Do we check if more people outside want to to join, or it's? Hmm? No, I think it's. Okay, welcome everyone. We are going to start the session because we have to keep a bit the time. So I'm waiting for the slides to come. Yes, so this is a session on return of experience, which actually is 2 back-to-back sessions before the coffee break and after. So next slide. Yes. So we are 3 on stage, 3 from ESA, myself, Catherine Morley, and my colleague Eric Joff and Kyle Palmer. We are working for different missions in ESA, supporting different projects, having different experience, and since also number of different years with different tools. So it gives a panel. We have organized a session in a way where we want to discuss more the problems, the issues we are facing to get a good introduction of MBSE in projects in the first place. So before the coffee break, we will focus on this, and the second part more on looking for solutions. In both cases, we will introduce a few slides, either of problems we are facing, and you had, some of you may have answered the questionnaire yesterday as well that we are using. And in the second part as well, we will give example of good return of experience that we have. But we will make you work also during the session. So you may have seen that we have flip charts in the room, and we are going to use them, which makes it a bit inconvenient for the people who may follow online. It would be just half an hour overall, where for the people online, you will be free to get a coffee, while here people will be working. So in the first part, we will discuss, I will present briefly the status that we observe at ESA in our project. We will present initial problems spotted also on our side, the feedback from the questionnaire. And then you will work in small groups on the flip charts. We are 4 in the room. So we will ask you to spread, to work for a few minutes all together, trying to really define the problems, and then to report to the audience until the coffee break. So let's get started on the identification of the problems, starting from the status of the project. So I've seen this slide already in several sessions yesterday. It is a status actually that we presented at past MBSE. We didn't update the slide. With number of projects. So you will see that actually Lisa has now moved to the right in practice. And the message actually we were conveying 1.5 years ago is that we are not progressing fast enough, deep enough in introducing MBSE in projects. So have we really moved from there? What we observe, you are not going to see a long list of projects this time, is that we have new projects coming in. This is very good. More and more people are trying to introduce MBSE when they start in early phases or also in later phases. We have projects continuing, still very good. When they move, especially we tend to have parallel contracts at the beginning of the project, and then we move to a new contract where we have a single contractor for really the development. So we have some continuity. But also what we observe is that we have partial continuation. That is, maybe you were looking at the full satellite, and then suddenly you end up with only a couple of instruments of your spacecraft, which continue with MBSE, but not all of the spacecraft keeps on this methodology. And you have, unfortunately, also projects which are stopping using MBSE. It's too much additional work, it's too much time, effort to invest, or it get the feeling it slows down the work of the team. And yeah, unfortunately, we have also this. So basically, the message is still the same than 1.5 years ago. We still believe we are not going fast enough and deep enough from what we observe in the projects we are running in the agency. So now Kyle will introduce the problems we identified.
So not to do your work for you, I've only got just, let's say, one of the example problems and tried to break it down in a way that we also want to see from the problems that maybe you'll identify in this morning before we get on to the solutions later on. So typically the one that myself, coming from future programs, always hears is why don't we do MBSE early enough? It should be started in the very early phases so that it can be continued and realized its full benefits in the later phases, so the adoption timescale. In principle, one of looking a little bit more into the details or of each of the specific problems, more or less comes down to each phase having separate budgets, separate timescales, and separate requirements. And that means that it's very difficult to have this continuity between early phase and late phase with MBSE. From an early phase standpoint, we normally have multiple competing contracts, sometimes 4, sometimes 3, eventually 2 normally when we get to phase A. But each of them is not actually selected based normally on the industry work. It's selected based on the science of the mission. So industry and ESA interface struggle to invest because it's not that industry decision whether it's selected or not. There's limited time, resources, and budget is always the one that comes up. So the investment opportunity, again, is low. Typically, phase 0, the contract might last 12 months, but probably the typical work that you get to do, the time you get to spend actually doing the work is much lower by the time you introduce the reviews and the documentation, which obviously is the main part that MBSE tries to alleviate. But nonetheless, the actual engineering still has to be done in these short timescales. And also rapidly changing requirements. What comes hand in hand with early phase is the requirements themselves are adapted and rapidly change. And the feedback we keep getting is MBSE can't keep up. So the requirements go through a full change, then sometimes the designs go through a full change, and sometimes the requirements stay the same and designs still go through extreme amounts of change very early in the phase, which is hard then to keep these MBSE models up to date. But on the flip side, the feedback from the sort of implementation side is normally MBSE should start at the start, because otherwise we can't be ready to kick off in B1 with the MBSE models and really ramp them up to the detail that's needed. They have to start from scratch. And from that standpoint, it only makes sense to do it at the start of the project, and then we reap, because it's in implementation, is where we reap the benefits of kickstarting and setting up these models. And of course, implementation, as much as it seems a long phase, is dotted with its own reviews and its own milestones. And therefore, in these chunks of time where people are working, they've got actually, in the end, short periods, again, where they've got to ramp up. So they've got to do the work very extremely fast. And you get this situation where you don't start quick enough. So you revert to the old ways of doing it. And then you always promise that after the next review, we'll get back to it. And then you see then you've got your next review coming over the horizon. And again, you revert back to normal practice. So this is the sort of exercise we'll talk about later that we want you to do, to really dive in and not just stop at the we should do things earlier or we should have more money, but really look at what the fundamental problems are at the bottom, so that we can start to address those with fundamental solutions that we can also implement. I'm now going to hand over to Eric for the very exciting results of the questionnaire.
Questionnaire which we have received the responses for and that we have spent the whole night processing. So this is the raw output of the tool. I will break this down in the next few slides, but first of all, thank you for the participation, because it was just yesterday and very short notice, and despite that we had quite a good participation, I think around 100 participants overall. So there were only 2 questions, in fact. So the first one was, in your experience, what are the main blocking points for MBSE adoptions? Interestingly, we've seen also that in the poster, we have quite a few posters addressing this. It's a common topic. It came up yesterday as well in the sessions. And we had a list that was already prepared by us, but we also had a second question, which was, okay, which are the other blocking points that maybe we didn't think about? And you see the algorithm here is not ideal for this question, so it was quite elaborate. We had quite long sentences. Fortunately, we have the full list of answers, and I think we will provide that together with a set of slides after this workshop. But I will show a few examples in the next slide. Okay, so the first question, in your experience, what are the main blocking points for MBSE adoption? And here again, we had prepared some tentative responses, and you could vote for multiple of them. So there was a clear winner in that case that indeed at least the first two were really about the method and the tools, MBSE methodology and the tools not being very well known by the project team members. You see the high percentage of voters here, in particular for the first one. Right after, the methodologies being too complex as well, goes a little bit together with the first one, but I mean, it's one thing that it is complex, it's another thing somehow that it's not known by the project members, right? So yeah, but it's really not far behind. Access to tools and toolbox, which I guess could encompass a few other things like, you know, infrastructure, but maybe also cost, which was one of the topics that came up in the quiz as well, was following. And then, okay, I'll leave you to read a bit after that. Reading and reviewing models, probably being a bit complex to grasp, you know, for system engineers. Segregation of information between customers and suppliers. Visualization of models, that came up quite a lot as well in the next poll, as you will see. Methodology to changing, and security, which only had one vote, but yeah, very much depending on the project, I suppose, in that case. Okay, so other blocking points. So there were many responses. I'm just showing you a few sample ones here. I'll leave you to read if you want. So we have actually used a little bit of support from Copilot and AI to process those responses late last night to make this a bit digestible, but there is a few themes that we have already somehow covered in the previous slide. Yeah, difficulty to adopt, training. Is it worthy? That was interesting as well. We didn't cover in the previous slide. No clear use case. Is it clear that actually MBSE supports always the projects in what they have to do? But okay, let's see. So in terms of kind of groups of themes, somehow this is what we came up with. So if you try to group this feedback into some categories, we have this pie chart here with, let's start from the top left, a big proportion of topics around the communication and understanding of the models. And then again about the tools and integrations, maybe infrastructure aspect, how to set up different tools in the different organizations. Cultural and human barriers, very important indeed, and I think we have all experienced this indeed, that there is kind of a natural tendency to not want to change in the way we do things in projects, so that's certainly true. And then, okay, training and time, that's true. That's something that also we see is very important. The need to train people to actually use these new methods, these new tools, costs, methodologies, and okay, life cycle integration as well was picked up. So this was an attempt to group a bit your feedback into these categories, but I leave the floor back to Kyle to now introduce the interactive part of the morning.
Okay. So what, as we said, we want to get your feedback. Again, let's say a little bit deeper than what we can get through the questionnaires, and really start to well, we want to address the problems. We've come up with the solutions this afternoon, so before lunch. So this morning, I should stress, is really about identifying, trying to get down to those very detailed, those very bottom problems, which result in the top level ones that I think we went through just this morning now. So what we'd like to ask, we have some flip charts around the room. There's 4 flip charts, a little bit of organizational constraints, but as well we encourage if anyone has any digital solutions they'd like to use, they can also do that. But we'd like to set you off into different groups, with one half of the room doing one thing, one half of the room focusing on something else. Firstly, I'd like to encourage if anyone's from the same companies or the same domains, maybe try and spread yourselves around the different groups, just so that we get a little bit more interaction in the groups and a little bit more diversity in the responses. Trying to think what way around we do this. So everyone on this side of the room, it would be great if within your groups you could start to look at what the sort of key and root problems are per domain. So what we mean is in adoption of MBSE for requirement management or platform design, instrument design, operations, AIT. So really looking at those the engineering disciplines and the works themselves. And then on this side of the room, then focusing really on the problems per phase. So where is MBSE adoption or continuation of MBSE use facing problems and roadblocks in early, mid, late phase as well, and possibly as well after launch if there's any experience to be pulled in from that. So what are the main things to do in the groups beyond just come up with the problems? So the idea is to brainstorm about the main problems which are invoked by each domain or each phase. I think pick the top 1 to 3 per group. And then we'd like then the group leaders to come that can be nominated, or the group spokesman, to come back to the plenary and give us a summary of what those problems are. We're going to then collate a lot of this feedback, the words from each speaker, and we'll record that and use that in the next phase of the workshop, where then we start to focus and try to look at the solutions themselves. So I think we've be ready to share for about 10:15. I think that's in about an hour. So maybe Yep. Yeah. So maybe we stop a bit early. We see when how everyone's getting on. We'll play it by ear a little. But yeah, that'd be good. I think probably if we can 5 to 8 people per group, I think it's probably a nice number. But we'll see how it works when everyone displaces around the different flip charts. So thanks. So I guess time to start, if that's possible. Thanks. Should have come up with some music for the background at this point.
It will become noisy.
Yeah.
Maybe you put back the previous slides with the topics.
Yeah. Back.
Yeah.
Yep.
Let's see.
See how we get on.
Yeah.
I leave that to you.
These 3.
That's a good number, right?
Yeah. They're doing the digital solutions.
Hi. Oh, really? Okay. Nice to meet you.
You could probably get away with turning it off.
Okay.
It's time? It's time?
Yeah, I think it's time.
Yeah. Hello, hello.
Cheers. Thanks. Hello. Hi, everyone. I think we're going to call it time about now. So we thought we could come around one by one in the groups with the floating mic and just ask for everybody's feedback. I'll put it another way. You have about 5 minutes to present. So you pick however many topics, 1 to 3, maybe 1 to 5, that you think you can fire through. So maybe we start with you then, if that's easier. Catherine's next to you with a mic already. So.
Right, 5 minutes. I'll do my best just to say everything quickly. So requirement, and because there's a couple of recurring themes we found as well. So we were looking at domains, problems of MBSE adoption in a different domain. So for requirements, we have seen gaps between the text requirements and then actual design / the model itself. There's this mismatch between text and then the precision that comes with MBSE modeling. And this is just a barrier because users can't conceptually in their brain understand how to make that transition, so they just don't start. Punkt. They just stay in the requirements management tool. For platforms here, so this is, I guess, in platforms in a satellite, we interpreted the dot point because we also had some launchers and other people in the team. Team knowledge, just fundamentally, team knowledge is, we could apply that to every domain, in fact, and it was on the early slides as well. But considering that a platform can be an established product or a product line that gets configuration, if you've got an established product and then you want to apply MBSE to it, it might be quite a complex product, and it's just a huge invest to build a comprehensive model that's going to copy, input everything. For the instrument, again, team knowledge is the fundamental barrier at the moment for a lot of us. And contrary to the platform, part of the challenge is every instrument starts from scratch, so to say. And then, okay, there's arguments against that, but the perception in management or whoever's going to pay for the MBSE modeling at the end of the day feel like they're going to have to start from scratch every time, and oh God. And then convincing individuals to enter information. So, okay, the preface to this point is one of the main advantages of MBSE is democratization of information and communicating to other people what I intend to do in the design. But to do that, someone's got to put the information in the model. So one of the big challenges is convincing individuals to enter information into the model for the benefit of others. So it's a tragedy of the commons problem, but that's a cultural thing. And it's also the problem with classical documentation anyway. No one likes writing documents. Ops, there's a language mismatch between ops and the engineering teams. They just think differently. The ops team might not be so technical as the engineering teams, which means that ops just don't use a model because the language in the model is engineering language. And ops tend to be involved far too late to be able to meaningfully contribute or add anything to the model. So they just, well, it's not useful to me, or I don't know how to interpret it or translate it. There's similar arguments for AIT as well. The Eng AIT culture, okay, AIT tend to be technical individuals, but there's a cultural mismatch there. You can see your model is made by engineers and not for AIT. It's not, the model is not created as a handover artifact for AIT. And AIT are not considered as the end customer or consumer. Okay, that's what I just said. Not considered as the end consumer of the model. So AIT don't see the benefit of using it for them. It's not been made for them. And finally, software. Again, similar, just a poor or informal stakeholder engagement from the start. Again, to have the model presenting something that is useful for them. So these last three, I guess there's a common thread there of models being created by a certain group without thinking who is my end consumer at the end of the day for the model. These are our ideas.
I just had one question. I think you, just to touch on maybe what you talked about, you mentioned the AIT not being the end customers. In your frame of the AIT, who's the end customer? Is it is it ESA? Are you developing an MBSE model for ESA to digest and to review, or are you or your idea is to create a model for industry to become more efficient and maybe not necessarily deliver that? Or
That is a
both
loaded
aspects?
question because there's ESA colleagues in here, and you come from Earth observation. I work for Earth observation, but I think it's. I'll give a personal take on that, not one representing. I work for OHB or anything like that. I think there's a general shift in the thinking of the people I'm around at work doing MBSE modeling from we're doing modeling for the customer for ESA to we're now doing modeling to manage our own costs and fix our own problems, and it's more internal. But it's generic, and there's other colleagues here, and they can give their own opinions as well. So I think traditionally a lot of the conversation has been around developing models because ESA is asking for it, or if ESA is not asking for it, we're not going to do a model. But we're trying to change the conversation now to our, not a customer, but a consumer. An internal stakeholder is who is going to consume this model and benefit from it. And I think that's a more sustainable argument to build internally. Yeah.
Oh, thanks very much. Yeah, perfect. We just had the request, if it's possible, can we maybe even wheel round to flip charts, but we can do the presentation down at the front just so those online can also digest the speakers. Thanks, Catherine. Is here okay, just at the side? Yeah,
Do you see it?
perfect.
Okay. So first of all, we have identified another domain, which is the mission, in which we have the mission analysis, the ConOps, the simulation, the life cycle. So we have found that the interoperability between all the disciplines is lacking. We miss sometimes a parametric model, such as the ranges, the variable, how they are interconnected. Sometimes it's better since the beginning to describe into a model, and we always miss it. Concerning the platform design, we find out that the trade-offs are not supported well, whatever the tool or method or approach we used. As soon as the system became complex, sometimes the model became more complex than the system. So we have more information, so it's even harder to understand how the system is working. The model product tree sometimes is not aligned with the system product tree because of different level of abstraction. So we found that the physical configuration is different from our Cameo or Capella model. And we have some huge limitation when we have to describe some domain specific, for example, the data bus, the wiring. Often the MBSE not support the design, so we don't have a digital continuity between our system level and the domain level. Concerning the requirement management, sometimes are the requirements feeding the model or the opposite, so we risk to double the information or to double the work. And the parameter and ranges are not often injected into the requirement. Concerning, so we spent a lot of time for this first topic, so then we had to speed up. So concerning the instrument design, sometimes the architects or the specialist don't believe on the functional architecture or the benefit of the functional approach, so we don't use it, or we use it in a very lightweight. On the operation, the model information, the functional information are not in the operational procedure or in the operation data. And the same problem we have found in IAT, because the IAT missing all the information, the function that we have identified before in the model. So yeah, these are the output. Thanks.
Any questions for the group? Yeah.
Okay. Take this one. When you send the operation, because the other flip chart was talking of a different language between engineering and operations, so is it also a problem you might see, not just on the functional, because it seems there's a discrepancy also of kind of language here, if I interpret correctly. It's not the right information somehow for operation and for AIT, and in the other group they were referring also to language.
We haven't spoken about the languages. It's like if we acted different if we are in two different companies. So we are doing our model, they are doing their procedure, and we don't talk. So it's missing a point of contact and some information inside the procedure. For me and even for the others, it's not a matter of different languages. We talk about the same stuff, but we don't communicate at the moment.
Okay.
Thank you. And just to add, maybe like here there is also a problem we mentioned before is that, okay, also we should put information about operation and NIT in the model, but then the complexity of the model grows even more. So maybe it's not the solution, it's more about interoperability that we mentioned at the beginning. Like we can model everything, but again, like is the model becoming more complex than the system itself? It's a question.
Good. Well, thanks very much. Maybe we move to the next group at the top. Oh, you're bring down there. Oh, thanks.
Is this on? Yep. Okay, so we were talking about the phases from our approach. I should say I'm not actually part of the space domain. I'm here from NATO to kind of observe and leverage your learning to apply in the defence sector. So obviously some of the terminology is different, but it was useful to be able to ask the questions about what was being faced here and kind of apply that to our sector. So apologies if I use some of the different language. But we started talking about the early phases, the concept kind of development phases. And I think the core thing that came through was, you know, if we abstract back to the big picture, why are we doing all of this? Well, the common learning is that if we put more effort in up front, we'll have fewer of the problems later on, where they're more difficult, more expensive, more timely to fix. But what does that mean? That means pushing more effort into the early phases, and these people don't get the benefit from them. They're separate projects, separate people, potentially separate organizations, and they go, well, I've got my project, I've got to deliver in X amount of time, you're telling me do more. I can't, it makes me look worse. So that's your fundamental problem in these early phases. You're convincing people do more up front. It's not actually in their interest. The benefits of all of this come much later. How do you tackle that? Part of it's a cultural thing. You need the bigger picture to recognize that we need to invest more up front and therefore, you know, give them the benefit of taking a bit longer, spending a bit more money in this phase. But also, as much as possible, don't make it more work, just make it a different way of doing things, a more efficient way of doing things. And that's, I think, the real core of it. So what do you need to do that? Well, I think for me, at least coming from my background, and it seemed to echo with other people, you need that common language. We're not saying build all these complex models up front. We're just saying be clear about where you are, rather than I'm talking about blah, blah, blah. I'm talking about blah, blah, blah. Where's the connections? I'm talking about that. Oh, I'm talking about that too. And you start building those connections. So high level, it's still models, but it's very high level models, and use them to identify where those sort of points of contact are. So that was the main thing I think we saw about the early phase. There was also this problem that everyone thinks they're special and different. We certainly see that in our industry. So when you try to build the common language, the common models, people go, don't really see myself on there, therefore I'm not going to use it, I'm going to build something of my own. And you go, well, we're not moving forwards if you do that. If it doesn't work for you, get involved, fix it, make it work for you, and then you'll get the benefits over time. Again, a cultural problem as much as anything. But to do that, it has to be more agile, because we certainly see these core taxonomies and so on, they've got like a 2-year update cycle. It's not good enough. It's not quick enough. So we have to fix those processes to make it more agile so that it becomes useful to people. If we move into the sort of mid phases and late phases, what we start to see here is we don't have, and you saw it in the comments that came up, we've not got the stuff to build on from the early phases, because the output of those early phases is bespoke models in different formats, PDF documents, Excel spreadsheets. I can't connect it into what I'm doing. So I've got to now rebuild these things to create the baseline to work from. Errors creep in from doing that, and certainly a lot of inefficiencies creep in from doing that. So these are the people that start to get benefits from the early phases being done in a model-based way. So that needs to be made clear so that it's incentivized and done. We also see there's a big problem still with contractual, the contractual basis of things when we start interacting with industry. Well, it's all still based on documents, and they need to be able to tie back to that. So changing those procurement mechanisms that recognize the model-based interaction and enable it rather than everyone pointing back to, well, the document said this. So we need that if we want the kind of agility in there. And therefore, we need the kind of tool integration and the language integration. Now, we can't force industry to use specific tools generally. That's quite difficult. But we can force them to comply with certain languages, frameworks, so that we can connect their input. And where possible, we create a framework that's not bound to proprietary languages, proprietary tools, so that we can easily integrate between outputs built in different tools. The core becomes some sort of open source framework that everyone can sign up to. What else do we see on here? Big problems, like I guess linked to that around, we talked earlier, training and the knowledge of people being a problem. We don't want a situation where ESA, for example, has to train the entire industrial base to be able to connect it. It's not practical, it won't happen. So you need to build it on frameworks that are open source, commercially available, so that industry and other partners can easily go out and get the knowledge that they're currently missing. Make it easy, make it open source, make it widely available on the market, and limit that bespoke local stuff to the absolute bare minimum that can be easily trained. We also saw a big problem around, okay, when we start moving into integration and test and the connection between design and development, integration and test, and the review of documents as we move away from PDF documents, that, you know, that old world where people come to a PDR, come to a CDR, here's your 1,000-page document, review it, put your signature on the front. And there's a lot of inbuilt trust and faith in that process, probably largely misplaced. But if I've got a document, I've got a signature on the front, then I believe that someone's been through it and knows that page 22 is consistent with page 714. It's not actually true. We all know it's not true. But then you move to a place where it's model-based, and we've got these complex models that you go into the tool and you can navigate around, but you can also very quickly get lost. Now you're asking someone to put a signature on the front saying that whole model is correct. Well, you can't read end to end and say stamp. What questions do I ask of that model? What's the process to go through that model and validate it? And okay, so really we move from, is that 1,000-page document correct, to are my processes for interrogating and reviewing that model correct? And the faith isn't there, then the confidence that that gives me the answer I need is not there. So you've got to work through that cultural mindset, and it's got to be built on something that makes sense, that's robust for reviewing things. And then I think the final point I'll make, otherwise I'm jabbering on for too long, the people side of this. We're also moving, another big part of why we're doing this is because we all recognize a huge amount of the knowledge is locked up in individual SMEs, people that have been around for a long time, have all the knowledge. They're the people putting their signatures on the front of these sheets. Now, we recognize that a problem. Too many single points of failure. So-and-so retires, so-and-so gets hit by a bus. We've got a big problem because all the knowledge is in their head. So we want the data in models. We want it in a place where we can hand it over, other people can look at it. But who's making the decisions to invest in this stuff? Well, it's generally those same people. And let's be honest, people are people. These people have the power. They are relied on. They don't particularly want to be disenfranchised to lose that power and that power structure. And it's not just individuals, it's organizational entities, substructures. So there's another cultural barrier there. There are solutions, but it's a lot about building the vision, building the case to get buy-in. And that people change management, I think, for me, sits at the heart of the success of all this, much more so than the processes and tools. It's the people and culture that's the big challenge. Thank you.
Any questions?
So I see you have not touched the last point. So the after lunch.
Yeah, just based on time. So in terms of the late stages, I do see there's a big carryover, not just briefly mentioned the connection between integration and test and design and development. The same is also true when you come into service operations and the ability to reuse things. You know, why do we need that connectivity? One, to make it more efficient and robust, but also so that I can take chunks out of it and reuse it, because I know, okay, that bunch of stuff has got those test results against it. Now I can pick up that block and reuse it over here without re-engineering the whole thing. If they're not connected through the model-based, I can't do that. The same is true service operations. Now, I don't know to what extent they're still relevant, but thinking in a defense space, and we've got command and control systems out there, networks out there, while they're in operation, in our case for potentially decades, there's learning and there's changes going on in service operations. Today, they're not connected. And you come to replace the system with something else, and you go looking for the documentation that's 20 years old, doesn't reflect all the changes of 20 years. I'm starting from scratch, so it's really inefficient. If we carry through the model-based approach and connect it through the life cycle, then there's a lot more benefits of enabling efficient reuse.
Because the point that I see is that for sure, for the space segment, the operation phase is a bit difficult, let me say, in the sense that if you identify an issue on your space segment, even if you have a model, there is very few things that you can do because you cannot go up. And unless you are not able to solve this, changing the software, for example, the onboarding software, probably it's difficult to solve the issue. While I think on ground, having a model-based approach and a model of your system is useful, because considering that you have a complex system, you can perform impact analysis, and having a model to perform impact analysis is much effective than having a documentation.
Yeah, absolutely. Yeah.
Okay. Any other questions? No, I think we can move to the last group.
Thank you. So I think I get the easiest job because everyone wants me to finish quickly, and also I get to say, as the previous speaker said. Yeah, again, we were looking at the challenges to adoption throughout the different phases, but one of the first things we sort of discovered in our conversation was there are sort of cross-cutting aspects here and things that transition from one to the other, as was mentioned by I think the first speaker. What's done in the early phases, of course, flows through to the rest. And we were noting that as we progress through these phases, for each phase there's a different focus, a different emphasis that our models need to address. So in the early phases, there's much more focus on trade-offs, establishing budgets and so on there, and then the architecture, and it moves forward to more of a focus on pinning down the details of the interfaces through to gathering the verification evidence and linking all that back to our design and requirements, and as we go back up the V there. So this is an important aspect that we have to handle these different focuses in the different phases there. Also, that as we progress in a project, the team size and composition and the parties involved changes enormously. So in the early phases, you typically got a small team working very closely together, maybe interacting closely with the user community. That team expands as you progress down the V, and then of course involves subcontractors there. They've all got their own approaches and challenges, and making sure that we integrate these and communicate, interface with between the teams and the parties and retain the knowledge is an important aspect there. So these sort of, we refer back to them quite a lot. So specifically on the phases, in the early phases, we identified quite early that, again, this need for trade-offs. In a lot of the time, our models aren't great at, or our methodologies for using them aren't great at capturing trade-offs and linking them through. So the fact is, we are going to have specialist tools. Good old Excel. I don't think it's going to go away, our favorite tool. But other specialist tools in general, we need to be able to integrate these together better, because the specialist needs aren't going anywhere, and so there will, I think, always be specialist tools for some areas there. There's also a need to make sure that there's the clarity on why we're doing an MBSE approach, and I think that feeds back to the first point about doing work that will benefit later teams there. And then a sort of a training and even specialist support in modelling in order to meet the needs of the systems engineers at this point. So making sure that the methodologies are clear and known to the team and the reason they're doing it. So they've got an investment into why they do this different approach there. So as we progress through to the mid and late phases, we identified a need to ensure visibility and configuration control. So visibility in terms of communicating across the various teams so that they can see the model and understand the model. As the previous speaker was saying, to be able to navigate a model is different from being able to navigate a document. Maybe not necessarily harder or easier, but people are more familiar with documents right now. We need to ensure the visibility of the model, but we also need to keep control of the configuration. Obviously, as we're progressing through formal milestones, reviews, we need to be able to keep a focus on that. Communicating the interfaces becomes more important as we're coming down the V, including for the test interface. And this is where we also may start to see a split of our model between the system level and some of the subsystems. As we start getting maybe subcontractors involved, they've got their own designs, their own approaches, and we want to make sure that they still tie up together so that we don't get discrepancies between the two. We also need to make sure that we capture the history of these design choices. This, I mean, in principle, goes all the way back to the start. And it was a topic we kept coming back to about this sort of a split between the as designed configuration and the, as we get later then, the as built configuration, or indeed different configurations to support specific tests, so test configuration scenarios and so on there. This is something where the methodologies for capturing these are perhaps not as mature as they are in other aspects, like interface design, for example. And as part of that, we need to understand the history of the design choices so we can understand if we've verified something by analysis, for example, in an earlier phase, but then something's changed in the design later, that we need to go back and re-verify that and capture that information. And indeed, as test results come in and the actual experience of the system in testing and ultimately in operations comes through, we want to make sure that our design reflects that reality, not just the theoretical design we had at the start, but the actual reality of it. And then I'm personally involved in ground segments in operation, so maybe addressing some of the points that were raised at the end of the last one there. There needs to be a handover of the model if we're going to continue using it, and I think there's value to use it in operations there, and particularly when it is on a ground segment or another system which is going to keep evolving over time. It's not, so as you're saying, space segment, you launch it, okay, the hardware's pretty much fixed, you can play with the software. The ground segment, my experience is typically the first thing that happens as soon as ground segment is handed over from development is we look at it, we say, well, that hardware is completely obsolete, that COTS software is out of support, we've got to re-engineer it. So we need to be able to take that model and update it. And again, this is where it's important to understand the as designed versus the as built baseline while we're exploring future options. And again, the importance of handing over the models from different teams and perhaps integrating models from different programs. Again, with my experience in EUMETSAT, we've got individual programs coming together, but they're using shared ground segment assets a lot of the time, for which we've already got operational models. We want to integrate these so the models are interoperable and we understand how it all works together as a system of systems. And of course, very important that we also want to take this and be able to reuse for future projects, so that feeding back at the beginning, we're not starting necessarily from a blank slate. We've got processes understood, and we've even got templates and reference architectures that we can refer to ease our work. And that's where we got to.
Certainly. Yeah. Is there any quick question before we finish? No? Oh.
In the early phases, one of the claims of MBSE is to be able to help to support the trade-off activity. That means that normally you should make as much as model as alternative you have in your trade-off. It's difficult to maintain one model, but if you want to make a trade-off, you should have as much as model as alternative you have. Did you address that difficult topic?
I'd say not directly. I mean, we addressed the fact that, okay, this was an issue that at least none of us in the group had a good answer to. It is tied also to this fact of being able to model and manage different configurations of the system. So the different options would be like could be different configurations of it. I mean, speaking personally, I had the experience where we've tried to model the alternatives, but then we have to collapse it back into a standard baseline. So that information tends to get not lost, but it's captured as a snapshot in a document, of course, a trade-off document that's referenced, and then you don't see it in the model anymore because you don't want to confuse people as to what is the baseline design. So I'd say, speaking for in our subgroup, we didn't have a feeling that there was a mature methodology for that we could apply as standard.
Thanks.
Okay. Okay, quick one, Stefan, and then we break.
What do we do with the results now?
It's a good introduction.
We are processing the outcomes. We took pictures. Yeah, we took notes, so we are processing. It gives a question of Kamal brings actually a very good point for addressing the solution in the second part. So I will invite you to come back after the coffee break, half an hour more or less, to discuss solutions, because we see topics coming in as problem in the early phases or per domain, like you were mentioning the trade-offs, difficulty to model it in the early phases, but we want to keep trace of things. So how could we address this or do it better than we are doing it today? So we reconvene at 11, our time here. So for people online, we might not be on the same time. Just watch out. It's half an hour break.
Maybe just a point as well for those online in the afternoon. I think we plan to do it much more of a town hall discussion style. So they won't be breaking into groups.
After the break. Not
after the break. Yeah. So it'd be a bit more easier for those online to follow, but also for your knowledge, it will be much more of a discussion with the groups within a plenary discussion about what solutions we think are best and bouncing off each other. So.
And of course, from the discussion of this before the break, we are trying to identify the top problems for which we want to look for solutions and discuss some solution in this town hall. Yeah. So recharge.
Yeah. earlier. Oh, did we check if we can keep? I don't know if the workshop's changed. Because we have 2 parts now. Okay, no one's cried.
No one has
No one is
No
coming
one's asked, so we leave it.
through.
I think it's good. We can then
We
leave this
just
up.
move them away from the screen, so
Yep.
that's it. But we'll distribute them with the slides.
I guess we give everyone a.
Because we cannot update the slides online. So we had to find another way.
Give everyone a few minutes.
Let's go. I'm not the first one, so.
Yeah. Where's I'll leave that up just now. All right. Yeah, if it's fine to leave it there if it doesn't work. I can go from here. So, thanks everyone for joining us this afternoon. I'll give a brief overview, let's say, to set the scene of some of the problems that we picked up from the discussion, and then Eric and Catherine are going to go through some of the, at least some success stories, or not so much success stories, but describing how we've implemented it recently in ESA, as well, for your feedback. And then at the end, we'll have a much more of a town hall exchange with everyone about how we think we can deal with some of the problems that have arose from the earlier workshop. So I'll just be very fast. I'll go through some of the things that came up. Basically we ran it through our friend AI just to try to condense all the discussions quickly, so maybe it's not fully captured. But one of the first point really, or first few points, are more the core challenges in the MBSE adoption, with requirements and modeling gaps being one of the primary points, where there's a disconnect between the textual requirements, the MBSE models, a lot of unclear ownership over the models and the requirements themselves, which make it difficult then to implement these things into our new MBSE tools, and with continued reliance really on the traditional tools as well themselves. Technology and tool barriers, again, very familiar to everyone, high upfront effort, with things like the instrumentation starting from scratch, or at least to perceive from management, the instrument will start from scratch every time, so why put in the effort every time? Poor interoperability between the tools is still being faced as a major challenge. And models can quickly become much more complex if you want to model everything, and sometimes the question's asked if they're more complex than the system itself. Cultural and organizational issues. So different teams speak different, I think we were calling it languages, but with engineering, AIT, ops, software development, which means everyone wants to interact with the model in a different way or doesn't understand the model in the same way, and makes it very difficult to share things between these different domains. Limited engagement. From here it said non-engineering stakeholders, so when I guess that's more when it moved to ops or AIT. And the knowledge is concentrated in experts using the tools themselves, but also experts in individual domains. And the last one on the sort of core challenges was early phase reluctance, with little incentive for companies to invest very early on, and therefore they don't get the long-term benefits that we tend to associate with MBSE. Looking at the life cycle as a whole, life cycle integration and reuse, going to a little bit in the previous point, but there's it becomes very difficult to reuse and constantly, because we're constantly adapting the models through the different phases of the life cycle of the spacecraft. Sometimes different teams, when they're passed over, prefer different tools or different ways of working, so the knowledge is lost from one phase to the other. It's difficult to configuration control and to find that traceability then through the life cycle, which is one of the major benefits that we see with MBSE. And models are not often updated or reused across the mission. So within the missions, sometimes the model isn't kept up to date, so then isn't used as a single source of truth. But also, how do we really reuse, when we have so many bespoke satellites, how really do we reuse the model that we get at the end of the phase E, and then somehow recycle it back to the early phases? Interoperabilities came up again here, and trade-offs. I think one of the points I thought as well was very nice was how really do we deal with all of the different configurations we get with trade-offs. Do we really model all these? It becomes very difficult and unwieldy, and normally then we just revert to a baseline solution. And especially in the early phase, speaking for myself here, that sometimes the trade-offs have got such distinct architectural differences, different instrument designs, different orbits and everything like that, then it becomes you're really modeling multiple systems rather than configurations of a baseline. Then the last one, really here, the last sort of theme was change in knowledge management. So resistance due to the ownership of knowledge. So I guess that here is when we have specific experts in specific subsystem domains not wanting to release or showcase the knowledge they have to everybody in the team as a sort of shared, and it becomes shared ownership. But also as well, I imagine it's those subsystem engineers being able to then introduce their inputs into the MBSE models is something that we're still struggling to get traction with. Need for data-driven knowledge capture and sharing. Again, it's just staying on the same sort of theme. And yeah, I think that's the rest of the points are going along that same theme as well. So that's a little recap from this morning. We'll keep the for the topic later. We'll keep some of the points on the flip charts if people want to refer to them later. And we'll just go now, I guess, to Eric, and we'll see some of the things that ESA are doing in this domain. Thanks.
Yeah, thank you very much, Kyle. So I will actually start with a short return of experience of the LISA mission, which is the mission I'm working on as a system engineer in the mission performance team. Which, as you will see, and that's the point I want to make, this is LISA has been a very special case. It's also a special case in terms of organization that I will introduce. And to make it short, maybe you remember in the introduction slide from Catherine earlier, LISA was there on the screen. And in phase AB1, in the study phase, we used to have two primes in competing studies using their own tool sets and so on. And when we moved to the adoption early 2024, so the project moved from the study phase to the implementation phase. And in fact, it should have been the case that by decision, project management, LISA should have stopped digital modeling, and no MBSE was foreseen. And so this is going to be a short story of the digital rescue of the MBSE for this mission, for reasons that I will explain in a moment. Okay, so I will start by giving a quick overview of actually the LISA mission, just one slide, and the project organization, which again is a bit special for ESA. Then focusing on the performance system engineering, which is what we are effectively doing in my small team. and the digital model implementation going with that. And some very early lessons learned. Once again, so yesterday we had a great presentation from Kamel showing the full experience from Ariane 6. We are not post-launch, and LISA is planned to be launched in 2035 if everything goes well. So we are very much in the early days of the implementation phase. So very, very early insights, and I hope, things that we can discuss afterwards based on this experience. But let's start with a few words of introduction about the mission itself. So LISA, in a nutshell, for those who are not familiar, will be the first ever space-based gravitational wave observatory. So today we have already ground-based gravitational wave observatory in the US, in Europe, so the LIGO and Virgo. This was the Nobel Prize in Physics in 2016 after the very first detection of gravitational waves in 2015, September 2015. So that was a major event for the whole community. And so it is, in fact, the next large class mission of the ESA scientific program, what we call the Cosmic Vision program. And in a nutshell, the mission architecture, so the mission consists in 3 spacecraft in a heliocentric orbit, so around the sun, either trailing or leading the Earth by around 20 degrees, and performing laser interferometry between the spacecraft. So we are basically going to measure with a very, very accurate measurements, distance variation between test masses on board the spacecraft. And we are talking about picometer stability in terms of variation of distance associated with gravitational waves, while the spacecraft themselves are about 2.5 million kilometers apart. So just to give you an idea of the kind of challenge, technological challenge that we have to face. So this is a very complex mission, very complex instrument. And again, we are just really now starting the mission implementation phase. Well, okay, a brief history of LISA. So this concept is actually not new. So the first idea of going to space to measure gravitational waves at low frequency, which is what we cannot do on the ground, dates back to the 70s with Pete Bender, who unfortunately passed away earlier this year. He was really one of the pioneers of the LISA concept as it stands still today. So you have a picture of the kind of space segment architecture that was conceived at the time. It's not that far from what we have today, but it has evolved quite a bit over the years. And as I said, in 2024, that led to the adoption of the mission by the Science Policy Committee. After quite a few years of studies, including at ESA in the CDF, there have been at least 2 different studies in the CDF for this mission, different architecture, different instrument design, and so on. All right, so this is what we have today. So we have a large international cooperation. So what you see on the screen is a kind of product tree for the LISA mission with a standard decomposition somehow. So we have a space segment, we have a ground segment, we have a launch segment, nothing really too fancy or original here. We have NASA contributions still on the table. This is, of course, a bit a topic at the moment, as you know, but it is still baseline, and there is funding for next year for the NASA contribution, in particular for the payload. They are contributing the telescope and the lasers, in particular. And we have a number of member states, so 12 member states involved in the mission, mostly what we call CFIs, the customer furnished items, contributing elements of the payload. What is maybe a bit less standard is the role of ESA, and you will see in the next slide. So you have the different logos on this one. LISA, it has been a decision to basically take a bit the responsibility for the overall system engineering of the mission, and in particular for the payload system engineering. We don't have a single consortium to which we ask to do the full job of designing the instrument. The system engineering is really done at ESA, and more importantly, for what we will discuss just after, also the performance management with dedicated tools developed and maintained by ESA is also something that has been put as a responsibility for ESA. So it's maybe a bit unusual, more commitment from the, let's say, more responsibility, more hands-on activity from the ESA team for this mission. And this is the reason that you have, here, the happy faces, a relatively large team. So I think it's around 30 people now in the ESA project team, which is a large team for an ESA project. So there is not many examples like this. So that's why I'm saying this is not a universal. This is just really showing the example of that particular mission. So this team is organized in 3 main groups. We have the spacecraft team, the payload team. I'm part of the mission performance and operations team. So for which we have a small group, let's say, of 3 people at ESA, but we are very much supported by a larger ecosystem of institutes in Europe. You see some logos here, but not only institutes, also our prime contractors, and there's one in the room here today, are very much supporting us in breaking down the mission performance. I will explain what this is exactly in the next few slides, and defining the right requirements for analysis, verification, and so on for really what we call the mission performance. All right, so mission and performance system engineering, indeed, what are we talking about when we say this? So I start with the specification tree. There is no good system engineering without a good specification tree at the beginning. So this is really the backbone, the hierarchical structure of our requirements set. This is the version from the ITT. So a few months ago, it's evolved a little bit, but basically what you see again, it's a relatively standard for science mission. We have the science requirement document at the top, which is basically our end user requirement spec, with all the science objectives turned into actual requirements, from which we derive mission slash end-to-end system requirements. We call that MRD, mission requirements document. And then we have specifications, let's say, made applicable to the prime contractor for the spacecraft. The prime contractor is actually also responsible for parts of the payload for LISA. But what you see in the middle, in the pink area here, is more the specifications applicable to the CFI teams, so different institutes in that case. And also we have the ground segment on the right-hand side. And this is just the ESA specification. You can imagine that this tree goes down further. The prime contractor has basically a full tree for their own breakdown of requirement specification, down to the supply chain of the solar arrays, the PCDU, all the subsystems that are needed to build a spacecraft. But in terms of ESA requirements and ESA specifications, you see a bit the magnitude of the number of requirements. It's not something that we are particularly proud of, right? I mean, I'm personally a supporter of as few requirements as possible, but we do end up with a relatively large set of requirements, around 10,000, 11,000, and about 40 specifications, set of requirements that are really managed by ESA, going deep in the payload itself, as you can see here, quite a number of specifications. So what is the LISA performance, so that we understand what we are talking about? Maybe this is very LISA mission specific, but so what we call performance for LISA is a breakdown of the noise, essentially, of the instrument and let's say the end-to-end system at the end of the day. I'm just showing you one plot, which is basically the performance for the free fall acceleration. So we have the acceleration noise acting on these two test masses that we have on board the spacecraft for a single link between two satellites. And if you have forces acting on the test masses, basically this will correspond to perturbations to the test masses, and then we cannot distinguish between spurious forces and gravitational waves. So what we are really trying to control is a number of categories of forces. You have here the 8 contributions to the free fall performance shown on this plot, and they are expressed in a weird unit. So we are talking about amplitude spectral density. All of this depends on the frequency. So this is not electromagnetic waves we are talking about, it's gravitational waves, but there is very different science that you can do in different parts of the spectrum still. So we have to, basically our requirements are expressed all in the frequency domain. And we need to meet these requirements all across the spectrum that spans from 0.1 millihertz to 1 hertz, which is very different from this ground-based observatory, which are more in the tens of hundreds of hertz, like LIGO and Virgo. And then, okay, we will see trees. I mean, this is something we have seen a lot. We call that arrows and boxes in previous talks yesterday. So we have a lot of that. So we were already doing that somehow before we started with our digital model. So this free fall performance, you see, it's broken down in these 8 entries. And what we do is that we assign responsibility to some of these entries, right? So you see the color code here. So the blue boxes are under ESA responsibility. Then some of those in green we assign to one of our payload CFI, which we call the gravitational reference system. And in that example, it's not doing justice to the prime, which is doing much more than that. But on this example, indeed, we have only one entry that is responsible for what we call dynamical couplings. So all the things that having to do with the control of the spacecraft, which leads to basically some acceleration noises on the test masses. Another example with maybe a bit more color and something maybe a bit easier to understand. This is an alignment budget with two parts of the payload, so the optical bench and this GRS I mentioned. And just also to illustrate that we don't only break down performance budget entries, but we want to associate that to actual requirements at the bottom. And also, in that case, parameters that actually feed simulations for bottom-up evaluation, verification by analysis, but we identify some key driving parameter that we need to control and that we want to track as well. And so I'm already showing you some graphs that start looking a bit like MBSE, but we were doing that effectively before with a large spreadsheet, a very large spreadsheet. So you see just a few examples on those two slides, but today we have around 1,000 budget performance entries and as many trees that can be shown as this one. So that was suboptimal, and in fact it was decided as we started to do this work a bit at the time when the Prime was doing their proposal sometime last year to think about how can we manage this complexity and to properly link basically this performance breakdown to parameters and especially also to requirements. So I've started to put some words here that we have kind of defined along the way, and that starts to define a kind of meta model, if you want, for relationships between those different items types. But at the time, it was really very much a paper exercise when we started this. So again, this was the motivation for actually, in the end, setting up that digital model. So this is something that came really more for the need to do this rather than impose from the top at the beginning. So we had this problem to solve. We wanted to track these parameters and link them together. For traceability is the main point, of course, but also indeed it's been mentioned before, change impact analysis, coverage analysis, are we specifying everything we need to specify? And all the nice features that come with also, digitalization in terms of version control, collaborative work, I'll come back to that, commenting, reviewing, and so on. So we did a bit of benchmark, and at the end we selected a tool. So we went for JAMA Connect, which was selected by the ESA project team after indeed some different trials, and it was good, seen to be a very good fit for our need. And you see an example today of what this looks like, and also some metrics in terms of items. So we have 20,000 items in our project, and a lot of things that are going a bit beyond the initial objective today, which was requirements and budget entries. But at the end of the day, we have incremented this model by other things. So digital implementation of our conventions document is generally a PDF we have for the mission, but this one we have decided also to include in the model. Requirements, budgets, but also parameters, mathematical model description, and a few things I will discuss a bit more later, which is verification and architecture models, which was not initially foreseen, but that I think we will start doing a bit more in a few months. Yeah, and the nice thing, of course, is that this digital model has become the authoritative source of truth for the ESA team and, let's say, more widely for the performance. Okay, very quickly on this one, indeed, along the way, we had to define kind of formal relationships between these different items types that we are manipulating. So I will not read everything, but just to comment on the few we have seen before. So budget entries to requirements, we define this as a satisfied relationships. Importantly, also the requirement verified by a verification item. But basically, each of these colored boxes corresponds to an item type in our model. And we can very much link all these things together for completing our traceability and change impact analysis and so on. Current and future work. So I've discussed a little bit about the performance decomposition and the requirements flow down, so which was indeed very much the initial sole motivation for this, and we started very small with this. And in the end, we completed that a little bit by some functional breakdown. That's something we have actually just started, with essentially the objective to support actual analysis. In that case, FMEA is very much relying on the functional decomposition and description of your system. So this is something we have initially started. And now we have actually passed the system requirements review a few months ago. And so we are really focusing more and more on the verification. So going up the V on the right-hand side here, with also relationships to all of these items, and that's, I think, will be one of the main benefits of this digital model when we progress to have kind of auto-generated VCDs and things that we've also seen yesterday that will greatly simplify this process. And yeah, I think why is this considered a kind of success story? You see, some of you will see that and they probably think, you have probably a bit reinvented the wheel by defining these items, relationships, and so on. But we have made this really tailored to our need. And I think what was really interesting is that even though we didn't necessarily expect this, we have managed to onboard very much the team on ESA side and beyond, so including now our CFI teams and the performance team on the prime contractor side as well, actually using and considering this infrastructure, their working environment, their tool as well. So that was not planned, but that's the, let's say, where we see the biggest benefits. So quickly, indeed, wrapping up, summarizing what we just saw and maybe triggering some discussion points. Yeah, LISA did not follow a standard MBSE approach or a fully fledged. We have had a very nice presentation yesterday, also from my colleagues on the ESA MBSE methodology, on SysML v2, all nice things that we would like to do eventually. But that's not how it happened for LISA. We started really small. There was this conscious decision not to do MBSE at the start. For all the reasons that we discussed before the break, right? And in fact, cost was one of them at the beginning. But we did not follow either classical design methodology, starting from use cases, deriving operational architecture, functional, logical, physical. We did not do any of this. Maybe the question is whether that approach is more adequate for early phases. That's a question I put to the audience that maybe we can discuss a bit later. We did not use SysML language. We did not use a formal language, actually. We just built somehow some simple items and some relationships definition. But it was considered to be maybe a bit too difficult for us, and we would have had difficulties to embark people in that exercise. So instead, we started small with a simple objective to ensure end-to-end traceability between requirements and performance, which we progressively then incremented to do a bit more things, favoring simplicity, user interface, some easy-to-use tools, and user-friendly modern platform. Of course, we can still do complex things with the model. We have an API that allows us to link this to our many analysis tools. You can imagine that these boxes I was showing you before for the performance model actually correspond to all of them a very complex physical models of the system. But the positive return is indeed about the onboarding, which was not necessarily planned with this. So as I said just before, so this is now considered a kind of working environment and platform for many stakeholders, both at ESA and externally. So just to wrap up, I don't know how I'm doing for time, but some lessons learned. Yeah, why I think this worked well. So we really indeed tailored the implementation to the needs and the context also, the special context of the LISA mission, rather than following universal recipes that we have seen failed in the past in other contexts. We've kept the model as simple as possible, even though it became more and more complex as we were progressing, but we really tried to keep it as simple as we can. And indeed, we have tried to embark different stakeholders along the way, not by imposing somehow, but more than convincing, demonstrating the benefits we will see in the kind of more digital approach to do all of this. And I think this has worked so far so well. Some caveats still. I mean, LISA again is very much in the early days of its implementation phase, so we'll see in a few years what are the actual benefits that we see, in particular for what concerns verification. And again, very special environment, very special case. So I don't pretend this is the solution. This is just a return of experience that may not fit all projects. And of course, I mean, the tool and model do not replace the system engineering work. There was discussion yesterday about complexity. It is there, right? So the tools really only facilitate somehow this process, but do not replace the actual work. And okay, last caveat about interoperability has been mentioned before. So you've seen all these interfaces, the institutes we are working with. So we have a lot of interfaces indeed for the space segment, for the ground segment, and Prime and CFI teams. and many, many tools. So it is still very much a challenge for us today. We do spend quite a bit of time to make this all work together, even just for requirements. There are many tools around, and this interoperability is something that we are really aiming towards, but still struggling a little bit today. I'm a bit late, so I'll stop here, but I think we will take questions after the presentation from Catherine, gathering feedback on anything that we've shown you. But yeah, thank you for your attention.
So now I'm going to give you another example trying to address a different issue, but to some extent also similar to the one that Eric presented because he referred to the onboarding. And we have something called the statement of work, which is the initial point when we want to place a contract, is to issue an invitation to tender, which contains the statement of work. We want to try to have MBSE kind of on a systematic basis being proposed in, by the contractors, by the bidders. Kind of default way of doing the system engineering. We want to move there. Now, if we don't request anything in the statement of work, what we are facing is that industry is not proactively proposing to actually do the system engineering with MBSE. They will propose the kind of classical still approach. They will do simulation in the corners, they will write description of function, and they will, at the end of the day, deliver documents. So came the idea a few years ago to say we have to incentivize industry to answer with MBSE. So let's do something with respect to the statement of work. The idea is to have already in the proposal something on MBSE. Getting something is not telling you, well, I will deliver you MBSE model HTML from an MBSE model, or I will generate my documents from an MBSE model. We want a bit more. Because then it's just a statement, and okay, we say, yeah, okay, they are compliant, but we don't really have a proof this will be done. So actually, what we prepared is a number of requirements in order to really verify that the bidders would be compliant and would deliver and actually would perform the task as we are expecting with MBSE. So this is a way we've been thinking of trying to incentivize industry to propose this. So that's actually two ways for us to request MBSE. We are using it especially for the early phases of the project. We have probably to modify it in order to address later phases when we go really to design phase and manufacturing integrating element. So we have the possibility to request a separate work package. Because our statement of work, there are a number of tasks or work packages we are expecting. With, of course, the drawback that then, yes, the system engineering will be done in one way, and then, in addition, someone else of the consortium will do the model, but might do then the model as a consequence of the other task. At the end of the day, and if there is no time enough, it gets dropped. So it's not really the best approach. Then we can also say, well, let's spread the MBSE through the nominal work. No dedicated task, we just inject it. So if you have a work package telling you you have to deliver at the end of the day a CONOPS, you put clearly that the work has to be done with MBSE, and the MBSE, the CONOPS in MBSE has to be delivered, and then the second task is about doing a design file, and the design file, you say it should be an MBSE file. Again, so actually, the key actors of each task are supposed to do MBSE. I mean, at least it's thought in this way. So to do that, we have also very few requirements. So one very generic which says MBSE approach shall be applied. And we expect in the answer to the ITT to see compliance to this. Then we specify who is responsible for the infrastructure. We expect that the contractor or the bidders would propose, explain to us how this would be organized, because normally it's not just one industry, it's several of them. So they need to tell us also if it's a single company accessing different people, collaborative work, etc. With the tools also, which are going to be used, because you may have companies who are not by default using the same tool, but for a contract they may agree to use exactly the same tools. We ask the system engineering tasks to be performed in this way, and very importantly, the content. So of course we have a problem of tools, because on our side we may not have the same tool as industry, so we go eventually to not systematically to ask for the native tool format. We try to make it and to have an instance at least to read the things. But it could be the HTML format is quite popular, but to some extent, and we have seen it in the problems, the native HTML that the tools are giving you are sometimes difficult to navigate with too much information. You don't really know where to click. So somehow you have also to be an expert of the tool in order to be able to navigate in the HTML. And we could also ask for some document spreadsheets coming from the tool. I've done it myself with Capella, with using M2Doc. So you decide what you export of the tool, but in the document then you can also select the information and don't see the full of the information which is actually in the model. So the advantage of getting it in the native tool or in a full HTML is of course you get all of the information which is in the model. So, of course, I was saying if different tools are used, we want to make sure that it's consistent, coordinated. It's not just a matter of saying, oh, yes, we have developed models and people have worked completely independently, not exchanging information between them, and decisions evolve over time in the project and they are not reflected in the other tool. So we want this as well. And last one of the requirements, so you see it's very few, with also all the domain specific afterwards, so which could address later phases, but it's just one requirement. It's still very light. Sometimes, like RAMs, could be integrated in the same system engineering tool, but it could be done also separately. So these are instruments we are putting in place as requirement, and we have also established a table. I'm not giving you the content here because it's too long, but basically it takes ECSS, the key deliverables we are usually asking, ConOps, design files, traceability matrices, VCDs, etc., and tells you what is the content expected in an MBSE tool, irrespective of the tool. So is it the description of the function? Is it the modes of operating of the spacecraft? Is it this kind of thing? So with certain level of details as a guidance of what we expect to see in the model instead of in a document. And this is provided in an annex to the statement of work, the statement of work being later on a contractual document. So applicable to the one with getting the contract. So is this working? As I said, when we implement as a separated task, there is always a risk that this is done by a separate person, and somehow it drops along the way and not aligned with the main task. However, it impacts the bidders, because when you request MBSE to be used, then the first thing is that, oh, we have to be compliant with these general requirements, how are we going to put this? Who is going to work in the project? So it stimulates industry, it gives a first order of magnitude of stimulating industry to think of doing it. Now, if we use the second approach, spreading the MBSE all along the way in the different tasks, it means also, because we are asking a first iteration of certain tasks in the proposals, so some tasks have to go also to some level of details, you have a chance to see actually MBSE in the proposal. First, MBSE diagrams, thinking of, for this mission, okay, they want to establish, if we would have taken Lisa, they want to establish this kind of things. There are 3 spacecraft, and you would start seeing a few diagrams with maybe the 3 spacecraft coordinates. So you have the feeling that some engineers knowledgeable about MBSE have contributed really to make the proposal, not just a task description. So it gives a second order of magnitude of stimulation for industry. So my success story, quite recent this year, I issued for phase A activity. We had an ITT open, received 3 proposals. 2 out of 3 did the job correctly by doing MBSE. The third one ignored completely. There was not even the word MBSE model in the proposal, kind of just didn't find it in the set mode of work, fair enough. It's not why they didn't get the contract, there were other reasons, but at least 2 out of 3, they were not only saying we will be compliant with the deliverables, but they were proposing tools, and we had a few diagrams in the proposals. So it was a good starting point. And then what happens is that when you, so one of the 2 went for negotiation, and then when you discuss at negotiation, you don't discuss any longer, would you use MBSE or for doing what? You discuss actually the details of the implementation, who is going to use it, how it's going to be organized in the team. So you get also, on our side, a level of confidence it's going to be used, and they really intend to use it through the whole activity. So now we just started 1 month ago. So I have still to see if it will work for the year of activity. But at least it gives a good starting point. We are monitoring internally some people who might not be here in the conference, because it's not, of course, the only set mode of work where we applied it. We are trying to get also return of experience on the way of we are doing it, whether we have to change requirements, to adapt requirements depending we address a phase A, a phase B. We have to see this kind of thing. But for us, at least as a customer side, it helps giving incentives to industry. It's not going to be solving all the problems. But we see it as kind of first success story in a way we could help things, being agnostic of the tool, because this is also the point. We are never going to impose a tool unless a certain circumstance for a certain project which is continuing and we have to reuse certain things has to go within one tool, of course. So this was the second example of good experience we are having right now. So I think now we are moving to the town hall part.
So now, as you see, now it's your turn. So the rules of engagement, or what we wanted to do, is as really now turn over the rest of the 20-25 minutes to yourselves. I think our idea is raise your hand if you've got anything, and that can be a question to the previous presentations, remark from this morning, or more interestingly, maybe your experience or your solutions or perceived solutions to the problems that we've discussed and identified, or maybe something a little bit more provocative where, I don't know, stop doing MBSE here, it's we've had the same problems for so long, or something like that. Feel free to be provocative. I think we'd be very interested both in the interface with ESA. What ESA is doing is obviously very personal to us, but also I think in inter-industry with subcontractors, I think that's still very valuable information that we can all learn from. And then we'll give option to respond from the audience. We have plenty of microphones. We'll run around and pass it round. So I don't know, turn it over to yourselves. Is anyone who wants to get us started? Who wants to be the, I'm like going, oh, well, that was nice and easy. So we've got one here.
The question is for Catherine. Do you think that the activity that has been done on the LISA project is compliant with the requirement that you have? The approach that has been used on the LISA project is compliant with the requirement that you have?
Probably not. Well, Eric might be better to answer.
Yeah.
I don't think so.
The question is, because in my opinion, yes, formally it's not compliant, but then they reach the objective. So the point, my point is that when you put something that right in the requirement, you have to use the MBSE approach. What does it mean? You have to use the MBSE approach. Because for me, this is something that could be really activity specific, no? If my objective is just to have the knowledge of all the requirements, not to invent, to create a full digital twin of my system. But at the end, I reach the objective. That's mama. Maybe what I can question is that I would like not to lose the knowledge. So my question on the latest part is that, okay, now you have done your work, your digitalization activity. How I can get this knowledge and eventually put in a model that will be used in the phase C and D?
So yeah, I mean, again, for the LISA, it was really specific. It was not in the statement of work, as I said before. It was the decision not to put it there, and it really started in that case from the ESA team for the purposes of performance engineering and this full traceability with requirements and so on. So that's a good question whether we would have complied to a statement of work formulated on ourselves. I will check the list from Catherine and do a compliance statement to some tasks. But I'm not sure that we would. I agree with what you said, that indeed. So it was very much tailored to the objectives. If
what probably would be to take the full table of saying the CONOP, the traceability matrix, you are not yet at the VCD level, to see if they would get this out of the model or the orchestration of the different tools, because you've seen in the last slide of Eric, it's not just one tool, it's then several tools, because the proof will be in a simulation done here and there. So it's several tools interacting with each other. Whether indeed they will get everything from one place, or whether there are still things which are in a separate place, and it might depend at the end of the day whether all the instruments, CFI and so on, are done using the tool or not, because the ESA decision to go for a tool, then I understand that some CFI went for it, maybe, but maybe not the full spacecraft will be yet with the same orchestration of tools, and then you will get a core, or maybe 80% of your VCD with it, but then you have a 20% you have to fetch manually from another place. Could be, so it's a partial compliance at the end of the day, but it's better than fetching, if you have 10 instruments from 10 different tools, and aggregating manually and then having inconsistencies. It's in any case better, so it's on the way to, and maybe the ones who are not applying it will see that they need, actually, it would have been better to do it as well, and they will embark. But it's very difficult, and on LISA it's so big, you have so many contractors, it's difficult today to embark 100%. In the activity I'm doing in phase A, you have 3 companies. Already they have to agree on the same tool. Okay, they did it, then it's only a few people. Do you do it collaboratively, or one after the other you access the model and the tool, so you share the access, but one is accessing in the morning, the other one in the afternoon to do the work? I mean, it's a question of organization. It comes also with the cost of the tool. When you address small projects, you have a lot of small companies. They don't necessarily have the budget for paying things, so come back to also the open source and things like that. So all this comes into the loop. So it's, when starting small, we can already learn a lot what works.
If
Then full compliance, we have to see on several. As I said, for the statement of work, we are doing an analysis because I think it has been used now in many statement of work. So we can have a real return of experience. On large projects, depend when we should indeed do the exercise to see if the large project would be compliant. But we don't have also so many large projects which are currently using MBSE or trying to use an orchestration between requirements, models, instruments all together.
I think just to add very quickly, I can't speak for all statement of works, but and something we also need to reflect on is normally there is the flexibility to propose a different method, and normally we have these caveats in our statement of works with respect to meetings and deliverables that here is we've moved from here's what you should do to here is what's normally done. And you're free to propose something different, which can then be discussed. So we do have this open door. One thing we want to reflect on is normally that's not taken up. So normally when we get the same people replying back, seems to be the feedback is let's stick to the norm to get the best benefits of being selected at the end. So it's one thing for us to reflect on. But there is that open door in a lot of the SOWs just now that allow that sort of basically that proposal of saying, okay, here's the SOW, it outlines what we think we want to do and what we want to do, but there's a little bit of freedom to say, no, we want to focus on this area, and then the negotiations, of course, is for that, but you have to get there first, you have to get to negotiations, so...
yes, this is true, but the point is that at the end of the activity, you have a deliverable, and this deliverable, in your case, is the model. And you have to think about that this model probably have to be let's say then provided by someone else that has to continue the activity with the model. Otherwise, the model-based activity will end. Let me see, no? It's just finalized to this task itself. So probably when you are writing your statement of work, you have to also think about the next step.
Yeah, but of course, what you will get out of the one who has won the contract is a model with a certain tool. And when we reopen open competition afterwards, you may end up with people willing to use different tools. So we might, of course, put a model as an input to next phase for the activity. The model would be in a certain tool. And I mean, imagine you have Capella and the one who is going to win is on SysML v2 based thing, which is not the Arcadia methodology. You don't have a direct transfer between them. So in any case, the new winner will have to redo something. Could get inspiration of the name of the functions which are there. Probably there's something you can speed up your initial model in the other tool you are going to use. But yeah, you're not going to reuse it. If the winner is also on the same methodology as the one who did the work in the early phase, then we could pass on the model. If this is not the same company, but the same tool and methodology being used, this could be done indeed. But yeah, I mean, it's never going to be perfect because we are not imposing a tool.
We go to some others, sorry. I think that corner was waving and here as well, so maybe we can move on. I don't know. So the gentleman from HP, if I can speak properly, yeah.
I think Kamala.
So there's a lot of questions here, so I'll try and be relatively quick. I've got a couple comments and then a couple questions. So first, I applaud the initiative to be quite concrete with what you're asking for in the statement of work. So the experience I have right now is essential to Next Gen Phase AB1 statement of work, and in there, if I recall correctly, there is a section on the benefits of MBSE, and then point. There's nothing asking for any deliverables, I think.
Depends how you use it. This is the point.
But there's nothing encouraging me to use it. If I recall, there's nothing contractually that I can pick up. I am using MBSE in Central 2 Next Gen, but I am not at all aggressively showing it to the customer. But this is a little bit unique to the specific situation at the moment, which comes to one more comment and then a related question. There was a requirement in there to guarantee consistency of the model. And that's a very big ask, I think, because there's not even a requirement in a standard SAL for guaranteeing the consistency of the documentation. We would all like it, but for sure it's not the case, and this is why we have reviews. And I think guaranteeing consistency in the model has the... I think there was another session someone said, how do you... Or was it this morning? How do you stamp the man from NATO? How do you stamp it and say that this is consistent? Is a guarantee of consistency, do I have to apply formal methods? Do I just have to have a bunch of SMEs review it? What does that mean? So, star. And then a couple questions is there a plan to extract this from the SAO into, say, an AD, a standard AD, so that we can start developing compliance strategies that we can reuse across projects and know that this standard AD is coming, for example, an addendum to systems engineering, ECSS, for example? Just question mark?
Well, I think for ECSS, one of the points is that it's written normally files. You deliver files. It's not even written document, but people have been using it for so many years, delivering documents, that they interpret files as document. So this is one thing. So normally ECSS is compliant, let's say, with MBSE, because a file can be an MBSE file. But the point is the ways people are interpreting and use to make it. So there is the idea. It was in the roadmap in the dossier we did last year, to have indeed an update. I would not like a dedicated ECSS on MBSE, because actually we want to do all what ECSS is already saying, but using MBSE.
It doesn't have to be an ECSS.
So it's to better reflect that in ECSS that the files could be MBSE. There is the idea to make it. It's clearly written on paper, but currently it has not started.
Okay.
But for example, the statement of work mapping a deliverable, you expect this kind of content in the MBSE, could be something we would inject somewhere in the, especially in the E10, which is the system engineering. It should be done, and
or an extra column in the DRL.
It would certainly help, because people would read ECSS in a different manner. Now there is also currently modernization of ECSS on which we might try to plug it in to go faster. But yeah.
Can I ask a quick counterpoint? Actually,
Sure.
Do you want ESA to prescribe how you use MBSE and how you deliver it in ECSS?
That's not what I'm asking for. Maybe I shouldn't have said ECSS, but a standard AD to the statement of work, so that I know the request is going to be consistent from one ITT to the next, so that I can have a standardized strategy that I can deploy over and over again, let's say, as it reduces the rework in a bid. I have one more question, then I'll pass it on, because it might trigger conversation. Is if I respond to this, how do I know that the ESA team receiving it is prepared to receive it, and I won't get 200 to 500 rids on how I've formatted and set up the navigation of the model, and that they'll be happy with it? Because in the past, I think we've submitted some MBSE documents back, models, documents, whatever, artifacts, and then hands are thrown in the air and we throw it in the bin and we go back to documents. So
I'll be interested in what everybody thinks here. I mean, I wasn't involved in the Sentinel-1NG statement of work, but I know for the most recent Earth Explorer programs, there was a conscious decision to step away from that sort of idea, because on the Earth Explorer 11 programs, we faced the same issue where MBSE models were delivered and not reviewed adequately, opened, or even continued from one phase to the next. So the idea was to give the power is the wrong word, but if you want to use MBSE, please use it. But you know, maybe it's not the place to be, is to exchange the models between us and an industry. And I think we're still in that learning phase about how we can do that to better increase our interface. But it seemed E11 was too early, so E12 we've taken a step back. Maybe Sentinel-1NG, that was the same feeling at the time. But yeah, so I don't know if anyone has some comments on that. Very useful. Anyone else's experience with
maybe
these
just to finish on the standardization, is because we have one opinion. Is it a shared opinion that we should maybe accelerate on the standardization, which is not an activity we will issue, it's more the working groups, because then, I mean, we have it in the work plan, just it's not activated. So is it a shared opinion we should progress on this?
Is this not what Osmosi and Space Ontology is trying to partially do, to define like some common guidelines and way of building a model so that...
Yeah, it's also not yet in the standard, the ontology. So it's also a document which is always in progress, never 100% finished and not standardized. So standardizing the ontology or putting it in the CSS is also part of a plan, but not activated. So is it necessary that it gets standardized, which is more my question, because even if not perfect, it's maybe better than not standardized at all.
Of course, I have a very clear opinion on this. No, but I do think I have one question for Eric in this area. Did you on Lisa, has there been done a risk analysis on the continuation of the tooling being available, because it's a very long program, so it's 10 years development at least, then probably 10 years of operation, where you want to have
that's a good
digital
point.
twin, and so and with a large consortium, you would want some standardization to be to mitigate the risk of losing particular tools and being really creating a project that's highly dependent on particular tools.
Yes, that's a very good point, and hopefully this is not too much the case. I mean, we have this REC-IF standard, and even though we are not only managing requirements, that would be my first answer, that we can rely on this should there be an issue with the tool. I'm looking at Carrie here. Nope, it's not the case. We are indeed relying very much on JAMA at the moment, but that's a very good point. We have indeed, as you say, a 10 years development as planned today, so we are just starting the implementation phase. So we are doing some, backups and everything as we should, but yeah, that's a question that we have. I don't know if I have a good answer for this now, but that's something that's on our mind, and we are trying to make sure we have interoperable systems as well. And yeah, as you said, long development. So yeah.
No, and the other thing is that the let's say SysML2 it was, let's say, too late to be deployed at when you started on this. Still, I think it will become probably in the next version, which should the 2.1, where the initial bugs are fixed and all the tooling is getting up to speed, including JAMA and every other tool. So this is coming. Also, I know there's work underway to export Capella projects into SysML2. So SysML2 is not constrained to SysML2 tools. It's a format and a database and a serialization that is completely standardized and captures, as far as I know, everything you need to capture, including all the parameters, the KPIs or budget type stuff. So it's all standardized there, and it will become available. So I would also want to contribute, let's say, for instance, doing an assessment on how to express what you have currently and do just the equivalent SysML2 model.
That would be very much
for me. It would not be a lot of work to do that, and you can just see what it would look like and how you could use that to mitigate the risk of losing data.
Thanks for the feedback. That's very interesting. I think we should invite you to give a talk to our management.
We can talk.
As you've seen for Lisa, we have really started bottom up from a need, and we have built this as we go. So we are again in the early days, but definitely, as I said before, I think with some of the things we've seen in this conference and yesterday.
And another thing for Katrien is are you aware that there's a model-based acquisition working group in OMG and let's say internationally doing this, and a lot of work, exactly this kind of work to put it into the statement of work for the ITTs is going on in US Department of Defense, well, Department of War now.
We know, you know that we are also not part of OMG, so we are not contributing actively.
No, but it's useful to have a look at, because they have very similar documents or very similar policies trying to enforce or not enforce, to engage.
Stimulate
and engage, let's say, the contractors to start doing this and making sure that this is future-proof also for this very long-running type of projects. But I can provide you the links to where this information is if that's interested.
Kamal had a question since a long time.
God, I can't actually see.
Okay, thanks. Juha-Pekka, Metacase. I don't think that the SysML2 will be the solution. There will be SysML3 and so forth in a longer period of time, and no single language or meta model would be a solution. But that should be clear. However, to address the tooling requirements that were in the requirements document, that the tool should provide native format and an HTML format, and also to allow models to be applied in future projects, I would like to propose a new requirement there. That would mean that the tool should be open so that there is no lock to any particle tool. So the tool should always allow a way to extract those models to some other format, whatever format that might be. And that will then enable that the models created will have a life afterwards as well. And they are not locked to any particle single tool, which nobody likes to be locked into a single tool. Or single meta model either. Even though XML version 2 advocates don't like this comment.
Thank you. A few comments on the questions. There is a lot to say. For me, and I think we share that, MBSE and the tools are not an end. It's a mean. The end, I think, is in two of your requirements, saying those are the deliveries I'm expecting, and the content of those deliveries, and, as said before, all that stuff shall be consistent. So then the question is, how do you, which means you put in place to ensure that all that stuff is consistent? So whether you take armies of quality guys, reviews, and that will cost you a lot, or you deploy MBSE. So first, and then coming back on the question regarding the reads, I think we shall distinguish the deliveries, which are on which we can make reads, or FEPs, I don't know how we read the term, remarks from the customers. We shall distinguish that from the content of the model. For me, you can review a document and have comments on it. Maybe you shall not review the details of the models and have questions of on each single artifact of the model. That's a proposal. Regarding also the standardization, I have one question. Would you, I think your landscape is very wide, so you have a big elephant, Leonardo, Airbus, Thales, okay, and you have startups who have different problems. The big elephant have maybe already tools in place, it maybe not consistent inside the company, and the startup have nothing. So my question is, would you evaluate the same way all that scale? And my other question, coming back to Lisa, just one question for qualification. Are those 3 satellites the same definition? Okay, so yes. My question is, how do you anticipate? Okay, same definition.
Yes. As per requirement. Actually, I think the requirement is, and I'm looking at our prime contractor here, that they should have the same interfaces to the CFIs. So we have moved a bit away from the it's restricting too much the design, but they are identical. Yeah.
Okay. So you have at end of phase B2. So yeah. if you would gather everybody contributed to Lisa, you would be able to put them in this room.
No, I don't think so. Yeah, no? Everybody contributing to Lisa would not fit in this room, okay. I'm afraid. Yeah.
But it'd be worse after.
Yes. Yeah.
So my question is, how do you anticipate the change of scale? And do you integrate in your framework the fabrication dispersion you will have between those 3 items?
Okay, that's a very good point. So indeed, what I presented was really we are still on the left side of the V somehow, right? So we are breaking down performance, and there, in doing that process, we assume that by design the satellite will be identical. We have 6 test masses, 2 on board each spacecraft, which we assume to be identical. In the breakdown and setting of requirements, we make those kind of important assumptions. Then for bottom-up verification, and that's where these kind of small bubbles with parameters, and as was presented yesterday, we have not one big V, we have multiple Vs. We are dispersing for now, basically based on analysis, so some of these parameters to do by modeling, right? Bottom-up analysis and verification of budget entries / requirements. when we will get, hardware, EM, will start to do some EM testing later this, early next year now, including for the GRS that I presented before. We will get some, so that will be a new challenge for us, because indeed, what even, this product tree that we are seeing before, yes, we have 6 GRSs, we have 72 QPRs, quadrant photodiodes, for measuring the light on the spacecraft and so on. So this issue of the complexity of the model when it comes to the actual physical hardware will come. That's not something that we have really started yet, but that's very much a challenge we are going to face. Yeah, that's a good point. Yeah.
So just to answer on the evaluation, I think we're doing it in a fair way, because in the activity for which I issued the requirements, the winning team is led by SME, with contribution from a prime. And in one of the 2 others that failed, that was one of the big ones, which was prime contractor in that case. So I don't think of course, the winning team, which is the SME, relies on an open source tool, because this is affordable to them, and the other one providing the infrastructure to the other. So I think, at least for early phases, where we have indeed some proposal coming with the LSI as prime or SMEs, it proves to work. When we move to big contracts, usually we have also big companies as primes. So I think then we will also find an infrastructure. It's more whether the prime then is opening its infrastructure to the smaller companies contributing to the contract. While when you have an SME as prime contractor with contribution from one of the big one, the SMEs are quite open. So we face less difficulties actually with them, providing they have an open source tool, which is really the fact, because they don't want to invest a lot in tooling.
Would like more standardization, and the big one less standardization?
The big one for sure are asking for less standardization. The small ones, I would not be so sure. I mean, also in phase A, we are taking ECSS in a light way. It's more reference. Actually, we put it as reference material and not applicable, because we accept to deviate. I mean, we are looking whether the mission is of interest, whether it's feasible. We don't want to constrain ourselves with too many deliverables, whichever format. We are interested to see if there is a solution, if we have to de-risk activities, whether we can make an initial mission in a few years from now. The problem is not really on, we know we will have to find the money, reissue an activity to do something much bigger. And then we will apply ECSS or a tailored ECSS to make the mission. Yeah.
I think it's a special point which we always talk about MBSE being compliant or not, or the things we're doing being compliant or not, but the things that we always associate with having full compliance, i.e. ECSS, every project has a specific ECSS tailoring. And in the end, we're not fully compliant to ECSS on any projects that we do. So I think as well, that's the mental shift we have to make with these things, is that we can't aim for full 100% compliance, because even when we want it, we never get it. So I think that's one aspect as well we can reflect on, I think, here in this room. Yeah, I just want to check quickly, because the timer says +7 minutes, but I think we can go to 12:30, right? That's the agenda was 12:30. Okay, so I was just making sure I wasn't keeping anyone away from their lunch break. Okay, good. Thanks. Sorry. Here.
Thanks. Yeah, thanks. So I come from the modeling world, not from the system engineering world, and I see a weird thing happening around me. So a big pillar of modeling is actually reusability, right? And I see all kinds of projects all doing MBSE in kind of their own separate bubble way. And my question is, how feasible is actually proposing something to, I don't know if it's either ESA or overall to the community, proposing stepping back a bit and actually defining a common language and common processes, and then using these common languages and processes with the projects. And from like when you have this language afterwards, you would actually extract the model part from every single project, and then you would have one common language where everybody speaks that, and you can reuse that and accelerate further on with every next project would be based on that and accelerated immediately.
For me, from purely the early phase point of view, I think that always becomes very, very difficult because every mission at that stage has its own specifics. Some at very early phase have very robust requirements. It's known what it wants to do. It's being built on heritage missions, and there we have a very firm requirement base, and you can do these things very well. And some the focus is on instrument design. Some is the focus is on mission design. LISA is very peculiar in its design compared to any other satellites I think that we've done. So typically the roadblocks we face is because different tools are good at different things, and trying to standardize the tooling and the processes fundamentally then assumes that we'll apply it in a standard way, and I struggle to see how we can do that with the breadth of missions that we consider, even within Earth observation itself. But that's just my opinion. I don't know.
No, I agree very much. I mean, what I was showing before is maybe a bad example in that case, because indeed, very specific. We were not using standard techniques, methodologies, or tools, and so on. Maybe, I don't know if you went yesterday, there was a nice presentation as well from some of our colleagues on the easier MBSE solution, which was really neat about the semantics. So the question is not so much about necessarily the methods and tools, but at least the language, right? You said something like this, and I think this is still being developed, and okay, there is also the CSML v2 and so on. Probably this is something that we can tend towards, right? So as a minimum, and that will already be a big step, I believe. So, we know what the requirement is, function, product.
Which is the osmosis work, which is supposed to be standardized as well and never completely finished. So as I said, things are there. The point is, if they are known from some people, but if it's not in a standard, then they are kind of not used by the one developing the tools and everything around, which makes, somehow if we don't have a way to comply or to be able to ensure people are compliant to this, it's in the middle. And even on our side, on the ESA staff, we are a lot of people in many different projects, and not everybody is aware and understand what it is. When it becomes part of the standard that you are supposed to apply to your project, you look at it. So that's where maybe it's a good thing that we would accelerate standardization, that we're strictly not doing. We are talking about it since several years, and we are not putting it. There's always an excuse not to do it, which is cost, time. Someone says it's not priority right now, or it's not the right time to update this CSS volume or whatever. So always a good excuse, or it's not 100% ready, so we don't go for it. But if you wait to be perfect, you wait forever. And you never do it, and another tool, another CSML v3 will arrive before. No, but this is what. Yeah.
And I think linking back to maybe the other question on how we review, because that's our interface, is how we review these models in a standardized way. The reality is we're also, I think, on both sides of early phase when we're setting up these things, we're both small teams, and we know we have the learning curve to learn how to use a tool or to accept a model, but I think we won't move on until we have internally a way to access these models, which is standardized. So whether that's one tool or one way to do it, because I think it's unrealistic if there's 6 of us in the future programs team in ESA, we operate with 3 large primes. And within those primes, I think it's fair to say, not always are the primes using the same tool themselves. So depending which country you go to within that prime, you tend to, and even within the same country, you tend to sometimes see that this team is more familiar with using JAMA. This team has been using Capella for 10 years. And they have different, not only within the tool, but also the parts that they introduce it in. I'm using it for requirements management here because I like it, and or Capella, I'm using it for functional architecture in this program because we think that's the best use of it. So it then becomes difficult for us to accept these deliverables because it's impossible for one of us to be skilled in all of those domains and all of those softwares. And I think until we have that.
This is also why in the questionnaire that we put out, I think came out of the answers that reviewing the model is one of the difficulties, or the usability of it, because you have different level of expertise in modeling, from the one which really knows all the details of the tool, all the tricks, knows to model plenty of things, to the person and the project managers who want to just get an overview. And we need a different level of abstraction, and today it's not fully there. You need to have, or when you get the HTML, to know how it is structured, where to click in order to find the information you are interested in, because maybe the links are not sufficient. So already this part in reviewing is a difficulty today. And you don't necessarily want to have everybody accessing your model. Yeah, you can set up viewpoints, but they have to be to the level. I faced it myself in Galileo in the past. Even the simple model I had in Capella, where I thought, no, they are too complex, or I don't like these arrows, or this should be another color because we are used to. Okay, it's never according to what a certain level of people in the project wants to see. And the bigger the project, the more opinions you have. So we are facing this. So at least having easy views for an easy way to see different views of the model, different views of the same thing, rather than saying, okay, I have to filter out this, and now I have to change this and that, and do plenty of clicks to have it a bit more automatically, might help, but it will not be the final solution either. We need also to have more people ramping up on knowing what a tool can do. Certainly, so I think from the questionnaire we get also on this, but if the tool and the models are too complex, people at some point it's too complex, so I don't want to see it any longer. I don't find my information. While when I know I have to go through a chapter in the document, I know where I have to go. So how do I find the same guidance in a model if it's getting too complex? When you have many pages, that's it. You go to the, you can still count and see the page you are interested in. Yeah, but it's on the use of the model. If the model is used just to build a model and not being used, it's useless.
You have to try to set up your viewpoint or your, I don't know, template for exporting information related to the review of some specific competence. Because this is what, in the end, the model may help, because instead of providing you a document of 300 pages, maybe I can provide you just a subset of the information that are the one that you really need based on your competence. And this is more effective, no? So it's a winning
for
point.
The usage, but it doesn't prevent. I really face it in Galileo. You have many information. When you want to have the information about a certain part, you extract that part for the person. Whether you export it in HTML, you put it in a submodel, whichever way, or in a document even. But still, the full model is big. It contains so much information that people who have not been creating the model, who were not involved in creating the model, are lost. So you can never provide to anyone the full model. I don't know if Kamal, you also might have this experience with IN6, which is super big with many things. It becomes so big that nobody is able to go through every single thing any longer. So it's too much, which comes to more, maybe it's better to have smaller model interconnected to each other, same tool or not, rather than a big one. But at some point, if you want to have a single source of truth, you want to see also how they interconnect at a certain level of abstraction. And today I find myself difficult. If you don't have a tool that provides you this, you hesitate also to use a tool. If you start saying I have to use plenty of tools or some parts will not be interconnected, yeah, you are missing something. So there's a trade-off, but we are not, when we are in a project, we want to run with tools which are existing. We are not at the same time building a tool or building new views. You want that it's there, that it's offered to you. So it's matching the expectation on both sides, which is, I think, difficult.
Hi, I'm Evelyn. I'm from the small satellite and IOD/IOV section at ESA, so not big missions at all. I just wanted to add that we have done some ad hoc model reviews in some projects where it's really dependent on the company, and why the model was there for review was because they were using it in their internal processes. So they still generated the artifacts that Catherine mentioned in the beginning from the statement of work. The model itself wasn't for review, it was just there to support. And what we also have been talking about the past couple of weeks is how we can actually review a model, but it's, as Catherine said, it's impossible if it's too complex. The same way, if you want to review a FEM model, all FEM modelers do it differently, which is why we require that when you deliver a FEM model, you deliver a model description, which is all your assumptions, all the model checks, all your validations. These are things that we might need to have to do an actual model review. But to begin with, we just need the artifacts. We want to see that you're using MBSE for your system engineering processes. And then maybe we can help the model to extract some of the information, but it's going to take time for ESA personnel to be trained, for the industry to be trained, for SMEs, for LSIs, for universities and projects, like it's going to take time. But I really hope we can get there. Like we have to work together. It's not going to be there tomorrow or in 5 years.
What I found very useful in the past is actually to do project team training as well. That is, when you work in a project, you have all the project team adhering to the same basis and way of working, because then at least you put the project contributors on the same page, which gives a consistency on how the model is going to be built. Now it doesn't solve the problem of the reviewers, because the reviewers are not knowledgeable. So you might expose the methodology you have applied, and to say we have used this to develop this part and this other part. So at least it gives some guidance of the information you will find and for which purpose it was used. But I think, as we said also in past MBSE conference, a model has always to come with a purpose. You model for a given objective, which actually match with also the set model work point, which is we have objectives for the activity, we have objectives for the different tasks, and for the different deliveries, the level of depth we want to go, and this kind of thing. So you should have an expectation of the level of MBSE or the type of things you want to see. If you want to see a functional thing, if you want to focus more on the interfaces. So it gives a guidance on what, but then the way of using the tools and the way of developing a model for exactly the same objective might differ. I fully agree with them, from one person to the other, even in the same company.
Thanks, appreciate. We're starting to stand between people and their lunch. But a few observations from my side. I think the crux of the conversation has come down to how much do you want to standardize things, prescribe things, in answer to the question. Why? Why do we want to do that? Well, we're looking for 4 or 5 C's. Fundamentally, we're looking for coherence and completeness. We're looking for consistency, not reinventing the wheel. And we're looking for clarity, so that people understand each other fundamentally, arguably compliance as a 5th C. Now, 2 of those are fundamentally about driving the completeness of the model, the coherence of it, and how well the pieces fit. And the other 2 are more about efficiency. How do we make the process, stop reinventing the wheel, and people not going back and forth because they don't understand each other. Now, how far do you standardize? I think it's really important to differentiate the different aspects. There's standardization of the methodology, the approach, the process sort of steps side. There's standardization of the fundamentals of the language, so the frameworks. Are we using Archimate, SysML, those basic structures of language. Then there's the language itself, the enumerations, the ontologies, the taxonomies, and then there's the tooling. Each of those may have different levels to which you want to standardize, and it's a fine balancing act, because if we don't standardize at all, it's complete free for all and a complete mess. So we know we need to go down to a certain level. But if you over-prescribe and over-standardize, okay, you get the benefits of it's really consistent, people can follow the process with not reinventing the wheel, but there's a really high level barrier of entry. It's difficult to get your head around all this stuff. So newcomers, it's very difficult. And it's also, you've removed the space to innovate, and you've removed the space to deal with those nuances. And by the way, there's a lot of work involved in doing it. So finding that balance is really tricky. Now, I would say that the balance has to be lower, further down, than just saying do MBSE. Because if you just say do MBSE, everyone will interpret in different ways and it'll be a mess. So I kind of agree with the assertion that you need to push further. It is important that we have some kind of directive guidance that says a little bit more in each of those areas, but you've got to be very careful to go just far enough to enable those benefits of coherence and consistency without removing the ability to innovate and making the barrier for entry too high. That's a balance that's got to be found, but something is needed.
Last one.
A final point down here, yeah, or final 2 points. Let's say final 2 points, and then we can close for everybody's lunch.
Hi, Meinte Boersma from DSL Consultancy. I have a bit of a trite follow-up question for Catherine. As a way to stimulate bidders to embrace MBSE, have you considered adopting MBSE for formulating the statement of work? In other words, do you publish the statement of work as a model as soon as you tender it?
This, I think, have been discussed among a few colleagues, but we are a few people sufficiently knowledgeable about MBSE, and we cannot spread our wings in all the statement of work. There is a point to say, maybe not for early phases where we are looking even for which what is really the relevant use case, and have things which are okay. We want to apply MBSE to see your concepts, but it's not really a defined mission. This would be difficult. But I would think, for example, for LISA, when you have the outcomes of the phase AB1 already, you could indeed have conceptual model in the future ITT for the B2CD, because you can start from it. But then when you have parallel contract, one has worked, I think it was Cameo and Capella, the two tools in phase AB1. Which one do you choose? Or which one do we have available or knowledgeable in the LISA team, in the ESA LISA team issuing the statement of work? So do we make a preference among them or not? I think this question will also come on the table, and because there is a risk. I mean, we don't want to push, we say we favor one or the other. So there's also the level of depth in which we can provide a model as input in those cases, which has to be discussed, and whether we do it probably we have to do it in an open source to also allow everyone to pick it up and at least to look at it, to read it in a native tool. Otherwise, we have to provide an HTML.
We had
so that everybody is going to be able to read it, whoever they put in the consortium. I think there is also difficulty there. It has to be accessible. It's not just to give a model. It has to be used in a certain way to answer the ITT.
We had a this is probably a bad example, but we had a small thought in discussion internally, which we might pursue, but every time we write a SAU, a lot of the work package descriptions can be copy and pasted, the meetings can be copy and pasted, the tasks that you ask for have to be in certain deliverables, so you then have to have a different deliverable set. And we were thinking, is there checkboxes that we can use? Oh, I want a standard phases 0A, and I don't need this, I need that, and then suddenly you've got all the WPDs and the meeting schedule and the stuff generated. So we've had some thoughts on it, but nothing too advanced. But it's a very nice point. And then I think we could put a disclaimer made by MBSE or something at the bottom and show at least we're trying. Yeah.
But it's true. Yeah.
Excluded.
But it's true that today when we want to put a diagram, even if we have it in whichever MBSE tool, at the end of the day, we go back to Visio and we put an equivalent picture in Visio in the same mode of work. It's true. It's the way people are working today. And probably this could be a first step to change things.
So I'm going to go back because I'm looking at the time and I think we're quite over. So what we had put, this is going to take a while actually. Can you put it back to just the slide with our names on it? Is that possible?
The very first, second
slide,
one.
second slide.
One.
I didn't realize how many animations we had. So I think thanks everyone. I think primarily for the discussions today. What we wanted to do was invite you as well, because we hope that it would be a lively discussion. There's probably been many points made. I think maybe we deviate a little from the solutions and more dug into more of our bugbears. But I would encourage you all with more of those difficulties, and if you have any specific solutions to get in touch with us. Our emails are here. I think we'd be really interested to continue the discussion after this workshop based on the workshop. And I think our plan was to pull all this feedback together that we've had just now and earlier in the morning, and write a short report and everything, just so that we have something that lasts, and also something we can reflect on, because we're really keen to use this feedback as much as we can in our different domains. So that's where we sort of see it going. So I please encourage you to do this. I already had the idea that maybe we can issue another questionnaire, because I think we had quite a lot of very good points and good suggestions and strong points. And I think it'd be very good, as you tried to get, is an agreement or a disagreement and a consensus in the community about each of them, so we know where we as well should focus for a sort of roadmap of the future. So again, I just want to thank everyone, and hope you all have a lovely conference and a good dinner, a good lunch. So thanks.
Good afternoon, everyone. Just to remind you for the placement in your appropriate session, it's based on the first letter of your last name. So for the people in the room here, your last name should start with Alpha to Foxtrot. Otherwise, you should be in one of the other rooms. I'll keep the slide up for a minute. It's only relevant for the first session because after 30 minutes you will change anyway to the next room. Can we do the chime again, please? So this is World Cafe Interactive Session 1, Track 1. Your last name starts with A to F, then you're in the right place. Don't worry, you won't miss anything. In the next 30 minutes you'll see another subject, so don't worry. Ah, yeah, the K, the typo here. They can make up their minds, they can go to anyone. That's what you get when you make slides at 4 a.m. in the morning. It's not advisable. Okay, enough fair warning. I think it's about time to start. I will give the floor to the organizers of the first track, Samuel and Anthony. And I'll give you back control of your video screen.
Not sure this one. Oh, it's working. Fine.
So, hi everyone. So, my name's Anthony Walsh from ESA ESOC, and I'm here with my colleague Samuel Rocher from OBO, and we'll be leading this this session.
Welcome.
So the topic is towards the adoption of SysML v2 in the space community. So actually, it's not a misleading title, but if we go to the objectives of this session, then the focus is very much more on having a discussion about the GSEF tool that is being developed at ESA, which is basically going to be a community tool to support SysML engineering, basically a SysML v2 based engineering tool. So basically what we want to discuss is kind of the, how shall we say, GSEF appropriation for the space applications. So how do we make the tool known to the community? What ecosystem do we need in place to make this tool viable? And this then goes on to communities that we need and the governance for the tools, and how that can also link to the other communities. So I think most of you weren't here for the presentation yesterday. So we did a presentation about GSEF, which is a ground and space segment engineering framework. So GSEF is an open and collaborative web framework supporting SysML v2 based engineering for both space and the ground segment. And this is basically being developed as part of a large GSDB activity called IDEV. And this is basically supporting, based on a tool called Syson. So this is an open source tool. Go to the next slide. So Syson is being developed, mainly led by OBO. And in the GSEF project, we're basically building on top of this open source tool to add features on top of the generic SysML v2 features that Syson is providing. So here You can see the generic features such as SysML v2 editing, collaboration platforms, the API, reuse for extensibility, and the features that are being provided by GCEF. So, for example, one of the things we're providing is support for domain-specific methodologies, particularly in the space domain. Specific libraries, document generation, history management, so additional features not provided by SysOM. And this will be provided to the community through the ESA community license. So TRL level will be TRL 7, so it's quite high. So this is going to be delivered next year. So it will be delivered sort of late Q2 next year is when we expect the product to be available. So, and now onto the practical side of the discussion. So we have the Slido tool available, and there are a number of questions. I don't know if you want to.
Yeah, so first we want your opinion about what we have developed so far. So the next question will concern the current features implemented in GSCF. Tony forgot to mention, but there are also some trainings planned. So if you want to discover the tool, you're more than welcome to join those forthcoming training and learn, okay? But for now, first, I encourage you to, use your phone, connect to this Slido app, and we will, see if what we have planned is working, basically. So, first round of question, pretty easy. What do you think about those new fancy features we have prepared for you? Is it really useful? I'm really sorry because here we can display only the 6 possible answers. So I hope if you vote for some of them, the most voted will appear. Anyway, I'm waiting for your opinion about what is really relevant, really important, and you're planning to use as a tool like a GSCF v3. So I can't see any vote right now. So if someone can just raise it, can you raise your hand if you're connected to the Slido platform? Okay, yeah, if you have to choose the red one, topic 1, Zeta room. Yes.
Two questions already. Yeah, I just said you need to answer both questions.
Okay, that's. So yeah, well, we are learning. We're learning while doing. Okay, so the good news is we have planned for a collaborative platform, which is quite interesting. Yeah, even if having a REST API is also seems quite important for you, apparently, even if it's quite abstract at this point, because we don't know exactly what kind of connection you're expecting from this REST API. So it will be interesting to have a discussion later about that. Okay, so this is just for a kind of idea if we were near the target. But for now, we will have to pave the way for the future of this GSCF v3 tool, and there's probably some features missing. So feel free to complete with what you would like to find in your next MBSE environment in the future. So requirement exchange, yeah, I guess this is something mandatory we will have to address first. It won't be so difficult to assess. AI is also, well, something quite prevalent those times, so I'm not surprised to see that. Actually, methodological guidance is something we already embedded in GSCF v3. At least there is a default methodology embedded. Plus, you will have the possibility to customize it and add your own methodology. Okay. Okay, interesting. Okay, maybe you can move to the next next one. Yeah, I'm sorry, you're too much for having a real discussion, so we have to use this kind of interaction.
Yeah. So the next slide is really about the rationale for GSEF. So I guess one question is, okay, how do we kind of speed up the adoption? How do we make this kind of available? How do we make sure that people actually know about the tool? And the other thing is about ensuring the availability. So how do we, from a community perspective, do we actually make this a sustainable model? So to have a tool where people can contribute, and actually it's something that actually is useful to the community.
Yeah, maybe a few words about what is a community, because it's not an obvious thing. So there is end users, of course, that will use this tool, but they need support. They need to be trained. They need possibly some expertise in being guided in introducing an MBSE approach in their company. So there is room for service providers offering those kind of services. And, well, the tool is offered based on an open source license. So we are also expecting that some other software editor or software vendor can provide add-on or extension to enrich the possibility offered by the tool, either by providing open source solution or commercial solution. So what we are looking for is really something satisfying all those stakeholders, so everyone can take benefit from this new tool. So it comes to a set of 3 new questions for you. You should be still connected on the same page. First question: who in this room is considering to use the GSEF 3 environment? Maybe you can vote on the site, plus raise your hand so we can have a kind of direct interaction.
I guess one question is how many people actually even know about GSEF at the moment.
Okay. It's frustrating because we have to wait for the three questions to see the answers. So,
okay.
Yeah, that's a pity.
Okay. No.
Yeah, because one of them have completed the 3. Maybe I will go back. So next.
Go through all the questions first, yeah.
So next question is, okay, I mentioned many ways to be involved in this community. Some are by being just a consumer and maybe funding some improvements or buying licenses, things like that. But there are so many ways to be also active by providing feedback to the community, exchanging with other users, or just exchanging with peers. So I addressed a list of possible actions on the images here. If you're interested in being active in one of those categories, please vote for that. Plus, if you're, I don't know, a software editor who have a plan to connect with us, well, the result is anonymous, so please come to see us and express yourself so we can have further discussion later. Okay, and then our last question. Beyond this, let's say, typical action I have identified first, we are quite open to receive your ideas about any further action we can make to ensure the long-term viability of this solution, because it really would be a pity that, well, it won't be used because it's a really good tool, and we are really eager to see the real project using it quite soon. So regular events, yes, I guess this is a quite good idea. And well, Marcel, this is work for you, forthcoming. But you're quite good at that, I have to say. A central add-on repository is a good idea. Just we already embedded some, let's say, space model component libraries in the project. So we probably have to extend that at some point. And yeah, maybe, okay, it's a good start. Probably we can take benefit of the remaining time to have direct exchange with
Yes.
people here.
So based on that, I don't know if anyone has any specific comments or feedback you'd like to make. I think there's two main things. One is, okay, features that you would like to see. And the other aspect is really on the communities. So, which I think is actually in some ways even more interesting, is how do we make this really into something which is sustainable? So, yeah. So it's kind of more open floor. Does anyone have any specific comments or suggestions about the features or about the community approach? How you think the community should actually could operate? I think there should be a microphone coming.
So the good news is we now have 14 people here considering to use the tool.
For us, one major topic is, okay, developing add-ons is important. It's really what brings the tools ahead. Yeah. And programming an add-on is no issue at all. So okay, it's a limited issue, but it's quite straightforward. But maintaining an add-on for a longer duration is always very, very painful. We ourselves, for example, do not have resources to take care of maintaining such a product. Yeah. And this is a question to you. Would it be possible that we hand to you over an add-on, so the skeleton, the first implementation, and someone else takes over maintaining it?
Okay.
I mean, certainly, the platform itself, in terms of it's hosted on this CodeF platform, so it allows providing kind of contributions. So, of course, a contribution could be initial skeleton, of course, then actually going further and then developing that further. Obviously, one thing is resources. So
yeah, and to be really honest, so far we have no idea about the exact structure or organization we will put in place to ensure this long-term viability. So that's why we are asking right now. What I can imagine is something pretty similar to what we have done with Capella, okay, where there is this very strong open source tool available, and we have a lot of open source extensions or commercial extensions available. Some of them are maintained by their editor directly because they have a commercial interest in it. Some of them are, I don't know, prototypes, but might be of interest for the community. And in the Capella ecosystem, we try to centralize the list of add-ons available on a public web page, where the most relevant ones are easily retrieved. And we have something called the Capella Lab, where this is more like first experiment of something not fully mature, which are stored. So people are aware that they can try it, but maybe this is not a good idea to deploy it operationally, or it will require further investment. This is just an idea we can reproduce, but we are open to any other mean or organization enabling to push a lot of new possibilities on top of GSCF. Yes.
I mean, one thing I should say is that currently the tool is on this CodeF platform, which is basically there to support software which is under this ESA community license. So anything that you basically put on the platform, then it's intended that would be kind of available to that community. So I guess the question is are you interested more in sort of developing add-ons which are private, or plugins that you then want to make available through kind of, say, some sort of repository? I guess if it's the latter case, then okay, then we would need to, something that, I mean, isn't really set up at the moment, but we can envisage it saying like basically some sort of website to say, okay, these are the extra plugins that are there, and obviously then you just use them.
Okay. And something which seems appeared from this first round is, well, this is not a surprise because the tool is quite new and you have to discover it, but there is an interest for training and knowledge sharing.
Yeah.
So probably the first action we have is to organize, I don't know, workshop or days to present the solution, things like that.
I mean, there is a public website, so
yes,
obviously we can provide there and maybe some online sort of training, but in terms of actual training, then okay, that's kind of interesting if people think that's something that they would want.
Yeah.
Or maybe like online trainings, maybe some online sessions.
Well, which appearing is knowledge sharing and exchange with peers. So meaning that probably they want to have direct discussion and maybe identify some new needs by discussing and not just a slide and a model example available. Just something we have to think about. Okay, any other question or remark? Yes.
Just one quick point for my knowledge. Considering you are referring to a grand segment engineering framework, is this based on a specific ontology or not?
So, okay, so the bit of a history was developed initially, the previous version for the ground segment, but for the next version, the idea is to really support it because it's kind of agnostic. So it was more that the intended user was for the ground segment. That's how we've kind of used it with the previous version. But actually, this is intended really for the space and ground segment. There's basically two ontologies that will be initially supported. So there will be basically one will be something based on UAF, which is kind of what is being used for the ground segment, and the other one is for the ESA MBSE methodology. So currently the DML our draft DML that's being produced is being integrated, and the kind of extensions are for the methodology are being added currently.
Okay,
and that's why.
But the idea is to make it extensible. So the idea is that it's a kind of configurable platform. So actually, other methodologies could be supported, but those are the two that are being basically provided as part of the IDEF project.
Yeah, and that's why also it was very important for Tony that it was not just a ground segment engineering framework, but ground and space segment engineering framework displayed here.
Yeah.
Something you have to fix also on the website.
Marcel, when do we have to finish? Because I guess we need. Okay.
Yep. Okay, let's go back to the results.
Yeah, we have a bit more time, I think, until the bell chimes. Then.
Okay.
So we have.
Okay, so yes, obviously. Size MLV2 is quite important for this environment. Even I would be curious, honestly, to know exactly what is expected from this audience about size MLV2 as a language, but it would require a long discussion.
I should say that for GSEF, I mean, the focus is very much on the graphical language.
Yes,
with support to import, export the textual language.
Yep, and probably, in my opinion, there's a lot of new features coming with size MLV2, like it's easier to exchange data and possibility to reuse your model with another tool. There's those open API, but the size ML element themselves are quite abstract, so we have implemented this specific space concept so people can use it directly and not being struggled with a too abstract concept just included in the default size ML standard.
Yep.
Yeah. Okay, seamless integration with other tools. I think this is more or less the same I mentioned. Okay, and okay, I went too far. The good point is many of those ideas are already covered, at least partially.
AI assistance is okay. I don't know. Is this ordered? This is ordered in the votes, I guess.
Yeah.
No, you can't
It's just a basic collection. Okay.
Okay, and now the second.
It's interesting though that Excel is mentioned.
Yes. Actually, because it's practical. That's what people work with. So.
Okay.
Yeah.
Okay, there's 3 persons here who say, no, I will never use this tool.
Okay.
So, is there a specific reason for that? I mean, just give it a try, I don't know. Well.
Don't believe me.
Oh, okay. This one, it's a pity, but I know if there are other answers, but there's definitely a huge need for exchange with peer knowledge sharing. I can easily understand that. And yeah, I can display anything. Yeah, I guess the main action we have is to provide a good tutorial training session and
material.
Yeah. Okay.
Which is understandable given that.
One of the things mentioned that is not on the slide is more advertisement.
Yeah. No, it's understood. Although, okay, at the moment the tool is still kind of heavily under development in terms of the version 3. So, okay, it was always a debate we had internally: is how when is it the right time to make tool available? Because if we do it too early, but it's too immature, then obviously people then get a bit disillusioned with the tool.
Would there be interest in online training, interactive online training, rather than tutorials? Other kind of.
Yeah. Okay, so well, thanks for those valuable feedback, and I think we're pretty on time.
I think we're just fine. Yeah. Any more questions? Points? Questions?
Complain?
You say it's actually agnostic, right? That you're providing 2 methodologies, but you could also do your own.
Yes.
And how can I choose them between using GSEP or Season?
Well, okay, it's pretty easy one. Because okay, on the left, basically you have what is bring by either the SizeMLv2 language itself or Season. On the left, there is a whole set of features which is just not existing in Season. So if you want document generation right now, this is not existing in Season. If you want history management, this is not existing in Season. If you want a review system, this is not existing in Season, and so on and so forth. So,
And these features, to me, they don't sound like very space-specific features. So should they be like moved?
Part of them. I mean, space libraries obviously is very specific. So some, it might be interesting to consider having something either available in the open source Season version or available in, I don't know, maybe a no commercial offer.
I mean, there's a bit of a history.
Well, okay. I mean, this is true. There is a few generic features here. For now, this is in GSCF.
Yeah. I mean, the history is that because of certain constraints, all the software really developed, additions were done under the community license. But we could foresee then that actually they could be basically passed to the open source community. So it may be that, as you say, these generic features could make their way back as either directly in Sison or maybe a Sison add-on as an open source software rather than the community source software.
that you provide the functionality like documentation generation in the context of GSEF. Do you mean that you can configure your template, or you have to use only the one that are part of the framework?
Well, there will be default template provided, plus you have the capability to customize it and create your own.
Yeah. We have some defaults which are directed obviously more to ECSS standards, for example, software requirements documents. So there are already some existing templates that you can use, but then you can adapt them. So you just take them and then adapt.
Okay.
But maybe another way to answer the previous question is, if you're looking for something you can use quite quickly on a project, probably GSEF is a bit more mature compared to Season, because you don't have to customize so much. You can reuse a lot of things we have provided by default for space projects. Yeah. Perfect.
Okay, thank you everyone.
Thank you.
Hi everyone. So welcome to. Hi everyone. So welcome to this session on. So the topic here is towards adoption of SysML v2 in the space community. So I'm Anthony Welsh from ESA ESOC, and this is my colleague Samuel Rocher, who's from OBO, and will be leading this this session. So just to give a quick overview of the objectives. So here we're actually more specifically talking about this GSEF tool. So it's a community solution which is supporting SysML v2-based engineering framework, providing kind of a collaborative environment. So what we want to talk about is really about the appropriation for space applications. So how do we kind of advertise this and make this available to the space community, the ecosystem that we need to keep this as a viable solution, the community that we would need, and the governance models that we would need to support that, and links also to the other communities that may be interested. So maybe some of you did see there was a presentation yesterday on GSEF. So this is a ground and space segment engineering framework. So this is, as I say, a SysML v2 platform. It's actually based on an open source tool that probably a lot of you have heard of, which is SysOn. And GSEF is basically adding additional functionality on top of that. And this is being done through an ESA GSDP study. So it's providing a set of generic SysML features, which is provided through the SysOn tool. And then GSEF is then providing some specific features. So one of them is, for example, space domain methodologies and libraries. So we're providing some domain-specific libraries for the ground segment modeling and also for the space segment modeling, customizable forms for those specific methodologies, document generation, history management, some security features and review and discussion features that are not available in the SysOn itself. And this is all being made available through the ESA community license. So this is all on this CodeF platform. So here's the link to the main website. But from there, you're able to register for the platform and get access to the software. And this is currently, the current version, the version 3, is currently under development and will be delivered Q2 next year. And also there will be some training sessions that will be made available during the Q1.
Okay, so now you should be used to that and probably already connected, but just in case, you have the link to Slido here. Just take care to select the right room, the red one, topic 1. And, well, we have a few questions for you. So the first question we have is, are we on target regarding the feature we developed so far? And in the same set of questions, we are also wondering, okay, what would you expect more from a tool like GSEF v3? So I will be able to display the result only when you will have to answer the both questions. So it's not ideal, but we have to deal with that. So first question here, what features are the most relevant to you? This is actually a mix of features coming from the SysML v2 language itself, from Season, and the specific GSEF v3 features. So feel free to vote for your favorite one, or at least the thing you're considering as mandatory to really be able to deliver something at the end of your project. Okay, so we have someone who has finished. I will go back first. So the next question is a free one, and well, this is a kind of a wish list. So feel free to express what you want, and we are not promising to implement everything, but at least it gives an idea about what would be interesting for you and what you're considering as a next step. Okay, so is there a first tendency?
The standard core model is, well, there's two models, but the standard core model is something that came from the previous version of the tool, and it's basically UAF. So UAF is this unified architectural framework. So it provides, and this is basically being used for the modeling of the ground segment, for systems of systems modeling. So there is basically a SysML v2 DML that's provided, which is, I would say, a partial but fairly complete version of UAF, which, okay, in the future will come. So there will work now for UAF v2, which will be based on SysML v2. I know is now underway, and at some point we would like to kind of converge. There is then also additionally DML, which is going to basically be supporting the ESA MBSE methodology. So some of you may have gone to presentations yesterday on that. And the objective is to also support that methodology in the tool. And obviously to do that, then it needs to also support the model library that is required for that from this methodology.
Okay. Okay. So as in the first round, we have a need for a collaborative platform, which is not so surprising. Integration with other tools. We also had that in the first round. So the question for us is, okay, which tool? So probably at some point we will need to have more details about that, but well, this is my fault. Question is not precise enough. Okay, so you can continue to vote, and well, we will slightly move to the next part, because having just this tool and those features is interesting, but at some point, well, this won't be enough, and we want. Well, maybe you can continue. This
Yeah. So the next set of questions is really more to do with the community aspects. So how do we speed up the adoption of the tool? So what do we need to do to make the tool easily available and make it easy for people to adopt? And also, how do we make this kind of sustainable in the long term? So obviously, any sort of software, if it's going to be used in the long term, needs to be sustainable. So what do we need in terms of the community? What do we need to set up from the community so that we can make it sustainable?
So, and by community, it's really important to have a global vision. Of course, most of you here will be future users, and it's fine. But there's probably also service providers here that might be interested to know that at some point they can extend their service offer by adding a GSCF v3 training or be able to support projects in their GSCF v3 usage, and so on and so forth. The same for tool or software editors. At some point, we are quite open, having a strong, open environment, which can be extended with new features, or which can be integrated with some external tools. So the more possibility we have, the more the project can implement and be efficient in their daily work. So there is a lot of stakeholders that might be interested in GSCF v3. We are just asking in the next question, okay, considering all those different roles, where would you be ready to invest and be interested in having something provided? So the same link, it hasn't changed. First question, quite easy. Are you considering to use this new tool? Yes, maybe, or no. Well, as the tool is not fully released yet, I'm not expecting a strong yes right now, but I hope you're a lot here to considering at least having a look at it and try it in the future. I would be surprised to have too many no's, but who knows? Yeah. The next one is a bit more tricky. I try to create a map with many ways to be involved in the community, let's say. So there are ways where you acting as a customer and you will pay for accessing new add-ons or accessing to services, things like that. But we also have room for organizing event and discussion between users or creating connection between between different projects so they can exchange on their practices and things like that. So you will also be active just by promoting the solution, letting other people know you're using it. Just give us feedback about what are the next feature you're hoping, things like that. So try to, tick the box where this might be appropriated for you. And on this specific question, this is anonymized. If you want to, I don't know, create a new service or a new add-on, I have no way to see who selected that, so please come to see us and have a direct discussion if you have a real project on that. Okay, and last question regarding the community. We are eager to hear from you about what you're considering as a further action to take to enable this GSCF deployment and to ensure the long-term viability of this solution. Okay, let's have a look at the first question. We have a lot of no, which is quite surprising. I don't know. But we have two yes, definitely, which is better than the first one. Okay, anyway, just for you to know, we also had a lot of requests for organizing knowledge sharing and exchange with peer in the previous session. So this is probably something we will have to consider.
Yeah. I mean, I think this is something that we realize, because in terms of knowledge share, then it's something that's still quite new. So we know that actually from a community point of view, there's not, shall we say, it's not very visible. So obviously it's something we know that we need to work on about how to make this, share the knowledge about the tool.
And yeah, practical training. Well, we mentioned that there's a few training already planned. So yeah, probably there's option for you, but we'll have to organize something also to consider the next step after the official end of this project.
I mean, it would be kind of interesting to know what sort of type of training people would like. So, I mean, obviously there's physical training, but that obviously is quite costly. But for example, do people prefer just to have, for example, online tutorials that they can just go to? Or is there kind of a strong, say, need or like having maybe some interactive online sessions? So this is something we could consider to sort of set up so that actually, we can have 1 hour or 2 hour sessions, present the tool, people can ask questions about it, and so forth. These types of trainings, it would be kind of interesting to get feedback if this is something that there would be some interest to have those types of trainings.
Yeah, I see there is a need for example. Just for information, there is already some data embedded, some libraries created, some document template predefined. So you're not starting from something empty.
There is the Comet example.
Yes, the Comet example.
Yeah, that's used for I think previously for another number of projects.
Okay, so maybe it's time to take a few questions or remarks from you guys directly.
I think in terms of providing examples, I think it's important that they're not locked inside the tool. Like, in order to see what you can do with the tool, you need to already cross the threshold of setting it up on your side. I think if you can just go on the web and find very easily, then making the case for choosing a specific tool is much easier.
Okay. I mean, also, would there be, for example, for for the models that are online. I mean, one thing we could actually do is also have a server where actually you can just browse, go directly to the web server and actually browse those models, because this is something that we could consider.
That could be a way, or like a lot of software projects have online documentation with tons of example implementations, like something that's easily accessible, I think is really important.
Yeah.
And also regarding those examples, something brings by this new SizeML v2 standard is that in theory, it will be much more easier for you to start from something created in GSEF and reuse it or open it at least in another editor. So you will probably lost some specific graphical representation we've made to hide complexity, but all the data will be directly embedded, and there's no need for stereotypes or extra information you had in the previous UML and SizeML formats. So it should ease to reuse GSEF model in other environment, or reverse, start from something created elsewhere and use it in GSEF.
Are there specific models that you have in mind in terms of what type of models you would like to see?
Not really anything specific. It's just being able to see all the different things you can implement and the different ways you can implement things, I think can spark inspiration in modelers.
Because the models would be kind of tied a little bit to the methodology. So, for example, you could have examples for the ESA MBSE methodology. Obviously, those would be using then that approach. But that's something you could do maybe for different methodologies, maybe have different models showing how the different methodologies are used. Could be an option.
That's something like having the release notes with videos embedded in the website, providing first hints on what the tool is actually doing on a daily basis, and with the updates would ease the way to enter in and see what is doable.
Okay. So there are also a few requests for a better interoperability, and this is also something that should be brought directly by the SizeML v2 standard and the open APIs. And for those of you who attended the session on the hackathon, possibly you saw there were those people who connected a theorem prover on top of a season model. And as GSEF is based on season, basically you would benefit from the same for almost free if all those specific analysis tool can access to the standard SizeML v2 API. So possibly there is a lot of analysis you can already do just by this new API capability provided by SizeML v2. Oh, too soon.
Does anyone have any, in terms of community aspects, so for example, sustainability, the tool, has anyone got any comments or points that they like to make? Because this is obviously, in terms of communities, one of the most difficult aspects is how to make sustainable.
I know it might sound quite an abstract tool because we just had 5 minutes to present it, and we had something like 3 hours yesterday. So, but let's say the main idea is there is new SizeML v2 tools which are appearing on the market, and we tried with GSEF to provide something already configured and customized specifically for space and ground and space segment design. So you don't have to waste time by configure everything. You can just reuse some component libraries, things like that. So something much more practical and convenient for your first project in space domain.
I mean, one thing I should say is that there will be further support in ESA, so we do plan to support the tool. Certainly at ESOC, we want to continue using the tool, so it is envisaged that ESA will provide some support to keep the going. And we do also see there are some other projects. For example, there's another major GSTP activity that started, which is to provide a basically space security framework, and this will actually be provided as an additional product to the community, which will be based basically as an extension on top of GSCF. So there are also some plans in the future where ESA will be providing some support and some financial support to keep the tool going.
So in terms of adoption within ESA, so you mentioned, okay, this is being supported at ESOC. Is it just ESOC, or is it across ESA? And are there discussions, for example, together with the EU for Copernicus to make this sort of your standard modelling framework approach by default?
I mean, that's probably a bit at the moment.
Well, that's
what's the management?
I mean, at the moment, I mean, it's quite early days, so there is. I don't think we can say that there is a, shall we say, an ESA position on this. So at the moment, it's something that we're developing. At ESOC, we plan to use it. It's also basically being provided the methodology for the ESA MBSE methodology. Of course, that will also continue to be supported through some of the tools that are being used, such as the Cameo tool. So, I wouldn't say that this is, shall we say, there's an ESA position. At the moment, it's early days, and it's also actually trying to gauge what is the engagement from the community. Is this something that actually the wider space community would like to see and would like to use this? At the moment, we're at that sort of stage. So
I think
I guess we should probably. The gong go off?
I don't know. I'm lost with the timing, so probably we are done. So thanks for
everyone.
your time.
Yeah.
And well, we are here.
Yeah.
So free to.
Exactly. If you have any comments or suggestions, then please just come and see us at some time the next day or so.
Okay. Thanks again.
Thanks a lot.
Bye.
Hi everyone. So I think we should start, or else we'll run out of time. Okay. 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 Well, whatever.
Okay.
Okay. Because that's okay. No. Okay. Okay. Yeah. Okay. But okay, we start because we know that basically we have to finish by 3:30. We then want to go on to the next track for everyone. Okay, so hi everyone. So my name is Anthony Welsh from ESA ESOC. This is a colleague Samuel Brochet from OBO, and we will be leading this discussion on the basically towards the adoption of SysML v2. So in terms of the objectives for this session is really to basically discuss the adoption of a tool that is currently being developed called GSEF, which is basically a SysML v2 tool, engineering framework that is basically aimed for the space community. And it's building on an open source tool, which probably a lot of you heard of with SysOn. Basically, GSEF is adding additional features on top of that, which is aimed more specifically at the space community. So what we want to do is basically raise the subjects of the appropriation for the space application. So how do we make GSEF firstly advertise it and then also make it available to the community? What's the ecosystem that we need to put in place to make this kind of a viable community solution? The kind of governance model that we would need to support that, and also linked with any other communities that we need to or would need to interact with. So there was a presentation yesterday on GSEF. So this is the Ground Space Segment Engineering Framework. So as I mentioned, this is a SysML v2 based engineering tool. So it's based on open and collaborative web platform technologies. And it's being developed under an ESA GSDP activity building on work that has been done previously. And as I mentioned, this is really building on top of the OBO's SysOn framework. So this is providing the generic SysML v2 features. Okay, I won't go through these because it's going to take too much time, but it's basically providing kind of very extensive and complete support for the SysML v2. And then on top of that, then we have then GSEF specific features. So one of the things that is being provided is space domain methodology. So we're supporting methodology that's been used for previously for ground segment engineering based on the UAF framework, so the Unified Architectural Framework. And also, as part of this project, we're also integrating the ESA MBSE methodology, providing also additional space libraries, customizable views for those methodologies, document generation, other features that you can see here. And this is all being basically provided through the ESA community license. So this is all available on the CodeF platform. So there's a link here, and where it's possible to join the platform and get access to the software. The final delivery will be Q2 next year, and will also be some training sessions in Q1 of next year. So now the idea is to now go. I'll hand over to Samuel, who will then go more into the sort of questions we want to ask about this.
So same dispositif in the other room. We are using Slido, so you can vote for a few questions we have for you. But considering the number of people we have in the room here, maybe we can have a direct discussion at some point. So. Okay. First question we have is just to be sure that we have developed so far interesting feature for your future project. So what I've done is just list main feature provided either by this new SysML v2 language, by the Season platform, or the specific GSEF v3 feature. So, well, just just inform us about what you're intending to use and what you're considering as the most important aspect in this environment. This will be updated only after the two first questions have been filled, so that this is perfectly normal if nothing is changing right now. And the second question regarding the GSCF features is for us the opportunity to have your views on the next improvements we can develop. There's no promise, okay, but we are just curious to know what would be required or what would be a good idea to consider for the next iteration on this tool. So right now I had no vote. So is someone ready to share his view directly, maybe?
Has anyone actually tried SysOn? I mean, I know GSCF is probably, people have not tried that, but as in terms of SysOn, has anyone actually used SysOn and had any sort of evaluation of features or missing features that they see that would be good, useful if the tool supported?
Feature, we needed to have the analysis part and the textual part, so that's why we didn't use it. But really the textual and the analysis was what we were needed for our hackathon part.
Okay, so I guess actually it's in some way an answer that textual features needs to be there.
Then it needs to be there, really, because it makes life so nice that you can use the textual part of SysML v2, so.
Well, there's actually a partial support of textual notation, so you can copy paste some element, but that's not like having both representation open at the same time.
Yeah.
So I agree. I would be curious to know if it would have been easier for you to have this space methodology already embedded, having some space component library available, things like that, or after all, it's not so important for what you've done in the hackathon? Because this is something we have on top of season in GSCF.
Yeah. I think if it had been embedded in the SysML model of the hackathon from the start, that would have been helpful. I don't know if anyone else was a part of the hackathon here. But we needed to change the hackathon model a bit.
No, I'm realizing that it would have been much more useful if we had provided GSCF instead of season for this hackathon. But next year, probably, this is something we have to do. Okay. Okay, so there's a need for AI assistance. I would be curious to know what kind of assistance you're requiring from AI at some point, but well, send us detail later about that. Okay, we had a few answers. Yeah, more or less the same compared to the previous groups. You are expecting obviously something based on size MLv2, which is good because that's what we were intending to do, and a lot of possibility to interconnect. And yes, for us, it's not easy to know exactly what is expected, which kind of integration to which tools, but we receive the same kind of answer from the other groups.
So there will be, so for example, there is some integration. So one of the supported features is the CSV for Exchange, mainly focused for Excel. So obviously people use Excel rather extensively. So obviously normally that's one of the first things that people ask for is, how do I integrate this with Excel? So that is something that is there and will be there in the first version. Then there will be some integration with Jira for issue tracking, and there will also be some support for this model-based engineering hub, or one of the versions of the model-based engineering hub that will be there as part of the first version of
Okay, so, well, first part of this session is about the, let's say, technical feature, but we are much more interested in making sure that the tool will be used in the future and how to ensure the long-term availability of this solution. So that's why we have a second set of questions, trying to identify what might be the next action we have to take to ensure well, this won't be just something else developed and put aside and nobody is using it. It would be a shame. So, want to add something?
No? Go ahead. I think we'll go into the questions and
okay.
have a discussion.
So for that, well, we are obviously considering the end users, but our hope is to have a global to take into consideration the global community on top of GSCF, meaning that you might have some new service providers offering trainings or support for a project. You might have a software editor creating connection to their tool or providing add-ons on top of it, and adding value to this tool, and so on and so forth. So just keep in mind that this is not just about the end users, but you might take benefits from this new tool in many ways, and you can be active. And well, we just trying to identify a few collaboration possibility in the next week, next month through the next questions. So the link is the same. You probably already have access to it. Well, first question is an easy one. Are you considering to use GSCF v3? Yes or no? Well, we'll see later. Second question, I tried to identify the few ways to be active in this community. Some require to have money and buy something like a license or things like that. But there is so many ways you can interact with people, provide feedback to the development team, or provide advice or share your experience with other projects. I identified a few categories here. So if you think some of them might be appropriated for you, you can just tick the one which is relevant. And if you have something specific in mind, the questionnaire here is anonymous, so I won't have any means to reach you. So if you have really something in mind, please come to discuss with us about your project. And yes, the last question regarding the community is, any idea from you guys about the next action we can have to ensure that the solution will be properly deployed, used, and how to ensure that we will keep all those things alive for a few months, a few years, and really take benefits of this new environment. So once again, we are not so many in the room, so feel free to interact directly. Okay, don't force me to ask who answer. Okay, so just for your information, we basically had the same feedback from the previous groups. There's an important need for knowledge sharing and exchange with peers, which is not so surprising considering that, well, the tool is really new, not even officially published. And yes, this is definitely something we will consider, organizing some kind of event or something to let's say, kick off the community. Let's things moving.
Has anyone got any maybe suggestions about ways that could be done, or their preferences how this could be done? Obviously, training sessions is obviously one way, but in terms of knowledge sharing. But it's interesting if anyone's got any suggestions either now or, as you say, later. See us. Oh, yeah, actually, a very good suggestion.
Okay, this one is surprising. We standardization is this is the first time we have this one. Okay, I think it's a bit soon, probably considering that. Well, probably we need some feedback from the project. Who? Yes,
yep.
Go ahead.
We have some support for identified methodologies in the application, so it brings some kind of standardization of the way you will be able to model using the tool. But maybe this is not what you have in mind when you say standardization, because it might be something else, some other way to access the tool or to display the information, as it's added with accessibility. That might mean also the fact that the tool should be provided and displayed in a standard way that complies with any accessibility standard. So I'm not completely sure to understand what you mean. And
so basically, we are. I'm in a company that doesn't still adopt model-based. So I'm actually here to understand what are the potentialities. And the point is that sometimes when I jump in discussions and also in latest sessions, I've seen that there is a lot of there is not so much common ground. So if I want to start doing something in this field, it's kind of hard to understand where should I put my direction at, and so I appreciate if like ESA is like trying to work on the open source and work on the impose some standards also. I would really like it. So just to have a clear direction of where we are actually going.
Yeah. So the idea is that. Well, with Season, you have something like a very generic size MLV2 editor, so very abstract concept, no methodological guidance, no libraries available. And with GSCF, you have a methodology which is proposed by default. You can adapt, if any. There is some space component libraries coming with, so probably you don't have to customize too much to start something and realize your first project. Will it become really the next official standard? This is slightly different, but at least you're guided and you are able to start working quite quick.
I mean, there's nothing in ESA in terms of like, okay, we mandate that you should use this, or this is the standard tool. At the moment, that doesn't exist. Maybe in the future that may happen, and I think there is some direction for some of the other tools, like ESA about, for example, the requirements management tools. There is some, shall we say now, kind of tool that is a sort of, shall we say, the standard tool that projects should start to adopt. But in this area, I don't think there is anything standard. At the moment, this is very much a sort of a, shall we say, a ground-up approach. So, I mean, it's more that we sort of make the tool available. We try to give some support. Then actually we like to see what the interest is from the communities. Is something that actually people want? And is it something that actually can be sustainable? Because obviously it will only be sustainable if the interest to support it. So, is the need there? And it's just, okay, these sorts of forums are one of the ways that we sort of better understand is there actually the need there? Are we wasting our time trying to do this, or is this something that actually kind of the sort of space community wants?
Is there a way that the tool, like to especially help the ones who aren't doing MBSE, could host a an ESA version of the Space System Working Group CubeSat System Reference Model from INCOSE. Because the CubeSat System Reference Model is largely based on the American and NASA standards and DODAF, but it's the complete model. You can get it for free. So it contains everything that would be expected in an American space project. I just wondered maybe that's something we could put effort into making for the European space sector.
Okay, that's interesting. I mean, I don't know so much about that. But is it, when you say a complete thing, is it's more a model, or is this like, how wide in scope is this?
It's a package and hierarchical model.
Okay. And is this on SysML v2, or is this something else?
It's released through OMG, I think.
Okay.
They have an implementation in Cameo.
Okay.
It's the INCOSE Space System Working Group.
Okay.
And it's been going on for 15 years, I think.
Okay.
And we aren't that many European people in the INCOSE Space System Working Group, so please join the INCOSE Space System Working Group as a European.
Okay.
INCOSE is the International Council of System Engineers. They have different working groups. One is the Space System Working Group.
Okay.
And it's mostly Americans there.
Okay, but this model has been developed through this group?
Yeah, voluntarily.
Okay. But the model is not American specific as such.
No, it's just based on a lot of the American standards. So then.
Okay.
Yeah.
Okay.
I guess the main issue will be to migrate it from V1 to V2 at some point.
Yeah.
But
I think it's also published in XMI, so I don't know how difficult it would be. But I mean, it's just an idea.
No. It's a very good suggestion. Do you think we need our own like a European version of it? I mean, this is the question.
I think it would be very good to have a European version of it.
Yeah.
Because then it would look what the primes and what ESA are used to seeing.
Yes.
Because it's slightly different from the American version.
Okay, so my personal opinion is it would be very nice to see more people from ESA in the INCOSE in general. Create a model or host a model is okay, it's just a technical stuff and we can easily do that. But the real point is there is not so many European people involved in this working group right now.
I think Hans Peter from ESA. He's part of INCOSE and part of this working group, I believe.
Although
I was part of that group too, but as a tool vendor.
Although Hans Peter's ex-ESA now, so I don't think anyone actively needs it. I guess you're in the group, so you're probably the representative from ESA. Or, yeah.
Okay. Well, I'm personally involved in other working group, but I can't attend everyone. Sorry for that. Okay. Any last comment or remark? Yeah, I know it's quite abstract because we had something like 3 hours yesterday to present the full workbench, so it's really, really quick. But if you want details, have a look at the available presentation, the website, or just have a discussion with us. Thanks.
Thanks everyone.
Yeah, unfortunately, yes.
So, hi everyone. So welcome to the final session. So obviously, not so many people now, but yeah, maybe that's kind of good because then maybe we can have a bit more of a intimate discussion about the topics that we'll discuss now. So my name is Anthony Walsh. I'm working for ESA at ESOC, the European Space Operations Centre. And this is my colleague, Samuel Rocher, who's working for OBO. So this topic is about basically we're looking at the adoption of SysML, particularly with this GSCF community solution tool that is currently being developed through an ESA GSTP activity. So basically this is a fully SysML v2 based solution based on, okay, we'll just wait for these people to come in. Come in, please.
Yeah.
I guess the other sessions. We're a bit late.
Just lost hope at some point. Okay, thanks for being here. Just take a seat, and we'll resume.
Okay, I think maybe we just start again, and then
okay. Let's start again.
Okay, so hi everyone. So my name is Anthony Walsh from ESA ESOC, and this is a colleague, Samuel Rocher, who's working for OBO. And in this session, we're basically the topic is towards the adoption of SysML v2 in the space community. And in particular, we want to discuss a tool that is currently under development called GSEF. So this is a community source solution that's targeted, basically a SysML v2 base, targeted for the space community. And it's building on top of an open source tool that probably a lot of you already know, called SysOn. And as part of the activity, which is basically funded through an ESA GSTP activity, we're developing extensions on top of SysOn, which is targeting the needs of the space community. So in this session, what we want to do is basically raise some topics in terms of the appropriation of this tool within the space community. So how do we advertise it, make it more accessible to the community? What is the ecosystem that we need to put in place to ensure that this is a kind of a viable approach? What is the sort of community that we need to set up in the governance model to support this, and also links that we may need to set up with other communities. So there was a presentation yesterday, some of you may have been there, on GSEF. So GSEF stands for Ground and Space Segment Engineering Framework. So as I mentioned, this is a SysML v2 based framework. As I say, is based on SysOn and extended by as part of this GSTP activity to add features that we require as part of the space community. So the core features come from SysOn. I won't go through all the details, but basically it's providing a very complete, shall I say, coverage of the SysML features. And then on top of that, then we have the GSES specific features. So one of those is support for space domain methodologies. So we're supporting one which has been used previously for ground segment development based on something called UAF, the Unified Architectural Framework. And also as part of this project, we're integrating the ESA MBSE methodology, which has been which is also SysML v2 based. Also, we're providing some space libraries, providing features such as customizable views and forms for those methodologies, document generation, history management, a whole set of features which is not provided by the base SysOn platform. And all this is being developed as community software. So maybe the next slide, which is kind of community license, which basically is freely available to the European space community. So the link is here if you want to access the platforms. This is made available through this CodeF platform, and you can register for the platform and then download the software. It's a GitLab-based kind of platform. The final delivery of the solution, this new version of the solution, GSEF v3, will be made available in Q2 of next year. And we will also plan to have some training sessions in Q1.
Okay, so you should be used to that now. Well, we are using Slido because we were expecting many people in the room. It might be not so convenient, so at some point, if it's easier for you to have direct interaction, we are quite open to that. Anyway, so you can connect, select the red session, topic 1. And here we go for the first question we have for you. The first set of questions will concern the GSEF features, either the features we are already developed or those who are expecting in the future. So first question is really about what is available through this new SizeML v2 language, the SASON environment, or the specific GSEF features we have developed on top of that. So we are quite interesting to check if we have covered the main need you have for your project, and we'll see that later because I can display the result only when you will have answered the 2 first questions. I don't know why exactly, but that's it. And the second question regarding the feature is a really open question about what are you expecting in the future as something you consider really important, or you would like to see appearing in this as an extension of this tool. Okay. As for the other group, obviously, well, we have developed a SizeML v2 editor, so yes, this is a SizeML v2 editor. We're quite happy to see that. It's well, that's nice. It's true we also had a need for integration with other tools. At this point, I have to say my question is not well formulated because I have no idea exactly which tools you are expecting to be connected with. So at this point, maybe some of you can, well, give details about that. What is there a specific tool you're expecting, or another extension? No one? Okay, so we'll have to guess. And
yeah, I mean.
The usual thing, thermal modeling tools, structural analysis tools, CATIA, this sort of thing.
I mean, in terms of what will be supported, at least in this first version, I mean, it's probably more basic in terms of, the first thing is Excel integration. So, which actually, to be honest, is actually what a lot of people request, because actually a lot of people do their work in Excel. And so just from a practical point of view, that will be supported. There will be Jira integration. So basically, so these are more, I would say, not in terms of integration with engineering tools, but more with, I would say, more the office type or collaboration type tools. There will be integration with this, there's a model-based engineering hub. So one of the versions of the model-based engineering hub, there will be an integration with that, so that will be part of the first version. But yeah, of course, it would be very interesting to know what other integrations people would like to see.
Okay, so it's also interesting to notice that some of you consider that having a space domain methodology is something important, which is quite nice for us because this is really one of the most key added value we had in mind when decided to implement JCF. For you having something ready to use and not something too abstract as a very generic size MLV2 environment. So it's good to know.
Yep.
And yes, and every other group also vote for having a collaborative platform because, well, there's definitely no more room for a single user on a model. You need a whole team, so it's good we are supporting that. Okay. Model centralization, I'm not sure what does it mean. We are supporting model libraries, so maybe this is.
Yeah, I mean, one thing I should say, it's I mean, this is it's a web-based tool and a collaborative tool. So effectively, there is a central model repository. So there's a database behind it, and obviously it's web-based, so that the team can all work on the same central repository. And so I'm not sure if that's what is meant by this, but I mean, I think there is the concept of a central model repository because the nature of the tool is that actually there is a central database where the model is stored and everyone works on the same model.
Okay. So I'm just curious to know what is AI, not just an assistant. So I don't know. Yeah, can you elaborate on that?
Actually, the thing is that in this workshop, in these days, everyone talks as AI to work as an assistant. I think the role of AI should be too much higher than just as a simple assistant. It should be a developer. It should help to analyze. It should develop the initial model. Because we have thousands of data, especially in the designing the spacecraft, designing the space segment, and if we can find a way in order to train the AI using these data, we can go to the higher level, not just as a simple assistant to help us to modeling the system.
Okay, well, it would be challenging. But that's indeed a need. Yeah, provide a full example. Well, we will probably have also this answer in the next question, but we had a lot of requests in this sense. Okay, and requirement management was also mentioned by other groups, and this is kind of the first extension you need when you go on a real project because you have to do traceability and check you are developing something.
Yeah. Code generation is mentioned. I don't know if anyone wants to sort of say a bit more in terms of what were they expecting in terms of code generation. So is this really kind of using it to do software development, or I don't know if anyone wants to volunteer a bit that raised that. Okay.
Yeah, the idea is to be able to verify and validate. So it could be code generation or model execution, but
okay.
Yeah.
So kind of to execute it in some way.
Yeah.
Okay.
Okay, we're done with okay. Let's say we're done with the technical features, and well, let's move to the main topic of this session, which is, well, you now have, or you will soon have something ready for you to use, and we want to make sure that there is an adoption of this solution, and we also want to make sure that it will be available for mid or long term. We don't want to develop something useless, basically. So what we will try to do with you is to identify what will make the community on top of JSCF fully active so that people can take benefit from it, and probably identify also a few actions to take to make things happen in the next weeks and next months. So just as a reminder, obviously, yes, there will be end users of GSCF3, people who will design a space system or ground segment with GSCF, but there are also room for service provider offering training or support to development team. There are also room for software editor to provide add-ons or extensions to these tools, and so on and so forth. So we really want for you to think about this whole community and imagine what you can have as an added value from GSCF or bring to this community and interact with the others. So we have a few questions in this, let's say, community topics. First, well, it's quite easy, is who here is about to use this GSCF tool, will think about it later, or already know that, well, there's no way we'll use that. Well, I would be quite disappointed if too many of you say no, but I'm just curious to check. Okay, second point might be more interesting for us to determine the next action. I try to identify the few ways to act in the community. Some are requiring some funding or investment, like you're ready to pay to access to extra features or service or whatever, so you're more a customer. And there is many other ways where you can just send feedback to the development team, or you can just exchange with other users about good practices and try to provide value just by I don't know, exchanging on a forum or being active at an event or be involved in a specific working session, things like that. So think about the category I've mentioned it. Select the one you consider that might be interesting for you. And if you have a specific project in mind, the questionnaire is anonymous. So if you really want to discuss, come to see us or send an email so we can really go further and have a direct contact with you. Well, and last question on this topic is, we are quite eager to hear from you about the very next step and what we can do to make this solution a success and ensure its availability. So we don't have specific plans, but we are ready to hear from you and ready to adjust and then create something in the next months. So let's check at this first answer. Yeah, good. Nobody say no. Thanks for that. Okay. Yeah, as in other rounds, there's a huge need for knowledge sharing and exchange with peers. So this is not a surprise for us. We already had that 3 times. So probably we'll have to organize some events. It's not clear at this point if it will be webinars or working sessions or I don't know, but we will have to do something about that. Good to know that some of you confirm that they are future users also. Well, and let's have a look at the other ideas we have. A clear roadmap regarding Capella and GSCF. Well, that's an interesting question, but could you elaborate on that?
Who is selling what? Who is what? And what is open source and what is not? Well, but maybe it's a silly question just because
I mean, this is a good question. So on one side, you have Capella, initially developed by Thales, and we helped Thales to develop this solution. At some point, they decided to open source the solution, and we were active in this open source. We are still quite active in animating the Capella community by organizing webinars, the Capella Days in 2 weeks, by the way. So if some of you want to register, it's still time. And we are doing a lot to create connection between Capella users, things like that. So we have this very efficient open source tool, on top of which some others have created services offer or extension, things like that. So Capella now is available in open source since 10 years, something like that. So it's much more mature. Now we have worked with the ESA to create this first version of GSEF. Okay, so this is a very first version available for everyone in a kind of open source license too. Okay, and the discussion we have right now is to try to identify if we have to reproduce the exact same business model we had with Capella, with a strong open source component and possibly some commercial extension, or maybe nobody here is interested in invest on that or use that, and so in this case it will be quite we will stop everything. So we are just trying to identify exactly how the ESA will invest on that, if there is an interest from the community, and if we need to plan for next development, next improvement, if this is something where the need is for everything is open source, or people are ready to pay to access for some features. We are really open to any option right now regarding GSEF.
So there will be, I mean, so we have this investment. We will continue. I mean, we're using actually, although it's the previous version, actively RESOC. The idea is with V3, then it can also be used. Will support the ESA MBSE methodology, so that provides an additional platform, and in addition to the Cameo for the methodology. Okay, we have to see then actually what people really want, which tools they want. This is what so we're trying to understand at the moment. There is also, in addition, another ESA activity, which is building on top of GSEF, which is actually to build it's kind of a security platform, which is there for basically for supporting projects to achieve certain security compliance levels, and this is building on top of GSEF. So, and the reason that's done is that it's built to be extensible, so you can add extensions to the framework. So there is already some work in ESA to do this, but obviously gauging the community, like wider space community level, whether there's also the interest to do similar things.
Maybe something, well, we haven't discussed in the previous rounds, but what we've done with Capella is when we decided to open source it, we also created the Clarity project, bringing together something like 8 of the most important French company interested in discovering MBSE and having their first project with Capella. So maybe this is a kind of action we can identify right now and say, okay, maybe Ariane is interested to discover this tool, and we want to share in a collaborative project or experiences, things like that. Well, I don't know. It's just an idea. Yeah. Also, maybe just to make another parallel with Capella, at those time, this is still the case. The added value is this is something really pragmatic, and the engineers can be efficient with Capella very quickly because the concepts they are manipulating are close to their daily work, and there is a lot of things about productivity and things like that, compared to SizeML, which were a bit too abstract for them. What we have here with GSEF is a kind of a similar situation where you have now those new SizeML v2 editor available, but this is just about part def, very abstract concept, and you will need in your project something coming with a specific methodology, an existing set of libraries and space component available, and so on and so forth. And we think that for space domain, it's much more useful to start with this tool compared to a too abstract one. I never said we won't have at some point an Arcadia implementation on top of Season based on size MLV2. We also have discussion with large companies, and we are quite open to develop that too. This is just not the topic for this talk. And at some point, maybe there is room for having both, because the projects are not the same, the concepts they will use are not the same, the community won't be the same. But the idea is to have Season and everything which is a very generic core component being available in open source and not redesigned and recoded every time. We will share every communalities and just work on the specific process, the specific concept you want to have, and the added value for each of domain. So it's a kind of a way to share communalities between domains.
Got 2 more minutes. If anyone's got any other points or.
Well, success story, yeah. Clearly, it's just too soon because,
yeah.
as you see, well, we still have to.
Yeah. I mean, the previous version of the tool is actually used at SOC on Plato mission is probably the one that's really used it most. So they're actually actively using it now before launch, which is end of next year. So they're really using it for mapping, for doing all their validation, so doing the SVTs and acceptance testing, where they have a full traceability between the various requirements, the components and interfaces within the system, and the test to make sure that there's full traceability, doing the sort of system validation activities. So, but okay, the idea is that then all those features will be taken into this version of the tool. We hope to then basically import all of their data into the tool. And that's kind of where we want them to actually, in the future, carry on in our other missions, carry on using the tool. As I said, this is sort of adapted very much for their use. So in the end, they don't really see SysML. Actually, they really just see tables and forms, actually, most of the time. That's really what the kind of engineers don't really want to see SysML v2 details. It's kind of hidden away from them.
So, any last room? I just can't see if someone is raising their hand. Okay, so probably we're done. Thanks,
yeah.
Thanks
yeah.
again.
Thanks everyone.
Thanks.
Noch nicht? Ja, und dann muss ich zuerst noch Sicherheit scannen, das Übliche. Ah. Angekommen ist sie schon. Alle? Caroline, alle? Weil ich habe... Right. So, good afternoon for this last session of today. I'm happy to chair that. Sorry for the slight delay, but that is if you have modern engineering and production technologies, it is delivery just in time. So I just got some of the final result slides only delivered and had to integrate them into my presentation. So what can you expect this afternoon? It has been in the program that first we have a panel session and the debrief of the World Cafés. And after that, we have also the last keynote by Ralph Hartmann to conclude the day today. But to start with the panel session and the debrief, just to basically tell you what I intend to do. Because how do you combine a debriefing with a panel? you can either cut it in two and say everybody gets 20 minutes and then we don't have any real interaction for half of the session. But we thought, why not combining those two things? So what we're going to do is ask the conveners of the World Cafés to basically report on the discussions, on the interactions they had in their sessions. But on the other hand, also have a whole panel there challenging, quizzing them on the discussions they had, getting more details out of that. And that discussion should not be limited only to this panel I'm going to call up, but also to you if you have any questions left. Roughly speaking, I think between 10 and 15 minutes per session per World Café should be sufficient for the debrief, which leaves us about half an hour at the end of the panel session, where I want to actually have a dialogue with panel members on a few questions I'm going to display later on. So, whom did I ask to actually join me on the podium here? It is the 4 keynote speakers we have in this conference. So please, if all of you could come up here. That's Kamal, Tim, Hans-Peter and Ralph. Ralph you haven't seen on the stage before, so he will conclude here. And on the other side, I also invite the 4, one spokesperson of each World Café to come up here and actually be ready to present and defend. Am I missing someone? More? No. I was not planning to sit, so that's okay. Right. So, first of all, a round of applause for all these people who actually are ready to expose themselves here in this kind of context. I propose that we go through the debriefing and quizzing the World Cafés in the sequence they have been in the program, starting with the first one, which was towards adoption of SysML2 in the space community. So the session objectives, I just recall them here. They have been laid out and were the starting point for the World Café. And I would like to basically invite Samuel to report on the main findings here. It was the session which was focusing around GCF as a tool, but also the adoption, a wider adoption in other domains than the space.
Yep. So thanks to be here, and I will be happy to do my best to, well, provide a feedback in 5 minutes on so many discussions we had. Okay, the title of this session is a bit misleading because it was about toward adoption of SysML-v2 in the space community. And actually, we talked a lot about this GSCF solution made available quite soon. So for some of you, it might be not so obvious that this GSCF workbench is actually a SysML-v2 environment. And so the good news is this is not just an abstract environment, but a SysML-v2 web-based environment where we also added some space design methodologies, some space component libraries, and a lot of other stuff, making it much more easier to use on your first experiment in your project and in your discovery of SysML-v2. So the objective of this session was just to present you this brand new solution, to make you aware about its future availability, make you aware about the future trainings that will be soon available, and discuss about your future needs in terms of technical features we will have to add on top of it, and more importantly, about what we will need to do to ensure the medium and long-term availability of this solution and make sure that this is something that will be useful for the whole space community. So what we were expecting is having you embedded at the end of this session and list of action to consider to go further. So we split the session in two main parts. First one was dedicated on the technical feature of these tools. We tried to check we didn't miss the most important point in the current development, and with no surprise, the fact that a lot of you were expecting a size MLV2 environment is well covered. That's good news for us. Plus, there is a need for a real collaboration in model edition, and good news too, this is something which is already covered by the tool we are currently finishing to develop. So you will have that available very soon. No risk on top of that. We also discussed about the future extension we might add on top of this solution. Well, there's a huge trend about AI, so this is not a surprise that a lot of you ask for an AI assistant on top of GSCF environment. I have to say we still have to figure out exactly what kind of assistance you need from an AI and to define exactly where we have to place the effort, but this is definitely an important topic for a lot of you, and we take note of that, and we have to think about a future project to at least have a proof of concept or first prototype to provide you with a few proposals in this regards. Much more pragmatically, there is also a huge need for an Excel integration. So it seems that a lot of projects are still doing a lot with Excel. Not a surprise too, but probably we will need to improve the capacity to import or export data from Excel to GSCF, so you can easily reuse data. This is something which is probably not so difficult to achieve. We just take note that we have to do that. And well, something more surprising is there is a huge need for, we need integration, we need analysis. So there is a lot of requests for that, but we still need details about exactly what kind of integration we will have to target, which tool exactly, which kind of an analysis you're looking for. So probably we'll need to organize a few workshop or survey to be a bit more accurate about the exact feature we have to add on top of a GSCF. So that was for, let's say, the technical part. Regarding the community and ensuring the long-term availability of this solution, I have to say it was a hard part because the solution is not ready yet. So for a lot of you, it's a bit abstract. So you still have to discover it, and you're quite willing to do so, but you will need help to do that. So probably at the first time, we will have to provide you with a lot of training material, model examples, improve the publicly available information, things like that, plus organize awareness and probably events to allow you to enter easily in this solution. There was also a lot of interest for having direct exchange between users and exchange about good practices and learn from each other, things like that. I don't know exactly which form this will take, but we can imagine organize some specific events our workshop and favor this kind of collaboration in the future. Plus, also probably at some point add an official training in the ESA Academy or a more formal collaboration with the, let's say, official training program of the ESA. So that was the main request. And if you have more or want to discuss a more specific topic, once again, come to see us and we will be quite happy to continue the discussion.
Okay, thank you for that reason. Now my question to you have now, well, partially participated in the discussion, but maybe not all of them. Anything in the findings you're surprised about or you're missing?
Yeah, I missed something. I think it would be good that we establish an ecosystem that provides domain-specific space model libraries, so such as standards, which are currently documented in PDFs or so, that they are available as SysML v2 libraries and accessible for all the organizations, so not for a single organization, but for all the organization.
All right.
Yeah, just a remark, if I may. There are several tools, several tool vendors, different domains, and I think that we need a little bit of branding here. The name, GSEF, maybe we can find a much more easy name. A motto also, because it's an ambition project, a motto, I don't know, the full end-to-end platform, or whatever, and maybe a little video or something like that. I think some branding is needed, and of course a logo.
Okay.
Sorry for this remark.
We'll add that to the list, but that's an easy action we can take. Yeah.
Well, that's a sales pitch.
Maybe another question I have. So again, GSEF was a new term for me. I assume this is ground segment engineering framework, something like that.
Yeah, exactly.
So
ground and space segment.
Okay. That answers my question. Because my question would have been, what distinguishes that from a space segment?
Yeah, the story is
framework?
initially it was only about ground segment, and in this latest version we added the space segment.
Okay, wonderful.
All right. Maybe I just want to ask you if what you want is already addressed partially by the ontology work we are doing.
Yes, but it's not SysML v2. Not yet.
Well, is it complementary or
well,
redundant?
If you would like to push SysML v2 into the space domain and people create SysML v2 models, they need access to the libraries in SysML v2. So we need something like that.
Yeah. Actually, Tim, there is some library provided in this GSEF project too.
Oh, okay.
So
great.
This is just first version, and it needs to be improved, but it's planned to provide a few example model and libraries.
Because we also see this in other domains, so all organizations reinvent basic stuff again and again and create their own libraries. So it would be good to have third-party libraries that can be accessed by everyone.
Yeah, there is actually one library from the concurrent engineering which is very similar. So we could easily convert that one to a SysML library, and it adds things like redundancy schemes, risk factors, a number of ECSS-related properties and KPIs, let's say. So that could be easily added. That would be a very simple thing to do.
Okay, so thank you. Right now, for this one, you got some additional ideas here from this panel. So,
thanks,
work
everyone.
to do. Thank you very much. Next one was the World Café on the collaboration aspect, enhancing space industry collaboration, solutions for prime suppliers, and so on. So, Moa, please. I don't know if that one.
It's working? Yeah, you can hear me. So I think most of you are familiar with this. I think maybe most of you visited for those who didn't visit our workshop, our aim, the team behind it with OHB, TNO, and EMM, And SysDice was to really collect the challenges when it comes to an MBSE or in general collaboration between agencies, supplier and primes, which is actually a typical thing for any space program or any space ecosystem. And we wanted to, beside the challenges, to also collect solutions from different stakeholders and put it all in a one kind of single source. We also recognized very interactive discussions between the team when they were sharing about even a Discord, the System Engineering Discord. So it was indeed on the fly already productive when the people not knowing each other already exchanging ideas. So I will go directly just from time perspective to the results. So the first, we wanted also to understand a bit the demographics of the participants, so for all the 4 groups. And as you see before that, we had, the team was very hardworking. We decided to take the paper-based approach. So we categorized the people in more or less in roles. So the first graph on the left side, we wanted just to understand who's representing the agency or who's representing a prime, and the supplier and other means a tool supplier or a university or a research institute. Then we also went deeper and individual to understand the roles. So who's let's say a classical system engineer, which is working typically with documents. We can see that mostly half of were real MBSE, so they were admitting that as a model-based system engineer. And we have like 20% development. That means they are like software, electrical, or mechanical, and also a similar number to the management role. What was surprisingly not expected, that almost half are reusing model to exchange. But there is a bias behind this because it's all about definition of the model. So it's not a SysML model only, but rather any engineering or any model. So it could be a MATLAB model or etc. So we have to be careful when we post this on the internet or in LinkedIn because there might be a lot of marketing behind. Yeah, so I would jump quickly just to show you the results. So after individually we had 6 groups, so we aimed at 4 or 5 people in every group, and really we asked the people to name the challenges. And so just shortly before the session, we harmonized everything together and cluster them more in a title. So you could see our first observation is there's a lot of challenges when it comes to standardization. Even I can let's say exchange. One of the agency members said that even the standard itself, so the process requirement, is contradicting the model-based collaboration when it's stated that, for example, a deliverable must be in PDF form, so something like that at some time need to be updated as well from a standard perspective. We also saw that when it comes to the competence, in some regions, let's say globally, if I may say in the Asian side, was also admitted that there's a lack of, let's say, a suitable or proper MBSE competence when we consider the whole ecosystem. So probably it's in the prime, but not on the supplier. And this will impact, for sure, the collaboration, the model-based collaboration will not be possible. There was a lot of topic. I mean, you see less or more about the IP and access. One of them was the security. So if I will share as a prime or as a supplier, if I will share specific model, will the tool address to extract, let's say, data with the typical data classification levels? So it goes more toward not only toward the tools, but also on the marking. We also saw a lot of, let's say, this configuration, typical version management aspects, and lack of revision control. And we did our best to vote them. So the colors you're seeing, it's more or less the same agency, just to see who is actually the most agreeing. Didn't work, honestly, 100% as we expected. But it was interesting to see at least that in some group, everybody was like agreeing on a specific challenge. So that it's actually a great takeaway that if you have 4 different roles are all admitting that it is a challenge and we have to look for a solution for it. What's also interesting that we saw that some are talking about the human factor, so the people itself, that So difficulty of engaging non-modelers. So this when we talk about simplicity, it's complex, how to bring the management, how to bring all these non-MBSEers to also keep them in the loop of the collaboration and the speed of communication. And I was surprised a bit there was a little of business, but maybe it's okay to not to talk about the return of investment. So it seems there's no challenges there. And I will stay calm and not say much. I'll not tease here. But just to show you the other part when it comes to solutions. So I was also personally, and we also like, so there is already a lot of solutions. So it's not that out there when it comes to the tools. So there's already, we can see the open source, the user access. So we went to the Comet. So most of the things maybe you're familiar with it, the open access API. So these user-friendly tools are there. So there is already a dedicated or set of solutions which could be actually a challenge. So we are not just talking about challenges without solutions. What's also was good to see that people were asking about free licenses, for example, for universities, just to at least kind of keep it as a standard way to tackle the competency. What else? Yeah, the common ontology. So we saw a lot about the topic about osmosis there, and one of the good points was also the reference architecture. So very similar what Tim mentioned. So if we all are talking about, let's say, a small subsystem, why we can't go somewhere as at least in that program and model it together as a library, or we call it reference architecture. And I know some of the primes here already driving that since more than years. So why just we bring it on an agency level as well? And it's very similar for the ESA MBSE methodology solution. Yeah, so in general, that's it. I would like just to thank again the team behind. So it's I was just one of a great team, and thank everyone for being the authors of all the posts this year.
Right, thank you. Well, I know for you it was a bit difficult to, because it was behind you, to spot maybe individual things, but from what Moa was saying, anything to be highlighted matching your expectations or actually surprising you?
Of course, I need to jump into that terminology you used, classical systems engineering versus model-based systems engineering. I think that is not existing. I will allude on that later on also. I think it's very dangerous if we go into that rabbit hole, making that differentiation. Also believe the so-called classical systems engineer are using models. If they are doing interface control document, a verification control document, that I call it even document, that is not a document, that is a database. And in the simplest case, they're using Excel for doing so. So that there are a lot of data models and models they are using for their work. If they are not using SysML or these kind of things, doesn't mean they are classical systems engineers from the dusty period where we have thrown paper documents around over the fence. So just a comment on this.
Yeah, I completely agree. Just the aim was more statistical. And there's no right statistics, right?
But I need to make sure that that this terminology doesn't get that we are not yet used to that. So I know what you wanted to do.
Yeah, Colin.
So when listening to your summary, thanks for that. What comes to my mind is one question, maybe a very basic one, maybe I missed it, but what's collaboration in the engineering process? Because I think it can have many facets, and yeah, we need to think about what it is in order to see how we can improve it.
Yeah, thanks for asking. It is a very good question, and probably Marcel will be enforcing that. So I can share. So actually, between OHB and SysDice, and actually between OHB and MM, we're already since beginning of this year applying a complete model-based collaboration. That means the prime is specifying the requirements, the capabilities in a model, exporting it, sending it to the supplier. The supplier is taking that model, enhancing its own requirements, of making full traceability in the model, working on its, let's say, a subsystem level, if it's the control heating unit in an instrument, and applying the full traceability in the model so there was no documents, and then at a specific milestone, sending the supplier model, which is containing the subsystem fully traced to the system, is getting traced back to the prime, and there with the right configuration management, it's merged, and with an impact analysis. So this is the kind of cycle we're talking about, which is relatively in automotive. It's a standard thing more than a decade. So, and it's not model-based, not document-based, but a complete model-based collaboration.
So essentially, exchange of models in the supply chain.
Exactly. The deliverable is the model, and there's no documents. There's really no documents in place.
Okay.
Yeah, I see there one thing says extend ACSS for MBSE. So that is pretty close to my heart. There's one very simple thing we can do there. Currently we have the DRD, which in ECSS is called Document Requirements. What is it?
Document.
No.
Definition.
Definition, yeah, document requirements definition.
Yeah.
So we have all these DRDs. A long time ago we made a list where we could, replace or make hybrid deliverables that contain both a model and a document. And I submitted, I think 8 years ago, I proposed to change DRD to use the same abbreviation, but to call it deliverable requirements definition. And so that opens the door to really specify them as model or document or whatever you need, but really take a neutral term and take out the word document from this abbreviation.
Okay, Hans-Peter, I know that Marcel wants to jump in, but I also want to, something which is close to my heart, which is people sometimes confuse documents and documentation. Yeah? Unfortunately, it's used synonymously very often, but I think we always will need documentation. And the way we actually put it down or exchange, whatever, might be different. It might not be a PDF or anything else, but it needs to be documented. And that is where I think the origin of the term comes from. But in order to avoid any confusions, it might be good to change terminology. But Marcel.
Yeah, just to provide a little bit of context and also a comment to Hans-Peter. So we actually are currently in the process of having made the definition of what we expect when we do model-based exchanges, what it means in every phase of the life cycle, what should be the content of that model rather than the document deliverable that we used to have in the ECSS. And actually the projects that Moha was referring to, we're challenging ourselves to do that outside the context of a single company. So we're forcing really people to collaborate across the borders of companies that have different working processes, different tools, different approaches. So we really want to engage and understand what it means to do practical exchange of models based on a defined content. And that is actually what's now going on in 3 projects in parallel. And the project in which Moha and the others are involved in is one of those 3.
Okay. So with that one, thank you, Moha, for that report and the clarifications. So the next one on the block is got to be Caroline on the federated data exchange for MBSE and digital continuity.
Yes, thanks a lot. So yes, I'd like to report on the third World Cafe, which I did together with Paloma Maestro Redondo from Starion. I don't know where she is, but yeah, thanks for, yes. So thanks for doing that together with me, despite the challenges we had to face. It also fits quite well with the storyline, with your collaboration topic, because data exchange, and what we discussed in that session is, yeah, one essential aspect of collaboration, next to, yeah, actually co-design or co-creation of things. So with our session, we wanted to cover or dive into the objectives that you see here on the slide. So we wanted to identify, together with you, the current challenges related to data exchange by showing you two existing prototypes. So on the one hand, we had the MBSE Data Hub developed by Sterion, and Paloma showed very briefly in these sessions how that was developed and a few use cases that could be useful for the future. And then I have shown you a bit different approach to data exchange in a more federated way by using the data space concept that's been going around in the last years, building onto the work that we have done in the Cooperance project. So we also wanted to discuss how these two solutions and possibly others could improve possibly workflows in data exchanges, especially, of course, while looking at what we are discussing here, MBSE environments, but also in general the digital continuity and how to, what role potentially trust could play in this whole data exchange scenario and how we could handle issues related to data protection. So we had 3 very interesting sessions where we queried the audience with a few questions in Slido. And first of all, we wanted to know from you what, well, in a very brief 1 or 2 words, would be the biggest points of friction in the data flow or in data exchange today. So you can see here the results of those 3 sessions. Essentially, we have mostly seen that the same topics come up again and again, being, well, for once, the topic of semantics. Of course, if you exchange data, then you have to understand the data, or at least map at a certain point the data. Then what also came up quite frequently, at least in 2 sessions, was the topic of tools. So either the tools you use to create your data and how the outputs could then be used for data exchange, or even the challenge of having tools that do not really produce output that is suitable for data exchange, so meaningful output that can be understood by other tools. What also came up is the topic of confidentiality. You see that here. So, as I said earlier, especially in scenarios where you have, for example, a constellation with the LSI and the supplier, there might be certain aspects of the data exchange where you want to make sure that the data is considered confidentially and also a responsibility. So then we wanted to dive a bit deeper into getting concrete examples, actually. So for when data exchange failed or somehow slowed down the work, the results were quite interesting, ranging from I don't know, the upload to a server took too long because the data files were quite big, to, well, interesting aspects, for example, where data exchange of geometry data between different tools didn't really go successfully, so the different geometries were not consistent in the exchange. We also had an interesting example of a failed data exchange, or maybe I challenge you to know or to tell me if it's really data exchange or something else. Well, because we had the second session without participants in our room, so there was the answer that the failed data exchange would be did not move in the right room during this World Café. I don't know if it's really data exchange or if it's interpretation of the data that in the end failed for that particular one. So maybe that can be questioned. But overall, I see that data exchange often still means exchange of documents or PDFs, and eventually models. But there are also other important data types to be considered for data exchange. Then we queried the audience for the topic of trust in a data space. So we wanted to know for the different aspects that could contribute to building trust in a data space and in data exchange scenarios, what would be the most important from you. And there was a clear winner in terms of importance for clear data ownership, so to know who owns what data, which is also somewhat connected to transparency of data use, so that if you own certain data set, you will also know who is using your data in the future and what's happening with that in the future. Then we have also seen that identity and access management could be another very important aspect for data exchange, for example, through a data space, where you could make sure, for example, that someone requesting or acquiring a certain data set is really a member of an ESA member state. That's one trivial thing, but in certain data exchange scenarios, that has to be made sure for export control regulations or something like that. We also asked for ranking capabilities of the data hub that was shown by Paloma. And what we have seen there consistently over the 3 sessions that we had was that those 3 capabilities were always in the top 3. So for you, most important thing is traceability across tools, followed shortly by model linkage and then change impact analysis. So surely all of those 3 aspects are closely linked and somehow show an evolution of that topic. So first you trace across the tools, then you link the individual models, and then, of course, on top of that, you have the change impact analysis. In the end, second to last question, we wanted to know what we should do next. It's always quite interesting to see where's the highest pain from the audience. So we proposed 4 different topics to work on in the next 6 months. Exchange of requirement sets, supplier interface data integration, cross-organizational change impact analysis, and exchange of test data and analysis data. Surprisingly, they were all quite similar. So obviously, we need to work on all of them at once so there's no clear preference of the audience, what's most pressing. And yes, last but not least, we also wanted to see, well, in the end, from what we've presented and what we think are the main topics for data exchange, which themes should be explored further, the participants want to explore further. And there also, among the 3 sessions, the result was quite similar. So the data hub integration and the data exchange were the first 2. And then the other 2 topics of governance and standards and adoption and change management were always a bit lower in ranking. So essentially, of course, understandably, the people want to dive closer or deeper into the actual solution. I want to see what's feasible, that's our interpretation at least, and want to use it actually. And then maybe later, of lesser importance, although we think it's an important topic, are topics like data governance, providing certain standards. And then in the end, once we know and understand the solutions, then we care about adoption and change management. Yes, so we also had an interesting discussion on standards in the session. Maybe I give it to if I may, give it to the group. So the question was whether in order to simplify data exchange, so the effort in realizing data exchange, we should standardize modeling tools, for example, to limit the range of modeling tools that should be used by certain companies doing a space project.
Okay, I think when we start talking about tools and standardizing tools or whatever, then we open a box of Pandora, and maybe we come to that at the end of the session, but I don't think we should focus on that one right now. Any immediate reactions?
Yes, thanks for those feedback. I'm surprised you haven't mentioned SizeML v2. I mean, one of the biggest promise with this language is it's supposed to favor data exchange and interoperability. So I'm just wondering if you discuss this during your session? If not, what is your view about, is it really being helpful for the problematic?
I think it's a bit connected to what you can realize in terms of what's highlighted there in the upper left for the semantics. It's not really an ontology language, I know, but from my understanding, it will be useful in the future for the backbone for understanding different data sets that are to be exchanged. But of course,
well,
I hear a reaction right away.
SysML2 is based on kernel. Kernel is an ontology language.
Okay.
It is based exactly on the same premises, on the same first-order logic. The mathematical foundation of the SysML language is exactly the same as OWL2, the World Wide Web, semantic web language, and also exactly the same as ORM, object role modeling. There's
then even better.
no difference on the foundations.
Yeah.
You can reason on a SysML2 model when the software is implemented, but the design of the whole language is on exactly the same mathematical framework than the others.
Well then, yes, so for the semantic aspect, then it could be useful for data exchange.
Okay, for me, one of the questions which came to mind when I listened to you, how do you see what you discussed in terms of, is it complementary to what we have heard from Moa in terms of collaboration aspects?
Yes, so let's say within the, so speaking from the experience of, for example, the Cooperance project, we have been looking at what elements of data exchange are needed in order to collaborate successfully over the whole life cycle. And we have looked at, that's why I ask what collaboration specifically. We have looked at certain use cases over the life cycle where certain roles or contributors to a space mission collaborate for a certain goal. And one topic is, for example, the co-design and defining the further scoping the requirements or defining the electrical architecture, things like that in the design. But there are other collaboration opportunities or possibilities or aspects like the interaction between the LSI and the client. So, for example, ESA or any other agency. In this contractual situation, there are other collaboration aspects where you exchange data, where you also exchange models that we have been looking at in the Cooperance project.
Okay. One last point here.
Yes, so one question. The tool or the platform, whatever you call it, sounds very cool. You have a certain level of maturity. We can say that you have a minimum viable product. Is there any real-life deployment roadmap? I mean, on a real project?
No, at the moment we have shown in that public money funded project that we reached this demonstrator level, TRL 6 was the limit for that project. And now we have finished the project in March. Now we have to bridge this gap to the operationalization. And I think that's, for many things, the most tricky gap that needs to be covered. If you don't have this consistent funding, at a certain point of time, you need to see if that gap is either bridged by investment adoption from, for example, LSIs, or if you get somewhere additional funding. So yeah, so we are making this transition now and creating the roadmap to enable an operational use in the near future.
Okay, thank you, Caroline. Now the fourth of the sessions was on the profile of the MBSE modeler in 2030.
Yes.
So that was not just in time delivered, it was a little bit.
So my name is Robin Prudhomme. I'm replacing Gerald Garcia right now. He should be there, but unfortunately he cannot be there today. So I will talk about the workshop cafe number 4, the MBSE tool of the future, meaning of 2030, and what we would like to have as a tool. So at the beginning, what we say that, okay, we have now several decades of return of experience according to its investment we have and all the tools we can use on our own organization. And okay, we have some, it's recognized that, okay, there is some added value by using this tool, but we can see that today, MBSE, it's not really adopted by the whole community of system engineers. And we could ask the question why. So let's try to concentrate on tooling aspect of the problem. So why, according to the tooling aspect? Because, okay, today there is some new possibility according to, okay, SysML-v2 language, AI, which is a promising solution to change the world of MBSE, of course. And, okay, it's maybe time to think about the future we would like as MBSE tools. Okay, so in order, sorry, okay, so before to go into detail, in order to try to answer to this question, we organized like a questionnaire, so a lot of questions, in order to evaluate the current status of MBSE, and then we ask people what are their expectations according to this new tool. So what we can see first, according to the current status, is that today, according to this curve, most of the participants we answer to the pool are mostly in the slope of enlightenment of this curve. So statistics don't say if it's at the beginning or at the end, but we are quite there. Quite a good point of view. Sorry. And when we ask the question if today people would like to recommend their tool, their current MBSE tool and environment to their friend, the main answer was not really. So we could ask why. But okay, this is the repartition, the distribution of answer we could have. So some are really optimistic or have really good friends, and others not really. And so we ask why. Why not recommended this tool, their tools, to their friends in 1 or 2 words. And so what we can see, okay, a lot of answer, but what come a lot is the complexity of current tools, the difficulty to maintain, to understand what can do the tools, all the features, and yes, complex interoperability between tools we have today. Okay, I'll let you, if you want, to read some answers. Okay. Yeah. So according to the expectation of the new MBSE tool in 2030, we ask which could be an emerging solution and which could be the most promising one. So we have a list of 12 or 13 possibilities, and the 3 that go into the podium was first AI assistant, of course. The second one, the automated diagramming, and first one, to have a mix between textual and graphical modeling. Another question was related to the proportion of usage according to MBSE models, and if the users are mainly authors of the model or reviewers of those models. And the distribution is quite interesting because we can see that we have like an opposite result. Yes, a V model, exactly. So for some users, it's better to edit and to exploit, to consult not a little the model, to use it a little, and for some it's better to model few but use a lot. Okay, so for the parameter of the 2030 MBSE models, we would like to have as an interface, we ask people what they would like to have. And the main answer was, okay, system level functional analysis and architecting, meaning stay as we are today. Because mainly the main proportion of tool provided today has this kind of functionality as basics. Then we ask, second answer was according to the fact to extend to other engineering domain and not only system engineering. So also to include or to integrate into this MBSE framework specialties such as software, hardware, or cyber disciplines. And the last one was to have it in a larger enterprise scale data platform. Sorry, okay, that was the end.
Okay, thank you. Thank you for. Thank you. Any direct reactions?
Yes, maybe an observation of this recommendation question. So why do you not recommend this to a friend? Yeah, that one. I think it. I assume it mixes up a little bit the tool, the language, and the methodology. No? It's a mix of all. I don't think that all these comments are against the tools, also against system and against the methodology.
In general.
Yeah.
I was also surprised about the bimodal distribution of. Do people think that the emphasis is more on the modeling or on the exploitation of the model? And apparently there is really very diverse perception of that, because it depends probably from where you come and do that. And okay, repeat the question. Oh, sorry.
Maybe one point, because you mentioned the major blocking element was also the famous return on investment discussion. Yeah. And I think I would like to open that a little bit up here for debate. I think that we set a wrong expectation to management and to the community about the return on investment, because people always expect the return on investment to occur in the same phase, in the same teams who apply system, or let's say model-based system engineering, or whatever, how you want to call that. And this is not true. It's an increased effort in that phase when you do architecting with these modern tools and so on. And the benefit of that will never come in that phase. It will come in manufacturing, in operations, and later on in the life cycle. And it will come in the next project when you have then maybe a product approach, you have a library approach, you have the concept of model curation and those kind of things. And I think the difficulty really is that we are a little bit helpless for explaining that expectation to people for getting support for investment in that phase of using modeling for systems engineering, because they will not see the return on investment in that phase.
I think it's a key comment. Thank you. And the point is that we are working on the long-term development project. So the deciders, the decision makers at the beginning are not the same at the end. So we are asking the decision makers at the beginning to take the decisions they won't have the fruits.
Absolutely.
So it's a key question. That's why I think we really need sponsoring at the highest level of the company.
Yep.
Correct. Any other direct? Yes, please.
So in the work that I do, I typically try to also achieve short-term return on investment. so that people don't make a model that they don't benefit from at that point in time, but that they reap the benefit of putting in the effort instantly and also later. So to close that gap a little bit, and I think it's, let's say I do that on a daily basis with the teams that I work with, and I think it's very possible to do that. And then the gain in the beginning is small, but if the engineers feel pain and also gain, then it's an easier, it's actually not even a battle anymore, then it sort of works for itself because they get something out of it.
I do agree with that comment in the sense that if I use the term return on investment, I mean return on the full investment. And what you are saying is, of course, you can demonstrate immediate benefits in applying it, but that will not pay off immediately with that full investment. And I think also I've seen a comment from Joachim before. I think there's also a difference between industries who have product customers, and the industries who have project customers. So that means if we have project customers typically are agencies like the Space Agency, there is a strong need that those people, of course, want, during the execution of the project, they want to have insight and understanding and transparency of what's going on. So that means there is a need for applying modelization instead of writing words in a document to really explain consistently to this type of customers continuously also along the life cycle what's going on so that they can understand this unanimously and in the right formation and so on. So there is an immediate benefit because of that specific customer relationship. What in consumer products or other industries, that does not count. There the other argument counts that it is in the manufacturing and the later phases.
Yeah, and the additional, that's a very good point, and the additional thing is that the return on investment is really on the enterprise. So you need to get the funding, let's say, for the engineering process of an enterprise and not on a single project. So it works for a collection of projects, then you get the real benefit.
Right. That we're still kind of triggered by the last debrief here, but first of all, I would like to thank again Robin for the debrief. And as I said, we still have a little bit of time and continue the discussion. And I have just, before this session, tried to capture a few of the ideas and observations I've made up to now, a little bit to dig a bit more into some of the aspects which we have had. And I've put three of these ideas, which I think partially we have touched upon, but where maybe we can get a little bit more substance into. First point I would really like to get a little bit more your opinions is, we had talked about collaboration, also exchange between along the supply chain, but who is really the driving force here? Is it the primes or is it the SMEs? Is it the suppliers? Where do we need to put the effort? Who is the pulling force and who is the pushing force in this context? Ralph?
Maybe I can just continue, if I may, on this topic. Let's say, having been representative of a prime in the past and having discussed that topic at the end very intensively with also other industrial partners. Now, the threat everybody has is to implement that digital continuity inside an enterprise. That is a threat for everybody. And if we have these concepts of there are data exchange standards or there's a data exchange hub, that means only this is a solidaric sharing of the burden to everybody. And as a prime, I would not be happy with that. So I think there was a concept which was dominating to say the prime provides an infrastructure and there will be an integrated collaboration approach that the subcontractors will work in the prime environment. They will integrate their models and their data in the prime environment. That they are responsible for validating the correctness of the integration, and then the prime would not have that burden of dealing with the data exchange standards, which are typically too limited because the richness of metadata everybody's inventing in their models nowadays will not be covered by that. So that leads to a lot of additional work at prime level then in order to that. So the logic was there was this, let's say, this integrated collaboration, and then the topic of IP and so on was then recommended that we have a kind of surrogate models. So that means those models subcontractors will deliver on integrated prime level are not to the depth of disclosing all the, let's say, the design secrets, but only what is relevant for system level interfaces, key system relevant parameters, and so on. So, and so that seemed to me in those discussions to be a trend that primes are trying to impose, let's say, this style of working to subcontractors.
But what you say is really, well, it is imposing the standardization, but it is the focus on the interfaces then at the end of the day.
Focus on the interfaces of the artifacts you bring to the prime.
Yeah.
Yes, but not dealing with the complexity of the IT infrastructure, data exchange, not different in tools, different digital continuity concepts in all the companies that cannot be solved. So that means in that case, let's say the prime is the integrating authority of asking for that kind of approach.
Yeah. Why you want?
Yeah, if I may just maybe share a return of experience. So I like the driving metaphor here, but I think it's not a car. It's more like this beer drinking truck. You know, you're all cycling, so everybody have to drive. Honestly, every stakeholder involved with his own role. So I take that de-risk setup we have. Marcel mentioned. So the agency is enabling, is doing their best to enable that financially and set up the other stakeholder. The prime is going further, sharing the methodology with the supplier, so really without any commercial. This is a respect that they are open, sharing really the whole, let's say, years of work to the supplier. And on the other side, the willingness from a supplier to invest internally, to say, I want to take that path because it will ease, so coming back to return, it will ease my work in the future. And so we have the agency, the prime, and the supplier, and still we have these others, what we call them in our group. So it's still all these, let's say, you can say vertical dimension, which are the third party when it comes that we have a good collaborative tool, frameworks, methods, standards, probably universities, and all these things. So just to summarize, it's a complex stakeholder setup, and probably now we are missing still a fifth stakeholder, but I don't think there will be a one driver, like a commander, and everybody sitting backside and doing nothing.
Right. Which actually was already touching upon the second point I was having here, which is, well, if you want to support that, and you were mentioning that, yes, the agency has a certain role in pushing all these things, there are very different nature of setups. The ones which I call the fully vertically integrated companies, who basically are more product oriented, and they probably, if they do it for their own sake, because they believe that they're benefiting from it. And the very complex setups which we have traditionally in institutional acquisitions, where we have very complex industrial setups, where we have a lot of horizontal exchanges. But both should benefit, and sometimes the question is, on the one side, as an agency, we have the role to procure systems, and that is where we have actually a mandate to make that efficient and as efficient as possible. But on the other side, we also need to help industry to become competitive and more competitive in the world market. So, as we have only limited resources, where is it most useful to actually focus more in our role as a customer or more in our role as enabling industry, or is that the wrong question? Yeah, I see. More question marks. Maybe my question was not clear enough.
There's a big role for enabling for the agencies, and I think there are two really good examples of where this has happened. One is with Thales Group, that developed Capella and open sourced it and provided this to the community. So that allows a lot of access. And now the same is happening with this GCEF example that we saw, the extension of SysOn, which is an open source graphical modeling tool. So that democratizes, you could say that this democratizes the use of MBSE and the infusion of MBSE, and it lowers the barrier to try out stuff and to run, pilot programs and so on.
Mm-hmm. Do you want?
Maybe another point is yesterday the head of the Space Hub, I think was the correct name, mentioned that they here in California sponsor the universities to push systems engineering there. And I think we need something similar also in the other countries. So we need funding of universities, or like this conference, it's funded by the European Union, and it makes this achievable for many people. And we need more of this, so conferences and exchanges of the community, which is funded to increase the level of MBSE.
Mm-hmm. Maybe, yeah, Caroline.
So yes, my personal opinion, because you asked where public funding should focus in this specific setting, comparing vertically integrated setup and a complex industrial mix, which pays a bit into the direction of democratization. I think public funding should focus on where the friction losses are. So enabling to overcome the points where the most friction occurs in this whole life cycle scenario of collaboration and realizing missions together. I think, but I mean, of course, you can prove me wrong, but I think that this friction is higher in the complex industrial mixes, where there's a lot of exchange beyond the organizational borders than in a vertically integrated setup. So I would personally see investment. I would like to see more investment there. And that also pays a bit into the first question that you had, enabling suppliers, for example, to participate in this whole MBSE model-based approach.
Mm-hmm. Sorry if I pick you up, I would maybe Kamal, because you have also the experience from the industrial side more than from the customer side, and you were using your own means to put things into place. How did you choose where to invest?
Where we have put our, I would say, internal effort.
Yeah.
The things that the programs don't want to pay. First, methodology. And any company needs to adapt, not to change, but to adapt, I would say, official standards and methodology to their own usage. And it is a tremendous effort. I fully share the fact that we had Arcadia available for everybody was a key enabler for us. Thank you, Dallas. The other location we had problems is, of course, tooling and IT infrastructures. And in fact, I don't have any answer because we are facing several problems regarding IT infrastructure, accesses, etc., performances, and we are a little bit alone, and we don't know how to. I don't know how to solve those stuff.
Mm-hmm. Okay. Any other direct reactions to that? Maybe just. I would like to pick on what you just said, Ralph, with my last point, which is you almost gave half an answer already between commercial and institutional projects, and you were making the distinction between projects and products. because commercial projects are more oriented towards a product or a service rather than a procurement or a project. Okay, we all agree both need that, but where do we believe are the what you called frictions bigger? In the product-oriented mindset, industrial mindset, or in the project-oriented mindset? Or is it the same?
No, I mean, following up on this, what I said earlier, I think the project-oriented mindset is the more difficult one. Because that talks about that you just cannot do as a company what you want with respect to your own digital continuity, your methodologies, and your own. You have to consider the, let's say, the acceptable need of a project partner at customer level to access the information, to contribute to that, have visibility to everything. Of course, not talking about documents as in the past. So that means access to the digital twin, in quotes, by the customer needs to be granted. And that is a different interest and requirement than independently of that, just making sure that you have a nice digital continuity within your own infrastructure. So that is more disruptive, I think, for a company, and this is why that is the more difficult part of it. On the other hand, I believe, as I said earlier, I think for these areas where we are technological upfront and methodological, like this MBSE story or so on, that also justifies an investment in the early phase just to please the customer and to recognize the need of the customer to be part of the project. And then nobody will debate this, of course, in a company working with ESA in that case. While the justification in a pure commercial thing where the customer buys a product at the end is completely different.
Okay. Thanks.
And that is also the power that ESA has in the space context with respect to standardization, with respect to pushing space industry in a certain direction, having open collaborative digital twins to put that beyond the MBSE story.
Okay, Hans-Peter?
Yeah, I think with a product-oriented company, it's more inherent to their own process, to optimize their own process, and might be the reason they need MBSE. In the institutional market, it's more that you have many suppliers that need to work together, and you have the chance of a top, because there's the big acquisition agencies have power to shape the way of working. So, for instance, what's very interesting is that in the US DoD, or well now Department of War, but they have a digital acquisition strategy now, which is going to be enforced, and they choose SysML2 to apply to all future US defense projects. Now, this in itself gives an enormous critical mass for all ecosystem, tool development, and so on. So it's different, but both can play their role to improve the situation, or to enhance and improve the situation.
Okay. One additional remark, I'm not sure it is fully relevant, but I will say it. On Ariane 6, we had the chance to have an embedded team. So people from ESA or CNES that were, I would say, inside the beast, with us, struggling with us. And they had access to the data, and that helped a lot, because they don't need documentation export, because they have access to the data. And it was a good, I would say, interface to discuss with the official customer. Okay, that was a good experience that helped a lot. Of course, I'm not sure we can generalize this kind of embedded chip.
There we're talking more about co-engineering, which is a dimension which I would consider almost perpendicular to model-based system engineering, because you need, or both are complementary, are not depending on each other. All right, looking at the time, I need to conclude that session. I don't know. I think we still have maybe a minute or two. If there are any burning questions from you guys here, I look a little bit against the light, so Rimantis.
Thanks, Dmitry. Thank you very much for your questions. What I'm missing in the whole debate, the interesting complexity, and Shami a bit touched upon that. The difficulty is we do not have model-based as an element. What Tim said, we have so many dimensions. We have methodology, we have language, we have vendors, and then introduces this already three-dimensional cubes with so many elements, and many of them even on one dimension are isolated. We think as implementing MBSE, but look, someone is implementing just particular methodology, maybe proprietary language that they created for their ecosystem. And then we live in non-connected worlds on both three dimensions. Some companies use 4 vendors, some use just 1. So we have such an invisible, and I think that the whole community is too much in a planning mode and forgetting invisible hand. Because planning works well when we enforce harmonization where it's really harmful divergence, as in too many languages, if we really have to decide. But reducing the effect of invisible hand really makes not the most useful thing, because the more invisible hand we'll have in MBSE is just like Sam told. It's doing a job, because we, in our experience, have so many examples of applying MBSE in isolated. And usually where we come in, where most inconsistencies there are. Because if you have some segment where you have like 100, 200 inconsistencies, the only good way is MBSE to reduce them at the most early stage. And it pays off immediately, as Sam described. So here I think we should less rely on our wisdom and more rely on invisible hand. That's my feeling. And the more invisible hand we have, the better we benefit. We talk about this North American market, European market. If you analyze that market in Europe, we discover that though it's 1/4 working on invisible hand, but out even 15% of those invisible hand is our European exports abroad. And our own demand is just 10% working in invisible hand worlds. So I think if we do less plan in this rigid for these points and more planned for the for generally how we adapt, not how we prescribe, but how we adapt to invisible hand, then we are much more competitive. Because whatever we decide today, we might be very sorry to have decided it today. Everything is changing, languages are changing, methodologies are changing, vendors are changing, everything. We are living in a very dynamic world. So do not forget, there's no one MBSE. There's so many MBSEs in multi-dimensional frameworks. So that's my, thank you.
Okay, thanks for your remarks and contribution to the discussion. On the and I'm sure we're not going to decide anything today.
Yeah, I tend to agree with you that we are in a very changing world. Okay, here we are discussing about how all those companies have to collaborate, and a lot of you here are still in a mindset where they are convinced that they have to be one solution for their company and they have to stick with it. What I can observe is in a lot of domains, there is no more and more huge project where even very big company can cannot design in isolation anymore. I have some examples in railway in Europe where they have to design something working on the whole of Europe, so they have to work like maybe a dozen or 20 different companies designing the same system. They are all huge companies. We now have huge defense projects. Some, well, maybe it's a pity, but we have to do that at European level too. And so we have those companies who were used to work in isolation who have to collaborate to create those new fancy weapons or new defense system, and they have to succeed in that. So at some point, what I can observe is there is more and more projects where they have to reach an agreement and be really pragmatic on the way to deliver something in a few months or a few years. And usually, one of them is taking the lead on the technical decision and will say to the others, okay, guys, I'm able to provide you a platform hosting the models. I will give you an access. I will give you a kind of a framework, including a methodology. I'm providing you that, and we will try to work together. Most of them will accept. And this is just a kind of change of mindset where those companies will agree on a specific project to work differently from what they've done during years internally and adopt for this project a new mindset, new ways of working, and will really collaborate in delivering something. So there is hope. Okay, we have projects succeeding involving huge entities, and they are just have to realize that even if this is hundreds and thousands of people working together compared to, well, these US companies, this is nothing. We have to collaborate anyway, and maybe just adopt a project mindset and maybe change the way you're working from one project to another is also a way to succeed.
Okay. Thank you. So I think that was very, very good words to finish up. There is hope. Yes. And with that one, also looking at the time, I would like you all to thank the panel who have supported that discussion. So thank you very much. And of course, I would like Ralph to stay here for the keynote. I don't think I need to introduce Ralph very much. Ralph and I have a long history together. Actually, we have worked together already 30 years ago. Yep. And he's space geek, and now, of course, I'm glad to introduce him as the sitting president of INCOSE, which is one of the, I think, driving organizations internationally for what we are discussing in these 3 days, and to get his vision about strategy and the future of where we're going. Mm-hmm. Ralph.
Thank you so much, Joachim. Yes, and indeed, we have a long history on talking about virtual spacecraft design already 20 years ago, nearly, or 15. Yep. Now, it's my real pleasure today to be here with you in this important topic, and I will talk about the International Council on Systems Engineering. I have in the program even put a subtitle, which I have not repeated here, which was, does something like non-model-based systems engineering really exist? And I will come to this in the second half of my presentation here also. So I will talk a little bit about INCOSE as such, about the trends we see, the strategies we have, the system engineering vision into the future, then about the current trends, and then focus on a number of examples illustrating this famous digital engineering and model-based systems engineering universe. And we already heard that this is very much fragmented and very much diverse. And unfortunately, I will confirm this assessment, and we are sitting there in a boat together. So I need that one here. Okay, so first, what is INCOSE? So it's the International Council on Systems Engineering. We are a non-profit organization. We believe we are the largest and most relevant international organization on the network of systems engineers. Currently, we are going towards 30,000 members towards the end of the year, very probable. So it's a very rich ecosystem. We have members in, what do I say here, in 70 countries of the world. And what we are also very proud of, we have 150 corporate members. That is of all size and so on across the world. We have the Airbus and Boeing and Thales as corporate members. We have space agencies as corporate members across the planet, but also consulting companies and tool vendors and many universities. Now, what short advertisement a little bit on what are our products and our services to the global community. I think a very prominent one is the top left, the system engineering body of knowledge. This is something which we offer as a wiki on the web, and this is available to everybody. So you don't have to be a member or whatever, everybody can go there. And this is the richest representation of, unfortunately, the very rich and variety of system engineering overall. We have millions of accesses to that, and this is a very interesting resource. Now, below that, the System Engineering Handbook. This is where we try, out of that rich set we have on the body of knowledge, where we try to say, this is the handbook of systems engineering practice as the state of the practice today. So this is really what are the basic principles you need to understand, and you should apply whatever product you are doing. And the basis of, this is also the basis for going to the bottom right. We have the system engineering certification at 3 different levels. And the first 2 are also based on the fact that you have the system engineering handbook under your pillow in your bed, and you know this by heart. And if we wake you up in the middle of the night, you can answer all the questions. Then you go successfully to that test and you get the basis for the certification. But also there are many other things, and standards and tools database, many products, a rich library of topics of 30 years of system engineering, thousands and thousands of papers from conferences, from journals, from webinars, many products around that. Now on the top left, bottom left, that is something I want to highlight. This is the System Engineering Laboratory. And this is also one element where we say, okay, we have now distributed to the planet enough PDF documents. Now we are preaching, we go digital and model-based. So we also need to make sure that we can generate practice model-based, and we can generate also digital artifacts in the future. So this System Engineering Laboratory has a set of many 20 or so system engineering relevant tools in the meantime, donated by the tool vendors, but not just thrown in there. There is also training and webinars attached to that so that people are very fluent in using this stuff. And this is not intended for everybody, let's say, not to pay the license for it and do their company work on this. This is the platform for all the working group we have in INCOSY. If you are a member of that, you can use this rich environment and you can generate digital artifacts, which will be also our products of the future to the community. Then we do have 2 major international events. The first one is the international workshop, which typically takes place at the beginning of the year. Next one here being 31st of January until February in Torrance, California. This is where all the working groups come together. They do the plan, they work together, they do the planning of the year. And of course, you can see in the center at the bottom here, this is also where all the propeller head coming together. I think probably these are all, maybe there's nobody missing. Some didn't have their heads with it. They all come together. There was the MBSE initiative. That was also the ecosystem where many years ago SysML has been started in version 1. The last 7 years we worked on version 2. So this is really the epicenter of, let's say, the evolution of the system engineering community. So be proud of that, really. that's really the best place to be. And of course, we do have an international symposium. It takes place next year in June in Yokohama in Japan, after it was in Canada this year and in Dublin last year. Good news is still the submissions for papers and panels and so on is open until 2nd of January. So you can submit something, making sure that you get accepted to travel to Japan for that. Now, that was a little bit the marketing part of it. A major thing we have is the so-called system engineering vision. This is where we try to give orientation and inspiration to the global community where we believe the discipline is going. That was already existing since a couple of years, 2020. Now we have published in 22 the 3rd edition, the Vision 35. And the Vision 35 has set a completely new ambition, I would say. While the first 2 editions, they have basically emphasized the application of system engineering to technical product development life cycles and to improving this continuously. The Vision 35, in fact, has changed this picture, still doing, of course, the same thing, but we have embraced, let's say, enlarged the viewpoint. In the introduction, we have the global context, where we talk about the United Nations sustainability goals, where we talk about an infrastructure where we have global mega trends like sustainability, like technologies like AI. We have additional technologies like quantum computing and all those kind of things, data analytics. And also our stakeholders and our enterprises have different requirements. It's more the time to market, it is the agility, it needs all what we do needs to be more scalable, more sustainable, and we have also a challenge of lifelong learning, basically. So that means this sets an ambition that we believe system engineering practices are the only ones which consider complex systems like those, the climate system of our planet, or the systems of systems, which are all those things here are system of system problems. So we believe system engineering need to go out and be recommended and proposed and contribute to the solution of those also. Of course, we are not yet there. We are still a weak community, but I think the ambition is set there. And the future state, which is indicated there, especially talks on the top left, the future of systems engineering is model-based. So there's no doubt about that. It talks about next generation of modeling, simulation, visualization, and so on. And I think we all violently agree in this room that this is true. The next part is already artificial intelligence. And when we have written that document, we have not envisaged the speed in which artificial intelligence will make a difference to our world. But that it would come, that was already envisaged, and it would also said it will assist system engineers to be more effective and efficient in doing their work. Data science technologies will also come in addition to that. And the education of training is a major trend and a major challenge, because there is we believe that systems engineering is not just to be trained for people who call themselves systems engineers in the world. We need also to make sure that all kinds of engineering disciplines have an understanding of system engineering as a discipline, as they also need to have system project management as a discipline, because they are all part of a system engineering process in the future, and they need to better embrace this technology also. Then the future state, of course, emphasizes strongly the impact of the digital transformation. I'm not going to these details. We all know that. And the second big picture is that the future state also talks about the impact of artificial intelligence. And artificial intelligence has these two perspectives. The black one here, this is AI for systems engineering, and we have heard a lot of that, how we can leverage AI for supporting our processes, our methodologies, and our work. On the brown area, this is the other challenge, that of course AI will be embedded in the systems we are developing in the future. And that imposes also on us as systems engineers a rethinking of processes, because we need to understand that AI systems need to be trained, they need to be differently validated. So we need to update our processes in order to embed the development path for AI in our systems in a much bigger way, in a much different way. That's still something we need to learn. Now, the major challenges, I mean, we said all of that right now. So we are a nice community, we have a lot of products, we are continuously improving the stuff we are doing, continuously also adding elements to this. So we could be happy and just go forward. I believe that is not true. I believe we are here at a turning point. And the first challenge is what we set to ourselves, the ambition of the Vision 2035, reaching out to new application domains. We are not ready, as I said, to go in that direction. We need to do something there. Next one is the speed of change. We are a rather slow community, I would say. Around us, things are changing very fast. And this example here is just illustrating the ramp up of the request for AI training provided by the World Economic Forum. And that gives one example of the speed of change, how quickly this is going. And I think we have discussed that earlier. There is also a positive element of proliferation of the system engineering discipline. So I think in many places this is applied. In many places we don't have to go and to convince people that system engineering is something they need to do. But at the same time, many people are doing it without calling it systems engineering and without adhering to the community and to the evolution of our standards. So that means what we see, and this is what you also said, we see a significant dilution of the discipline. We are continuously contributing intentionally, and also by the proliferation around the world, we see the increase of the mess, I would say, on this, unfortunately. And the third one is that industry is also very unsatisfied with that situation, because, I mean, all of you, we have discussions here. So that the question is, now what is the recommendation? What is the methodology and the processes today to be applied, especially as part of the digital transformation and so on? You don't want to here go to the body of knowledge and be happy that you have there 20 of different approaches which are there presented without any judgment and any guidance to you what is the element which is applicable to your business. So this is a set of challenges we currently have and where we need to react to. And I have a famous slide here I'm using to explain a little bit this delusion. So this is from our, let's say, a subset, I would say, of standards related to systems engineering in the world. In the center, we have somewhere 15288, the system lifecycle. In the bottom, we have a couple of things from INCOSE. Now, I believe, and to many of them, INCOSE, for example, has contributed to. So we were nice people in the last 3 decades that any opportunity which showed up that we could contribute to a standard, a piece of systems engineering, we were more than happy to do that. And what we created with that is that picture. Not sure that all of us, that we need all of that. We need a handful of those. And so that means we need to be sure that in the future we prioritize better where we put our efforts and what we consider really as a standard, and provide better guidance to the community with respect to those applications. This is why we did 2 years ago a new strategic plan. We updated our vision, and we want to unite, advance the global community. And in addition, the mission now is also speaking newly that we want to be the trusted authority for systems engineering. And that means we don't want to be the nice contributor to the next 100 standards. We want to be a key player with OMG, with ISO, to be recognized that we decide which standards are important and that we put our logo and our energy and our resources in the development of those standards, as an example. And we want to be trusted because we don't want to be those who impose something to the community. We want that people believe that they are coming to us as a community and that we are the right place to support them. These are the 4 strategic objectives we have created from that. The left side, this is about the World Trusted Authority. Behind this, we have all the stuff related to standardization and positioning ourselves in a different way. The second one, expanding the community, is not just growing members, but expanding the application into the application of systems engineering into new domains, into agriculture, into financial systems, into water and resource management systems, into healthcare, energy transition and transformation. Those are the domains which currently are also needing system engineering in a different way. And then we, of course, continue also to develop systems engineering for all of you as we did before, with a new focus also not only helping individual members, but also in the future to better help companies and enterprises to implement organizations and to implement systems engineering in a different way, because that is currently, I think, the obstacle. Each of us individually have difficulties to find the right positive and embracing context at enterprise level. Out of this, we said, okay, this is nicely said. So what are some of the immediate actions we are taking? And this is where we are currently working on. In the top left, you see exactly what I mentioned before. We recognize that MBSE and digital engineering is a very confusing status as of today. Too many practices, too less guidance, and so on. So we have created a task force to work on this and to try that we as an organization can provide a better framing, glossary of terms, the various sets of methodologies, including then also adapting our own working groups to that in a different manner and provide a better guidance for that, not continuously increasing the difficult picture we have today. Standards development, I said this already. On the bottom left, also to work on AI, and specifically also beyond the AI working group we are having for systems engineering, that we as an organization have an AI policy, so that we also recognize that our services to you, again, are not just put through the PDF documents, but what we have heard here yesterday and today many times, that we have AI assistants for you to access all this information in a much better and much more efficient way. Because navigating through the ecosystem at INCOSE with the various guides and sources and working group stuff is also very difficult. So AI assistants should help us here. And on the right side, that's the last point I want to emphasize here, is also that we have a difficulty to speak to non-engineers. As I said earlier, you have the ambition to go to politicians, to top management, to other domains and industries. With our storytelling today and explaining the value and benefits of systems engineering, we will not reach them. After 1 minute, they turn off. They will not follow us anymore. So we need to have a language and a material available so that we can speak to those people in a different way. have those kind of elevator pitches, kind of 5 pages documents which explain system engineering from a system thinking perspective in a much different way. And this helps in technology companies to convince the top management, but it helps also to convince people in other domains to recognize what system engineering is about. Now, what are the current trends? And for this, I have done an analysis of our symposium this summer. And you see here, and I did this, of course, with the help of a large language model, you see the major topic areas where all the presentations and papers came from, including the number of abstracts in each of those domains. So it's very obvious that besides the first line, which is the standard evolution of the discipline, requirements management, design, processes, architecture, and so on. But also then it comes quickly to MBSE tools, AI generative approaches, digital twins, SysMLv2 modeling, AI-driven decision making. So that means this is a one-to-one reflection of what are the hot topics of the world currently and what are people talking about. And on the right side, this is, if you look beyond our symposium this year into other events, these are also the topics which currently are trending and typically also in the theme of many events, like this one here. We are talking about MBSE for space applications. But all the other topics here, they are consistently coming up, including, of course, now more and more aspects like sustainability. And we have sustainability working groups nicely. And sustainability is an important aspect, not just from a mindset perspective, because we have seen also things like, or let's say historically, we have also talked about cost as an independent parameter. Now we can also talk about sustainability as an independent parameter. That means we see in the design models, we also have characteristics related to energy and material consumption. We look into the manufacturing processes. There we talk about water and energy consumption. We talk about wastewater generation and all these kind of things. And of course also then the chemicals and CO2 and all the other stuff. That can be quantified and explicitly considered in our system engineering modeling efforts across the full life cycle. Another reflection, what's trending, I would say, at least in our environment, are the working groups. So we have more than 50 working groups in various areas. I'm only showing here one page of those which we consider to be the transformational domain. And also here you see immediately the reflection of the problem of, let's say, there's no clarity. We have many things dealing with digital engineering information exchange, MBSE initiative, MBSE pattern. We have tool integration and model lifecycle management. So that there are so many things, object-oriented system engineering, so many things related to model-based and to the digital transformation, that also we have, of course, difficulties to recognize the overlap and the potential inconsistencies we are creating here. But at least this is, and we have sustainability here also in the center, this is the list of the trending topics we currently have. So that means we could say as an intermediate conclusion, we are in a transformative swing. We are challenged by a very rapidly global changing context and a technology race, and AI is only one example of those. The major areas of concern are the digital transformation, and this is for me the term where what we discuss here as MBSE is an element of that, but the digital transformation as such is a larger topic. Artificial intelligence, and then of course more the systems of systems and complex systems. driving a car today is not just having a car. The car is embedded into navigation, traffic information, tomorrow car-to-car communication and all of that. I mean, these are complex systems of systems, and this is only one example. So our challenge really is that we continue to align the global community along those lines and have a consistent evolution of the discipline rather than the races of many other organizations and many other also applications who come left and right and overtake us, and we are getting out of control of the evolution of the discipline. Now with that, I would also come to this topic of MBSE and DE. And for this, I'm not preaching a solution. For this, I will show you a number of viewpoints on that topic, which are existing, because there is not a single viewpoint. The first one is one page out of our system engineering vision. So this is the slide which says, today we are unevenly applying model-based stuff across industry. Tomorrow, systems engineer will routinely compose task-specific virtual models using ontologically linked digital twin-based model assets and so on. These are all connected and updated in real time and so on. So this is of course a nice paradise we foresee there. Still 10 years to go until we are there. Now, we have seen that before. One viewpoint of our MBSE initiative is to say, okay, now let's go back, keep our feet on the ground. What is the reality today? And we have here a number on the first column, a number of relevant, let's say, digital systems engineering related competences. And we have then the maturity level from initial to optimizing. And what you can see is we are somewhere in the middle here. So that means also looking to the hype cycle on the left. It's what we have seen in one of the slides before. The reality is we are the advanced community speaking about the future here and applying those things, but going out into our organization in the rest of the world, this is not yet the mainstream, what we are discussing here. We are still in this let's say, valley of disillusionment and trying to get at the stage of enlightenment. There are still many years to go until the things we are discussing here become really industrial day-to-day practice. And luckily also because we are here for space industry was at the beginning of system engineering in the last century already a driving force and still is today. So you are, let's say, the privileged community also we are looking at in order to help us driving in that direction. Now then, these are the things we all know as a principle. So we have this historical status of throwing documents across the walls into the next phase. And then we started to change a little bit. The first step was, we had PLM systems trying to better manage documents and data and configurations, especially into the manufacturing field. Then we already observed that after this, we got the evolution of all the other disciplines. We have digital engineering in mechanical, electrical, software, and name it. While still we did the transition at that time from document-based requirements management to requirements management tools. First step. But now we have this thing, what we call MBSE, in order to catch up with the other disciplines, in order to fill our role as systems engineers to orchestrate the rest of these people and this stuff here across the life cycle. Now, what we heard a number of times this week also, that this is a nice vision still, and where we currently are is basically the process of creating a new silo. We are creating the silo of the MBSE engineers. I heard that term a week ago, people talking about MBSE engineers, about MBSE artifacts, about MBSE activities. And this is where that's completely wrong. We should talk about systems engineering, and systems engineering needs to be model-based and need to use the digital artifacts and need to understand also the digital artifacts of the other domains in order to do this orchestration role. So currently, there is a big risk that let's say, emphasizing this MBSE term puts us in a different silo. And many companies and managers like this and hear these communications, and then they say, by the way, there is now this new thing, MBSE, this is really cool. So I buy a tool which does MBSE, and I buy 100 modelers, and then I do MBSE, and that means I do systems engineering. Wonderful, I'm done. And we all hopefully know in this room that this is not at all the solution to the problem we have. Now, another viewpoint is this famous digital thread. So the idea is that from the very early phase down to the rest of the life cycle as serviced and until retirement, we have a continuous traceability from requirements to functions to logical architecture, physical architecture, to the as built and the as maintained. And this thread on a very individual basis, that's also the vision. This is what we expect also the digital transformation to deliver. We also speak about the famous digital twins. Now, some people believe the digital twin means I have a wonderful supercomputer which has all the artifacts of such a product to the lowest level of detail, and I can do with that, can simulate that, and I can look up all the information. For me, a digital twin starts at the beginning of the life cycle, travels through the life cycle with an increasing level of detail, and there is a digital twin at each stage of the life cycle, and it does not be also artifacts like, how to say that, static architecture representations also are representing a digital twin to the extent. It's not meant that this is the full simulation at every time. And we heard this today in the discussion. That's the viewpoint from the US DoD. They have created this digital engineering strategy with the idea of the authoritative source of truth at the bottom, also connecting all the elements along the life cycle and standardizing the approaches in each phase, making sure that with their acquisition strategy to primes and suppliers and so on, they can impose a way of working, so they make sure that all their consortia and products and projects are working in the same thing. Interestingly, they don't talk about MBSE. When they say digital engineering, also system engineering is naturally part of that, of course, and playing this orchestration role. But they're not calling it MBSE. So what are those key concepts now? We have on one hand all the digital engineering stuff which is coming. On the other hand, we have this understanding of data plays a critical role nowadays. Some people here it's the oxygen, others say data is the oil of this century. That's the most valuable, let's say, asset we have. Then we have systems engineering, the technical connective tissue. And people say, okay, now we have also MBSE. And of course, you can imagine I don't like this way of representing it, because that has to look like this. So we have systems engineering as the technical connective tissue of the project team. And of course, systems engineering is naturally model-based. And then we have, of course, different maturity or details currently in our practices, but you cannot explain to me that there is any system engineering approach in a real project these days where you don't have models and data and so on already in usage. And because you might not use SysML does not mean that you are not yet model-based. Other viewpoints on that is, in the center we have this authoritative data. We have a data governance approach, and then we have all the elements around, like system architecture, hardware, software engineering, manufacturing, also project management, and all this stuff around. And we have this interconnected data, which are then the basis also for all kinds of analysis and so on. So that means we do have this diversity of perspectives, unfortunately. I mean, if we put all of them together, we can get a glimpse, an understanding of what we mean and where we want to go, but there's not this single one way of describing it. And this is why we need also to move forward as a community, let's say, figuring that out and clearing this methodology chaos a little bit what we have there. One thing which came up recently, we talked about very strongly these days, was SysML v2. Now, SysML v2 came out this summer, and we all know that this has artifacts and elements in there with the textual representation, with the strong component of a data model and a database behind, with APIs which are set up in order to allow this connectivity to other disciplines along the life cycle in the future. So this is a cool step. I mean, I'm not advertising SysML as the only methodology we have on the market. There are many others. Especially yesterday somebody asked, so what do I do when I have a small team of 10 people and so on? And so do I buy this big ecosystem of SysML and all the stuff which is around there? I mean, no, you don't need to do that with SysML. You can apply systems engineering principles and system thinking, and there are also elements, other methodologies and tools available that you can do kind of architecting and you can do your formalization and the model-based activities in a small team too. What you see on the left is that, and I think that's a good example because I mentioned standards earlier, since 7 years this has been developed. 7 years. It took us 7 years to get this. It's a good thing, and it has been done also nicely with involving the tool vendors early and so on. So that was a good journey. However, it took us 7 years. So we need in the future to be much faster on those things. And of course, INCOSE basically was the key provider for that. I think the majority of the team were INCOSE members. A lot of work has been done at INCOSE workshops, INCOSE working groups, and so on. The lead for that was paid by INCOSE to go to OMG for these activities. But it's one of those examples where this OMG standard is mentioning in one paragraph, I think at the end of the document, the nice contributions from INCOSE, and we are not stamped at the same level as a partner, and this is what we want also to change in the future. And what I said here on the bottom right, this is an essential contribution to our strategic ambition, absolutely, to go to a fully model-based discipline. But if I say essential contribution means this is a necessary but not a sufficient step for that. It's only one building block. Now a couple of other viewpoints. Some of them are also from tool vendors. This does not mean that I'm advertising those tool vendors. It's only another rich set of viewpoints we have. So the first one is this here, where this concept of, let's say, the system architecture at the top is breaking down and interconnecting with the architectures at all levels of the disciplines. So that means the process and the refinement is going into all the disciplines, and this is what the digital transformation and the model-based systems engineering is about, so that we are able to connect with all of that. Secondly, here's an example, also from a space example. Virgin Galactic and Bell Aerospace are delivering a project together. where they have really applied the digital continuity across the life cycle into manufacturing and into maintenance, repair, and overhaul. And that is a concept which really provides then the digital twins traveling along the life cycle and iteratively being able to come back to the beginning. One other example I saw 2 weeks ago, and interestingly, and so this is a picture I took from the screen, there was somebody presenting about the role of AI for manufacturing. And in that context, that person was presenting this slide. Holistic systems of digital twins and large language models enable comprehensive models for planning, development, production, logistic, and business processes. They simulate, validate, and visualize different planning variants and thus eliminate planning errors. I mean, this is a system engineering pitch. That guy was not a systems engineer. And out of context, he was exactly, let's say, speaking our language and promoting systems engineering. And this is what I meant with that proliferation we have before, that in many corners of the world, people are doing good stuff, applying system engineering principles, but not being connected at all to our community. This is another viewpoint from Airbus Defence and Space a couple of years ago, where also we have this digital continuity with respect to the data management across the life cycle. We have this notion of digital twins, let's say, traveling across the configuration managed infrastructure. And I just recognized this week when we talk about SysML v2, the database aspect of SysML v2 is the semantic data integration layer in this picture. And the APIs from SysML v2 is the semantic app integration here on this picture. And then the viewers with respect to text and graphical notation, there are some of those, let's say, visualization elements at the bottom. So this context, I think, is also very much a nice point. And this one is from a Chinese automotive supplier, also something I've seen recently. So that's their understanding of the life cycle towards an electric vehicle manufacturing, where also they have this concept of architecture, breaking it down into really various disciplines at software, at hardware level, at electrical level, having this what they call the small V's here, having continuous verification in each phase of the life cycle, and then going into hardware in the loop and until final integration and testing. I think that is a picture which you could easily replace the car by a satellite, because that is more or less what we do through satellite integration and testing. So, some final thoughts on this. I believe systems engineering is the discipline to be the master for the digital future. Because the digital future is not buying a bunch of tools and connecting that. It is about re-engineering the processes of all disciplines in a way that they are better integrated and that they can work more efficiently in an integrated tool set. And with the so-called MBSE stuff we have today, our discipline is now catching up with the others. So we have now formal models available so that we can really going and become model-based as the others. And this is then the basis that we can say we rightly take the responsibility to orchestrate the interdisciplinary digital collaboration along the full life cycle. Before, we couldn't do that. We could try to orchestrate, but we had no means. All the others had nice digital processes already in place. And also, the digital transformation of systems engineering specifically is a key enabler for agile systems engineering. Because agile means you have short sprints, and at the end of a sprint, you have a deliverable. A deliverable cannot be a chapter of a document. A deliverable is an artifact of a model. And so agile systems engineering using models can be then really implemented these days by creating new versions and new artifacts, new variants of the model. And it's totally counterproductive to call this MBSE. I think we need to talk about systems engineering, and it's natural. We also do not talk about model-based electrical engineering. It is natural that everybody is using models these days. And this is also what we do as a discipline. And modeling is necessary, but not a sufficient competent. Not to forget that if you can model, that is only one piece of the cake. And so with that, I have 50 seconds left. I want to say one word on artificial intelligence. And I'm jumping over here. I have a couple of slides you can have in that presentation. So there is artificial intelligence for systems engineering, and of course there is systems engineering for artificial intelligence. But there are one practical example here. So there was a conference where people have put together the overall system engineering lifecycle and then identified in the various points along this lifecycle what would be, from today's perspective and state of the art today, what is the benefit and the functionality, what AI can already deliver today. And of course, at the beginning, this is about requirements. But it's also about generating models, making design traits, and of course generating models and design traits means we can do design traits based on 100 variants versus the 2 variants which we can manually create. And there was also one test here which was provided when we create a system model which typically would take 100 hours, AI assisted, this could go down to 30 hours. While if we talk about agentic AI, which I've heard also once today, this will go down very quickly to 20 minutes. So this shows the efficiency increase and the speed of support we can expect into the future. And this is my last slide. It's saying these are all the things which are interconnected. So when we talk about a digital engineering and systems engineering strategy, we need to put this in the context of an overall system engineering understanding, but interconnected with a data strategy. That is, and the data strategy and meaningful data, structured data, are the basis for applying AI and the AI strategy. AI then supports MBSE and digital engineering, and all of that together is then the breakthrough for a more agile systems engineering process, where we can also catch up into the commercial industry to time to markets which are totally different than we see currently in satellites or other of those products. So with that, I think I'm at the end of my presentation, and I hope I could provide you a bit of the picture of what it should be, where we all should work in the direction, but recognizing there's still a long way for us to go to implement this really. Thank you.
Thank you very much. Thank you very much, Ralph. I don't know, well, it's late. But people stayed, so that means it was sufficiently entertaining or engaging. And I think it, at least it gave me a number of very good inspirations of where we can continue working on and where we should try to increase the coherence of the what has been highlighted in several discussions today. So I hope that that all the discussions will help us to actually create that increased coherence. I don't know if there are any really burning questions, looking also at the time. But Ralph, I understand you're still here tomorrow.
Yeah.
So there will be opportunity still to ask, interact with him or any other experts which you have seen today. So with that, I would like to, in principle, close the session. But of course, since we have all, then if that's going to work, we have all used the Slido tool today very nicely. So what I wanted to do is to ask you a final question today. I'm not sure if I can get that on the screen. Somehow it doesn't work. Okay, well, then I'll leave it for that, and maybe tomorrow morning then at the introduction, and I'll leave that then to Marcel. With that one, would like to close the second day of this MBSE workshop, which was very inspiring for me. I hope also you had a very interesting and fulfilling day, and hope to see everybody of you tomorrow again at 8:30 for the introduction of the team. And I would like to thank also all the people who have supported from the audio, the video, and the catering, and everybody around. So thank you very much, and see you tomorrow.